Hello everyone, welcome to this Data Structures and Algorithms course by Intellipaat. The days are gone when the entry into the global companies was determined by the brand of your college. Nowadays, even companies like Mang have opened their doors to applicants who want to work for them. So what do you think? What is the factor that determines the entry into these big companies? Here is where the roles of data structure and algorithms comes into play. Data structure and algorithms not only play an important role in hiring but also act as an asset that allows a better understanding of more complex things in the world of computers. So if you are an engineering student preparing for placement, then you must already be acquainted with DSA and its importance. To help you crack the next placement drive, our top experts working in companies like Microsoft, Amazon, Google, Meta have curated this comprehensive data structure and algorithm course in Java programming. And I'm pretty confident if you stay until the end of this video, you will gain a great build-up to attempt the next technical interview call for the developer role. Here's what the agenda for this course on data structure and algorithms will look like. We will start by getting introduced to the notion of data structure and algorithms. Then we will look into the basic syntax of Java programming language. After that, we will see how the comments in Java work. Once we're done with the basics, we will do a deep dive into the concepts of variables, operators, and conditional statements such as if-else and switch. Now that we have an understanding about how to do programming, we will start by getting acquainted with data structure concepts such as array lists, linked lists, and their basic operations. Moving on, we will look into the comparison between an array and a linked list. We will also discover the concepts of stack, queue, and sorting in data structures. Lastly, we'll conclude with a set of commonly asked interview questions related to data structures and algorithms. These questions will help you prepare for technical interviews and demonstrate your understanding of the subject in interviews conducted by both startups and large MNCs. But before we move on, guys, don't forget to click on the subscribe button, and if you have subscribed us already, click on the bell icon to never miss out on any updates from Intellipaat. Now let's move on to the course.
So let's begin by talking about what are data structures. Data structures are significant concepts in computer science that aid in developing efficient programs in any language. In general, a data structure is a way of organizing and storing data in a computer program so that it can be accessed and used efficiently. Python is a high-level, interpreted, interactive, and object-oriented scripting language that allows us to explore data structures basics in a more straightforward manner than other programming languages. Using appropriate data structures can help make your code more efficient, especially when dealing with large amounts of data. Now let's look at what are algorithms. An algorithm is a step-by-step technique that outlines a collection of instructions that must be followed in a specific order to get the desired result. Algorithms are often developed independently of underlying languages, meaning an algorithm can be implemented in multiple programming languages. From the data structure point of view, the following are some important categories of algorithms. Starting with search, an algorithm to search an item in a data structure. Sort is an algorithm to sort items in a certain order. Insert is an algorithm to insert an item in a data structure. Update is an algorithm to update an existing item in a data structure. And finally, delete is an algorithm to delete an existing item from a data structure. Now we'll see why are data structures and algorithms important. Data structures and algorithms are important for several reasons. First, they allow programmers to write efficient and scalable code that can handle large amounts of data. Second, they provide a common language and set of tools for solving problems in computer science and related fields. Finally, understanding data structures and algorithms is essential for working with and contributing to open source software projects and passing technical interviews. Now let's talk about time and space complexity. In computer science, there is always more than one way to solve a problem using multiple algorithms. As a result, it is critical to apply a method to compare the answers in order to determine which one is optimal. The method must be independent of the system and its setup on which the algorithm is running. The number of inputs has a direct correlation and can differentiate between two algorithms without ambiguity. There are two such methods used, that are time complexity and space complexity. Let us talk about time complexity. An algorithm's time complexity estimates the amount of time it takes to run as a function of the length of the input. It should be noted that the time to execute is determined by the length of the input rather than the actual execution time of the machine on which the algorithm is operating. Now let's talk about space complexity. When utilizing a computer to solve a problem, Memory is required to store temporary data or the ultimate solution while the program runs. The amount of memory required by the algorithm to solve a particular problem is referred to as the algorithm's space complexity. The space complexity of an algorithm estimates the amount of space required to perform an algorithm as a function of the input length. Now we look at different types of data structures. Data structures are fundamentally divided into two types, that are linear and non-linear. Talking about linear data structures, first is array. An array is a data structure that stores a collection of elements of the same data type in contiguous memory locations. The elements of an array are accessed using an index which represents the position of the element in the array. Arrays are a fundamental data structure in computer science and are used in a wide variety of applications. They are particularly useful for storing and manipulating large amounts of data efficiently, as accessing an element in an array can be done in constant time. In Python, arrays can be implemented using the built-in array module in the standard library or using the more powerful NumPy library. So let's look into implementation of arrays using the array module. The array module in Python provides a simple implementation of arrays that can be used to store homogeneous data. Here is an example of how to create an array of integers using the array module. In this example, we import the array module from the standard library and create an array of integers using the array function. The first argument to array specifies the type of elements in the array, in this case I for integers, and the second argument is a list of the initial values for the array. We can then access the elements of the array using indexing, just like with a list. For example, ARR of index 0 would give us the first element of the array, which is 1. The array module supports several different data types, including signed and unsigned integers, floating point numbers, and characters. Now let's look at implementation of arrays using NumPy. NumPy is a powerful Python library that provides support for multidimensional arrays and a wide range of mathematical operations on them. Here's an example of how to create a NumPy array in Python. Now let's move on to stack. Stack is a linear data structure in computer science that stores a collection of elements and provides two main operations, push and pop. The push operation adds an element to the top of the stack, and the pop operation removes the top element from the stack. Stack follows the last in first out principle, which means that the last element to be added to the stack will be the first one to be removed. Stacks are used in a wide variety of applications such as expression evaluation, backtracking algorithms, and function call management. Now we'll look at the implementation of stack. In Python, stacks can be implemented using an array or a linked list. Here's an example of how to implement a stack using an array. In this implementation, we define a stack class that uses a Python list as the underlying data structure. The push method adds an element to the top of the stack using the append method of the list. The pop method removes the top element from the stack using the pop method of the list. The peek method returns the top element of the stack without removing it, and the empty method checks if the stack is empty. To use the stack, we first create an instance of the stack class. We can then push elements onto the stack using the push method. We can remove elements from the stack using the pop method. We can then check the top element of the stack using the peek method. And we can check if the stack is empty using the isEmpty method. Now let's move on to queues. Queue is a data structure that stores a collection of elements in a specific order. The main characteristic of a queue is that it follows the first in first out principle, where the first element added to the queue is the first one to be removed. A common analogy for a queue is a line of people waiting for a service, such as a ticket counter or a ride at an amusement park. The first person to join the line is the first to be served, and the last person to join the line has to wait for everyone else to be served first. There are two types of queues. A linear queue is a basic queue that follows the first in first out principle, where elements are added to the end of the queue and removed from the front of the queue. Whereas in a circular queue, a queue that uses a circular buffer to implement the queue. This allows for efficient use of memory and faster execution, but requires careful handling of edge cases. So let us now look at the implementation of queue using the queue module. In Python, a queue can be implemented using the queue module, which provides the queue class that implements a synchronized queue. The queue class can be used to implement both FIFO and LIFO queues depending on the argument passed to its constructor. Here is an example of implementing a FIFO queue using the queue class. In this example, we create an instance of the queue class and add 3 elements to it using the put method. Then, we remove the elements from the queue using the get method, which returns the first element that is added to the queue. Alternatively, we can implement a queue using an array in Python. Here's an example of implementing a FIFO queue using an array. In this implementation, we define a queue class that uses an array to store the elements. The enqueue method adds an element to the end of the queue using append method, and the dequeue method removes an element from the beginning of the queue using the pop method. The isEmpty method checks if the queue is empty, and the size method returns the number of elements in the queue. Now let's move on to linked list. A linked list is a data structure that stores a collection of elements in a linear order. Unlike an array, which stores the elements in a contiguous block of memory, a linked list stores each element in a separate object called node. Each node contains both the element and a reference to the next node in the list. The main advantage of a linked list over an array is that it allows for efficient insertion and removal of elements at any position in the list, since we only need to update the references of the nodes before and after the inserted or removed element. However, accessing an element at a specific position in a linked list requires traversing the list from the beginning, which takes big O and time complexity on average, where n is the number of elements in the list. Now let's look at the type of linked lists. Starting with singly linked list, a linked list where each node contains a reference to the next node but not to the previous node. Then there is doubly linked list, a linked list where each node contains a reference to the next node and the previous node. And finally, circular linked list, a linked list where the last node contains a reference to the first node, creating a circular structure. Now let's look at the implementation of queue. In Python, we can implement a linked list using a node class that contains the element and a reference to the next node. Here is an example of implementing a singly linked list. In this implementation, we define a node class that contains the element and a reference to the next node. We also define a linked list class that contains a reference to the head first node. The isEmpty method checks if the list is empty, and the add first and add last methods add a new node containing the element to the beginning or the end of the list respectively. The insert after method inserts a new node containing the element after a specified node in the list, and the remove method removes the first node containing the element from the list. Finally, the print list method traverses the list from the head and prints the elements. Moving on to the next data structure, that is trees. A tree is a hierarchical data structure that consists of nodes connected by edges. Each node in the tree represents a value or element, and the edges represent the relationship between the nodes. The topmost node in the tree is called the root, and every other node is a descendant of the root. Nodes that have the same parent are called siblings, and no nodes with children are called leaves. Let us look at the type of trees. Moving on to binary search tree, where a binary tree where the left child of a node contains a value smaller than the parent and the right child contains a value larger than the parent. This allows for efficient searching and sorting of elements. Next is AVL tree, a self-balancing binary search tree where the heights of the left and right subtrees at any node differ by at most 1. This ensures efficient searching and insertion of elements. Finally, red-black tree, another self-balancing binary search tree that maintains a balance between height and node count. This ensures efficient searching and insertion of elements while also providing a guarantee that the height of the tree will not exceed big O of log n complexity. Now let's look at the implementation of trees. In Python, we can implement a tree using a node class that contains the element and references to its children. Here is an example of implementing a binary tree. In this implementation, we define a node class that contains the element and references to its left and right children. We also define a binary tree class that contains a reference to the root node. The isEmpty method checks if the tree is empty, and the insert method inserts a new node containing the element at the first available position in the tree. The search method searches for a node containing the element in the tree using a breadth first search. Finally, the print tree method traverses the tree in a breadth first order and prints the elements. Let's move on to the next data structure, that is graphs. A graph is a data structure used to represent a set of objects called vertices or nodes and the connections that are called edges between them. Graphs are a flexible and powerful tool used to model and solve a wide range of problems from network routing to social network analysis. Graphs can be either directed or undirected. In a directed graph, the edges have a direction and represent a one-way relationship between the vertices. In an undirected graph, The edges have no direction and represent a two-way relationship between the vertices. Graphs can also be weighted or unweighted. A weighted graph is one in which the edges have a weight or cost associated with them. An unweighted graph is one in which all edges have the same weight. Graphs can be implemented in several ways. One common way is to use an adjacency matrix in which two-dimensional arrays that represent the connections between the vertices. The value in cell ij of the matrix represents the weight of the edge from the vertex I to vertex j. If there are no edge between the two vertices, the value is often set to infinity or a large number. Another way to implement a graph is to use an adjacency list, which is the list that contains all vertices in the graph and the edges that connect them. Each vertex in the list has a corresponding linked list that contains vertices to which it's connected to, along with the weight of the edge. Now let's move on to implementation of graph using adjacency list. Here is an example of how to implement an undirected, unweighted graph using an adjacency list in Python. In this implementation, the addVertex method adds a vertex to the graph and the addEdge method adds an edge between the two vertices. The printGraph method simply prints out the graph in a readable format. Here is an example of how to use this implementation to create and print a graph. As you can see, the output is displayed on the screen. Moving on to hash tables. In data structures, a hash table is a data structure that stores key value pairs in an array-like structure where the keys are hashed to unique indices in the array using a hash function. Hash tables are used to implement associative arrays or mappings of key value pairs where lookup, insertion and deletion operations can be performed efficiently in big O of 1 time complexity on average. In Python, hash tables can be implemented using dictionaries, which are built-in data structures in Python that store key value pairs. Python dictionaries use a hash function to hash the keys to unique indices in the hash table and handle collisions using a technique called open addressing with linear probing. Now let's look at the implementation of hash tables using dictionaries. In this implementation, the hash table class is defined with two methods, insert and get. The insert method takes a key value pair as an input and stores it in the hash table using key as the index. The get method takes a key as input and returns the value associated with that key in the hash table. Now let's move on to types of algorithms. Starting with sorting algorithms. Sorting is a fundamental operation in computer science that involves arranging elements in a collection in a particular order. There are several sorting algorithms that have been developed over the years, each with its own advantages and disadvantages depending on the specific use case. Let us look at bubble sort. It compares adjacent elements in a list and swaps them if they are in the wrong order, repeatedly iterates through the list until no swaps are necessary. Its time complexity is big O of n square and its space complexity is big O of 1. Moving on to selection sort, it finds the smallest elements in a list and swaps it with the first element and repeats this process for the remaining elements in the list. The time complexity of selection sort is big O of n square and the space complexity is big O of 1. Moving on to insertion sort, it builds a sorted list by iterating through an unsorted list and inserting each element into its proper position. The time complexity is big O of n square and the space complexity is 1. Moving on to merge sort divides a list into two halves, recursively sorts each half and then merges the two halves together. The time complexity is big O of n log n and the space complexity is big O of n. Moving on to quicksort picks a pivot element in a list and partitions the list into two halves around the pivot such that all elements to the left of the pivot are smaller and all elements to the right are larger. It recursively sorts the two halves of the list. The time complexity for quicksort is big O of n log n and the space complexity is big O of log n on average and big O of n on worst case. Moving on to heap sort, it builds a heap data structure from the list and repeatedly extracts the minimum element from the heap, which is placed at the end of the list. The time complexity for heap sort is big O of n log n and the space complexity is big O of 1. Next on the list is counting sort. It counts the number of occurrences of each element in a list and uses this information to sort the list. It only works for non-negative integers or values within a certain range. The time complexity for counting sort is big O of n plus k, where k is the range of values in the list, and the space complexity is big O of k. The final algorithm on the list is radix sort. sorts elements in a list by considering their individual digits or bits from the least significant to the most significant. It requires a stable sorting algorithm as a subroutine. The time complexity of radix sort is big O of d into n plus k, where d is the number of digits or bits in the elements and k is the range of values in the list. And the space complexity is big O of n plus k. Now let's move on to searching algorithms. Searching is a common operation in computer science and is used to find the location or value of a particular item in a collection of data. Searching algorithms are used to perform these operations efficiently and effectively. There are several searching algorithms that are commonly used in computer science, starting with linear search. Linear search is a simple search algorithm that works by sequentially checking each element of the collection until a match is found or the end of the collection is reached. It has a time complexity of big O of n, where n is the number of elements in the collection. Linear search is typically used on small collections or unsorted collections. Next is binary search. Binary search is a more efficient search algorithm that works by dividing the collection in half and comparing the target value to the middle element. If the middle element is equal to the target value, the search is successful. Otherwise, the search continues on the left or right half of the collection depending on where the target value is greater or less than the middle element. Binary search has a time complexity of big O of log n, where n is the number of elements in the collection. Binary search is typically used on sorted collections. Next is interpolation search. Interpolation search is a variant of binary search that works best on collections that are uniformly distributed. Instead of dividing the collection in half, interpolation search uses a linear interpolation to estimate the position of the target value. The estimated position is then used to determine which half of the collection to search next. Interpolation search has an average time complexity of big O of log n but can have a worst time complexity of big O of n. Moving on to jump search. Jump search is a search algorithm that works by jumping ahead a fixed number of elements and then checking if the target value is less than or equal to the current element. If the target value is less than or equal to the current element, linear search is used to find the target value within the current block. Otherwise, the process is repeated with a new block. Jump search has a time complexity of big O of root n, where n is the number of elements in the collection. Next is exponential search. Exponential search is a search algorithm that works by first finding a range that contains the target value and then performing a binary search within that range. Exponential search begins by checking the first element of the collection and then doubling the position of the search until either the target value is found or the end of the collection is reached. Exponential search has a time complexity of big O of log n, where n is the number of elements in the collection. Last is hashing. Hashing is a technique used to map a large and potentially infinite set of inputs to a smaller set of outputs. In the context of searching, hashing can be used to quickly find the location of a target value within a collection. Hashing works by taking the target value and mapping it to a specific index in a hash table. The value at the mapped index is then checked to see if it matches the target value. Hashing has a time complexity of big O of 1 on average, but can have a worst case time complexity of big O of n. Now let's move on to graph algorithms. Graph algorithms are algorithms used to solve problems on graphs, which are mathematical structures consisting of vertices and nodes and edges connecting them. These algorithms are widely used in applications such as social networks, transportation systems, computer networks, and more. Here are some popular graph algorithms, starting with depth-first search. DFS is a traversal algorithm that starts at a specified vertex and explores as far as possible along each branch before backtracking. It is implemented using a stack and can be used to check if a graph is connected, find strongly connected components, or detect cycles. Second is breadth-first search. BFS is another traversal algorithm that starts at a specified vertex and explores all the neighboring vertices before moving to the next level. It is implemented using a queue and can be used to find the shortest path between two vertices. Third is Dijkstra algorithm. Dijkstra algorithm is used to find the shortest path between two vertices in a weighted graph. It works by maintaining a priority queue of vertices and their distances from the source vertex and repeatedly selecting the vertex with the minimum distance and updating the distances of its neighbors. Next is Bellman-Ford algorithm. Bellman-Ford algorithm is also used to find the shortest path between two vertices in a weighted graph, but it can handle negative edge weights. It works by relaxing the edges in the graph repeatedly until the distances converge. Next on the list is Kruskal's algorithm. Kruskal's algorithm is used to find the minimum spanning tree of a weighted undirected graph. It works by sorting the edges by weight and adding them to the tree one by one, making sure not to create any cycles. Finally, Prim's algorithm. Prim's algorithm is also used to find the minimum spanning tree of a weighted undirected graph. It works by starting with an arbitrary vertex and adding the closest edge to the tree one by one, making sure not to create any cycles. Let's talk about dynamic programming. Dynamic programming is a technique used in computer science to solve problems by breaking them down into smaller, more manageable subproblems. The idea behind dynamic programming is to avoid redundant work by storing the solutions to previously solved subproblems in a table and using those solutions to solve larger problems. Dynamic programming is especially useful for problems where the solution can be recursively defined in terms of smaller subproblems. Some examples of problems that can be solved using dynamic programming includes the knapsack problem, the longest common subsequence problem, and the Fibonacci sequence. To implement dynamic programming, we need to follow a few basic steps. First, define the problem in terms of subproblems. In order to use dynamic programming, we need to be able to break the problem down into smaller subproblems. For example, if we are trying to find the longest common subsequence between two strings, we could break down the problem into finding the largest common subsequence between each prefix of the two strings. Next is defining the base case. The base case is the simplest version of the problem that we can solve directly. For example, the base case for Fibonacci sequence is that f of 0 equals 0 and f of 1 equals 1. Next is defining the recurrence relation. The recurrence relation is the formula we use to calculate the solution to a subproblem in terms of the solutions to a smaller subproblem. For example, the recurrence relation for the Fibonacci sequence is f of n equals f of n minus 1 plus f of n minus 2. Another technique in dynamic programming is memoization. Memoization involves storing the solutions to subproblems in a dictionary or some other data structure. When we need to solve a new subproblem, we first check if we have already solved it. If we have, we return the stored solution. If not, we calculate the solution and store it for future use. The next important topic in dynamic programming is tabulation. Tabulation involves creating a table to store the solutions to subproblems. We start by solving the base case and filling in the table with the solutions to smaller subproblems. We then use the table to solve larger subproblems until we reach the solution to the original problem.
Okay, so very first thing is, unlike Python, Python is a language where you can just install Anaconda, open Jupyter Notebook and start coding and start executing stuff. That is slightly different in case of Java. In case of Java, what you see over here is a rough syntax of how you can start a program, writing a program in Java. Each of the program in Java starts with public class main method. Okay, so basically every single code in Java constitutes of a class and a method. Class you can assume as a group of methods stored in a particular box. Okay, so class will store one or multiple methods that can be used to execute any statement. Okay, that is going to be the crux, and that is how Java are built. Okay, so that's how you see public class main followed by public static void main. So over here, public means it is publicly accessible. We'll touch upon more on that once we talk about OOP concepts, object-oriented programming. But for now, you can just assume public as something which is not, it's up to the user to, it's publicly available. It's not abstract. It's not hidden. Class defines that it's a class, and main is a class name. Second is public static void, which basically means that it's again a public method. Static means static is something we'll cover in detail in OOPS concept, so you can just ignore that part. Void means the function doesn't return anything. Okay. So in Python, I am assuming if you have already covered, the functions usually return stuff, right? In function, it can either print stuff or it can return stuff, but you do not specify anything that what is the data type of what is being returned. But in Java, once you return something, depending upon what the function is returning, you have to change this particular part. If integer is getting returned, you have to mention over here as int. If something else is being returned, you have to mention here as that data type. And if nothing is being returned, that's where you see void over here. Okay, so what I was saying is, unlike Python, where you just start coding things from scratch, writing and initializing variable, making arithmetic operations, that is something not feasible in Java. In Java, what we do is we start with the main method, which is a class, right? That's a class you have to define, followed by a method. Okay. Don't go into specifics of what each of the words says. Just on a high level, understand that this is a class, and this what we have written, main with a capital M, is a class name, and then the static void is the method, and the main in terms of small letters are the name of the method. String args is something we'll cover in detail once we go to oops. But the main crux and whatever code that you write has to be written within this. So this is going to be the ideal structure for you when you write any code in Java. And over here, you will be writing all the code that will get executed and will be printed over here. Okay, so this is going to be the ideal structure of Java. Now, methods can be multiple. Okay, definitely the name of the methods cannot be same, so this has to be changed. But method could be n number of methods within a class. Okay, so this can go into n number, and each of the code could be doing different stuffs. That could be the ideal structure of Java. All right, but this is going to be the way we'll be using it. And for now, we are not going to multiple methods. We'll be using only single method for all our operations and understanding the syntax. Okay, cool. So moving on to the Java syntax part. The very first thing and the most basic thing to know is how to print. Okay, printing any stuff on Java. Now, to print stuff, how you usually print in Python, you just write print statement, you open the parenthesis, and within that, you either put a string or you put an integer and it gets printed. But that is not the case with Java. With Java, there is a system library that you have to call out. Inside that, there is an out sub-library that you need to call. And within that, you have to call println. Okay, once you call this out, after that, it's more like Python. Whatever you put inside the parenthesis will be get printed. So if I run this, it prints whatever you have mentioned inside the println method, which is hello world. Now, what if I remove println? Let's say I only use print. Let's say, what does it return? It still prints, right? So what is the difference between print and println? Now, difference I can show you once I write one more statement for print statement. On, let's say, over here, I write something first class. Now I try to print. There are two print statements. I'm trying to print both of them. Now, when I print it, what you would see is it appends, correct? It appends one after the other. And then that's the reason println is used to make sure that the second statement, or println basically says, after printing whatever is present in the parenthesis, go to the next line. And once it prints hello world, it goes to the next line, and then it prints the first class. So that's where you'll be able to have two things in different classes. That is about print statement. Okay. All right. So coming to the part where printing text and printing numbers. Now, very similar to Python, we have the same way of printing stuff. If you're trying to print a string, you can print with quotes. But if you are trying to print just the integers, you don't need to put them into quote. Also, if you're trying to print a character or a multiple characters, you can also use single quote. So now if I print it, I'll still be able to see 23. Okay, so this has to be functional character. Let us see. So if you're trying to print a single integer, it will still work because 23 can be printed without quotes, right? So that is about the print statement. Coming to the comments. Now, comments after print, what we can utilize in Java is comment. Now, let's say you have written a large amount of code, which which you have not, which you want to make sure that you can recall it once you use it later on. So what you can do is you can make use of comments. What you can do is below a line prints 23. Okay, and below line prints nothing. So what you can do is, instead of making sure that a person who is not able to understand Java or your code sees your code, they should be able to understand what you are using. Okay, so that's the relevance and that's the importance of printing. Coming to Java variables. Now, I hope variables, the importance of variables, why variables are used is something clear to you, right? So I'll just take, two minutes to introduce you how to initiate variables in Java. Now, what you can do is, for initiating variables in Java, unlike Python, you will have to use a data type. That what data type you are trying to initiate a variable on. I can't just write a equals to 4. I'll have to make sure that a is an integer, right? And also it should follow with semicolon. Without semicolon, you'll get an error. Okay, and then using string, if you're trying to raise a string, you can use string str equals to random string. Okay, that's how you will be able to, write stuff and create variables. Now, with variables, you can do multiple operations as well. What you can do is you can use variables and you can use the variable names to print it. Okay, so for example, I have created these many variables. Okay, now instead of printing directly the integer or anything, what I can do is I can print the variable itself. Let's say I am trying to print 5. What I can do is I can directly use my num and get it printed. Okay, and if I run it, it returns 5. Okay, random string has to be left with semicolon. And once we do that, you would see getting printed as 5. String should be a capital letter. Okay. Okay, so multiple people are asking why we have the first line as public class main, because that is the way of implementing code in Java. In Java, whatever you write is a part of a class followed by part of a method. Okay, and all the code that goes inside the method gets executed. So that is how object-oriented programming is followed in Java. Hence, everything comes under the class and second comes under the method part. Yes, first and second line remains the same, right? First and second line mostly for the most cases remains the same. In this case, both main is the class name as well and main is the method name as well. So don't get confused in that. Main with capital M is a class name. Main with a small m is the method name. Okay. Static void is something we'll cover once we talk to about OOPS concept, object-oriented programming. Once we go over there, we'll be talking about this part. Okay. Objects and methods are same. No, Mayank, it's not the same. We'll cover that part as well once we go to OOPS. All right. So coming to the methods, which is important, which is around Java operators. Now, this is exactly as same as the Python operators as well, which is the operations that you can perform using different variables. Okay, so let's do one thing. Let's cover Java operators and then we'll take 15 minutes of practical implementation part. Okay, so arithmetic operation is as same as what you do in Python. Okay, let's say you're trying to add sum of two numbers. Let's say I already have integer a and my noun. Okay. Okay, guys. So I hope till this point things are clear in terms of print statement and data types, right? We have close to 5 data types, which is integer, float, character, and boolean. Okay. Okay. For the folks who are not clear, I'll re-repeat that and I'll go very, very slow. Okay. Okay, Vaibhav, as I mentioned, string these two lines, please ignore for now, everyone. Okay, because this will be confusing for you for now. What I'm saying is, let's just focus on the inside code and make sure that you're understanding the inside code correctly. Print statement, I hope everyone is clear. This does nothing apart from printing any values or any variables. You can directly put integer, okay? Or if you want to print a string, you can use double quotes and try to print that particular string as well. Okay. Now, if I run it, it will print string as the first line. Okay. And 5 is getting printed from the below one. So you can ignore that. But yes, string can be printed. But if you are trying to print a character, what you can do is you can just put a single quote and print a single character using single quote. Okay, that's what you do. Character and string are not same. String is a group of characters. Character is a single character. D is a character, but if I put a double D, it would not be a character. Okay, you need to use double quotes if you're trying to print a string. This is, I'll come to that, Mary. Just hold on. I'm explaining only the print part. Okay, this is one thing. And second thing is, you can print statements either by using print directly or print ln. If you're using print ln, after printing, that line will go to the next line. And if you're doing only print, that line will stay in the same line. To elaborate on that part, let's say I did system.print.ln and I passed D. And then next line I'm using and I'm printing D again. Now what will happen? 2 times D will be printed, but still since I'm using ln, it will go to the next line. That's why you see 2 Ds getting printed in the 2 different lines. But let's say I remove print ln from the first, and then I try to print it again. Now what will happen? The next line, it would not go to next line after printing. Hence, you would find 2 Ds getting printed in the same line. Okay, that's the way you can use print statements. Usually in the industries, you do not print values directly. What you do is you use num you use variables to send them inside the print method, and then you print it. Okay, so this was about print statement. Coming to variables and declaring variables. So in Java, you have 5 different types of variables that are mostly used. First type is integer. Okay, integer is anything that from -infinity to +infinity and are real numbers. I mean the integers. Okay, float is something you need to define in this way. Okay, 5.99 whatever is followed by f represents that it's a float. That's how you define float in Java. Character is a single character, either capital or either small. Character can also be used via hyphen, slash, different symbols can also be used as a character. Okay. And then the fourth criteria is we have Boolean. Boolean takes 2 values only, either true or false. Okay. And then we have string. String has to be dealt with double quotations, and inside that you can have n number of strings. So moving on, this is the way you can declare variables. Okay, and coming back and incorporating what we discussed for declaring variables and printing stuff, you can print variables using, you can print values using the variables assigned to them. So for example, I want to print 5, but I can directly put 5 over here. Okay, but that is something that is something not the nomenclature, and that's not the way we work in the industries. What you can do is, what you can copy, and you can use the variable name directly over there. So these all part, I hope, is clear to everyone. All right. Now we'll move to a part where we will be discussing about operators. Operators are nothing but, it can help you to perform arithmetic operations, logical operations, or comparison operators. Okay. The very first thing is arithmetic operation, which talks about different operations like addition, subtraction, multiplication, division, modulus, increment, and decrement. Okay. Arithmetic operations, addition, everybody knows. Example, x plus y, that is the most basic arithmetic operation. Second is subtraction. Two numbers you can subtract, and that's another arithmetic operation. Third is multiplication. Fourth is division. Fifth is modulus. Now, modulus is something, if I put a modulus b, it will return me something like what will be the remainder when 5 is divided by 2. Okay, that is called the modulus. It returns the division remainder. So if you put 5 modulus 2, it basically means return the remainder you got after dividing 5 by 2. Okay, that is modulus. Okay, second is increment. Increment is as same as, let's say I am trying to do x plus plus. X is a variable. Let's say I have defined int x equals to 2. Okay, and I'm doing x plus plus. This statement is as same as doing x equals to x plus 1. So basically, increment increments the same value by 1. Similarly, if I do x minus minus, it basically means what I'm doing is x equals to x minus 1. Okay, so I hope all these arithmetic operations is clear to everyone. Okay, next coming to assignment operator. This assignment operator we have already been using, and what is this is, you don't have to go through all the complex part. You can just understand this operator for now, and rest of the things will come to you over time as well. Okay, assignment operator basically means just the way we are doing it, just the way we are assigning value to a variable, we are using an assignment operator, right? That is all about an assignment operator. You assign values, and it is not just true for variables getting assigned a value. It can be also dealt in a way where you initiated a second integer called b and assign the value of a into it. So assignment can happen between two variables as well. So what I'm saying is, if you initiate an integer xyz anything and assign it to a value, and you want to increment that value by 1, obviously this is one approach, you can take it. Or if you want to decrement the value of that integer by 1, this is the second approach, you can take it. But by using x plus plus and x minus minus, you can achieve the results in a shorter time. Shorter time as in it's a quick way, a shortcut kind of a stuff, which means the same, but it can be implemented in this way as well. That's all it is. Okay. So we have covered the assignment operator as well. Coming to comparison operator. Okay, comparison operator basically means you compare two different terms. Or let's say, before we go to the comparison operator, we have already spent 45 minutes. Let's try to have a practical implementation of, just try to have a practical implementation of whatever we have learned so far. And the first question is print a statement with your first name in the first line and second name in the second line. Okay. One thing is for sure that you don't have to worry about the two lines. You have to deal with only this bunch of lines of code. Okay. So it's very simple. I have already discussed about print statements, right? So system.print, and you have to do in the second line. So print a statement with your first name in the first line and second name in the second line. Okay, that's the reason you have to use print ln. And what you can do is, let's suppose your name, let's say first name is MS, okay, and second name, let's say, is Dhoni. So let's use print ln and put Dhoni over here. Okay, what will it do? It will print the first name MS and it will go to the next line and print Dhoni. Okay, it's as simple as that. Let's try to execute this code. And we see over here, first name and second name getting printed in two different lines. Second question is print a statement with your first name in the first line and second name in the same line separated by space. Now you don't have to change the line. So what I can do is I can remove the ln statements from here. Now if I print it, both the ones will be printed in the same line, but I want it to separate by space. What I can do is I can add a space after the first name, or I can add a space before the second name. Anything will work. Now if I run it, it will be printed in the same line separated by space, just like this. Okay. Third question is create two variables, one as integer, other as string of any value, and print them both in separate lines. Okay. So what it is saying, create two variables, one as integer. So integer, let's say a equals to 5. What did we do over here? We created an integer called a and we assigned a value of 5 to it. Okay. And then other string of any value. So we create a string, let's say string b, and we assign the value of, let's say, anything, let's say session 1. Okay. And then print them both in separate lines. What we can do is print ln and then do print ln. And in the first line, we pass a. And in the second line, we pass b. So what did we do over here? We created two integers, two variables, integer and string, assigned a random value and printed them both in separate lines using print ln. Now, if I print it, I'll get 5 and session 1. Okay. Next is create two integers, print sum of two integers using print method. Right. So create two integers. Now let's remove string b, and instead of that, let's say I created integer b and assigned a value of, let's say, 4, and remove the print statement as well. Please explain 3 again. Okay. Okay. Question was create two variables, one as integer and other as string of any value. Okay. Two variables, one as integer and other as string of any value, and print them both in separate lines. What did we do? One as integer, we created first variable as integer, other as string of any value. So we created string and assigned any value to it, and then print them both in separate lines. And we tried to print a and b using separate lines. We used ln, print ln. Okay. Okay. Next question is create two different variables. So let's say we created a and b, both integers, and print the sum of two integers using print method. One way is to you create a third variable called int c, and then you use a plus b, just like the arithmetic operations which I mentioned. You use a plus b, and then while printing, you just print c. Okay. Now, if you execute it, okay, semicolon is missing. Now, if you execute it, you will receive the sum of 5 and 4, which is 9, right? Other way is you can remove this part and do directly inside print statement itself. You can do a plus b inside the print statement itself. So both of a and b being integers, they will print the summation of a plus b, which is going to be 9. Okay, I hope it makes sense. Second is create two integers. Okay, this is done. Fifth question is create two integers and print the incremented value using print method. Okay. So either it could be two integers or one integer as well. Let's say two integer itself. Int b equals to, yes, by applying double slash, you can comment out the line. B equals to 4, and then using increment, I can print incremented values of both of them. Right? Like this. A equals to 5, B equals to 4, and using plus plus sign, I can print incremented value of both A and B. Okay. And if I execute it, it will print 6 and 5. It got incremented by 1. Okay. That's a cool thing to explain. Okay. Now, how does increment works is it works two ways. Either it works in the way where plus plus a, there are two types of increments, plus plus a and a plus plus. Okay. And if you use it in the print a plus plus, what will it do? It will print a first and then increment it. Okay. And in this plus plus a, what it will do, it will increment the a and then print a. Okay. So this is called pre-increment. Before performing any action on a, the increment will happen. And below one is post increment. After performing action on a, then the increment will happen. Okay. So with these two logics, to achieve our desired result, we need to do plus plus a and plus plus b. Okay. Now, if I execute it, it will give me the result of 6 and 5 after incrementation. All right. Last question was find modulus of 5 and 2 and print the same. Modulus of 5 and 2. Let's say I assign a to 5 and b to 2. And then let's find the modulus. Modulus would be a mod 2. Sorry, a mod b. I should get the answer of 1 because remainder is 1. Modulus is nothing but it gives you the remainder value of what you have done. According to the remainder, it will give you the value. Next thing, what we want to cover is comparison operator. What is comparison operator? The comparison operator is you can compare two different variables. Let's say I have, let me remove all this. Let me just close it out and do it this way. Let's say I have x equals to 5 and y equals to 3. And system is trying to print x greater than y. And this will return true if because 5 is greater than 3. If I return this, it will return me true. Okay. Why? Because 5 is greater than 3. If I do the opposite way, x less than y, it will return me false because x is not actually less than 5, less than 3. Okay. The third kind of operator is double equal to. In these operators, you can actually compare two different variables. Okay. And the comparison operator, unlike any other operator, will always return you Boolean value. Okay. It will always return you either true or false. Now, these are the 6 different operators that comes into picture. First is double equal to. This equates the variable x with variable y. Second operator is not equal to. Okay, x not equal to y. So basically, instead of double equal to, if I put x not equal to y, what do you think will be the return type of this particular statement? If I execute it, will this statement return true or will this statement return false? Absolutely, it will return true because x is genuinely not equal to y. Okay, so that's what you see over here as true. Second is greater than, which is as per the logic, greater than are the ones. Then next is less than. After that, it is greater than equal to, and after that, it is less than equal to. Okay, so these are comparison operators. Next comes is logical operators. So you can apply comparison operators with multiple comparison operators. So logical operators can be applied it in this way. For example, let's say, let me just take it whole over here itself. Okay, let's say x equals to 5 or x is already equal to 5. Now we are trying to do is x greater than 3 and x less than 10. What do you think the value of this expression will be? Everyone, what do you think the value of this expression will be? True? Absolutely. What if I do this? Okay. What will be the value now? False. And now what if I do this? Some people who are already aware are able to answer. Okay. So for the people who are not exactly clear, you have three more different operators with which you can join the comparison operators. And these are logical operators. Okay. How you can join is, the first is AND. So this is very similar to the set operations that you might have studied in your class 12th, right? AND operation. AND operation means if both left-hand side and right-hand side are true. If both of these sides are true, you will return, it will return true if the middle connection is through AND. Okay. Or if either one of them are true and one is false, if one is true and one is false, this will return false. Only if both are true, AND operation will return true. If any one of them are false, that will return as false. But if I put the OR operator basically says even if one of them are true, it will return true. And if one of them is false, it will still return true unless and until both of them are false. It will only return false in that case. So basically AND operation will return true only when both are true. OR operation will return true even if one is true. Okay, that is the case. And then there is a logical NOT. NOT basically means if I applied something like this is basically a negation. It converts the underlying expression to its counterpart. If this expression is already true and I have applied a negation, it will return me false. And then if this statement is true, if this statement is false and I applied negation, it will return me true. So opposite, basically it makes the value opposite. Okay. The first question was compare first and second. I mean, you need to take two integers and randomly assign them values. So let's say two integers that have been taken with num1 equals to 2 and num2 equals to 10. Okay. The first question is compare first and with second and return the Boolean value. So basically all you have to do is compare it with num1 greater than num2. I mean, it's okay if you're doing less than or greater than as well. The point is you should be able to compare num1 and num2 and print the result. Okay, that is number one. Second thing, check if they are equal to each other. So you're doing println num1 double equals to num2. If you're doing this, that's also fine. Or if you're doing not equal to, that's also fine. Okay, depending upon that, answer will change, but basically you are comparing if they are equal to each other or not. All right. Third question was, check if num1 is greater than 10 and num2 is less than 5 and print the result. Num1 greater than 10 and num2 less than 5. So we have and in between, right? That's what the question says, that you have to be put, check if num1 is greater than 10 and num2 less than 5. That's how you see and over here. Second was fourth one was print the negation of this expression num1 less than 10. So you use num1 and then you use the negation to print the negation of that statement. Okay. And the last one was print the value of negation of num1 greater than 3 or num2 less than greater than 10. So num1 greater than 3 and num2 greater than 10, followed by a or condition and a negation. Okay. Now, if I execute this statement, what will I get? I get all the answers. Okay, I need to remove that. Okay, these answers might change for you depending upon what is the expression you have used. Okay, but overall, you should be able to get 5 Boolean values and this one. So Java strings, we will cover string length, how to calculate string length, how to convert the string into uppercase character or to a lowercase character, and how to find the character in a string. These 3 things will cover as part of strings. The first one is most simple, is about checking the length of the string. Okay, how to check the length of the string? It is as simple as txt, whatever name you give to the variable. So string variable, you use txt as the variable name of that string, followed by .length, length. Okay, so this is the way you can very well use the expression to check the length of any string. Let's suppose, let me remove this part and let me add another string. String str equals to, let's say, Shubham. Okay, now I want to check the length of the string which I have initiated as Shubham. str.length. Now if I print it, it will give me an integer value that will be equal to the length of the string. Okay. Okay, I'm not sure why is it taking time to compile. What happened? 1 second, guys. I think there is a problem in IDE. Okay, you need to print it out. So basically this will give you the result, but you have to print this out. Okay, so it says 7 because the length is 7. So this is all about the length of the string. Coming to the second part, which is around converting the string to a lowercase or uppercase. That's a very interesting fact. You create a string, string text equals to hello world, and then you do system.print.out. I mean, that's for printing, but just by appending dot to uppercase or dot to lowercase, you can convert that particular string into lower cases or uppercase. Okay, it is as simple as that. Okay, so don't worry about other stuff. It just converts all the characters in that string to uppercase and all the characters in that string to lowercase. Okay, so it is as simple as that. Okay, now when it says system.print.out text.index of locate, okay, what does it say? Index of is a function that looks for a particular character in a string, okay, or a particular sequence of character in the string. It basically returns that at what position a particular string is present in that particular string. That is what it says when it says index of. That in a particular position, what is the position of that? Let's say I'm trying to search for locate. What it will do is it will start iterating from the first place. And just like any other programming language, iteration starts from 0. Python starts from 1. Python programming language for iteration starts from 1, but for Java, it starts from 0. So basically, if I start from 0, it will be 0, 1, 2, 3, 4, 5, 6, 7. So at 7th index, it located the start character of locate. Okay, it's a sequential search. Yes, it starts from the start and it looks for the character where it can search for this particular character, and hence it returned 7. Just now I explained, Krish. Okay, so ignore the print statement, just focus on this part. What it is trying to do is text is a string. Till that, I hope it is clear. Okay, text is a string and we have initiated that string, given it a value as this one. Please locate where locate occurs. And then on that text, we are using this particular function, dot index of. This function is trying to look for this particular piece of characters, which is locate. How does it do? Once you execute it, it returns you an integer value, which is basically the index. Okay. And hence it starts from this place. Starts from the beginning. Every single character, Vaibhav, yes, every single character will be counted, guys. Even the space will be counted. Every single character gets counted. Okay. So while calculating index, space, right, whatever is inside this double quotes, every single thing will be counted. Okay. So basically 1, P is 0, then L becomes 1, E becomes 2, 3, 4, 5, 6, and 7th. So 7th place is the place where locate starts. And hence you see 7 getting returned. It looks for a particular start, looks for the starting index of whatever you have kept over here. If I remove locate from here, and now I execute it, answer will be different. Answer is 14. Let's calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It reached to the start index, right? After counting the single quotes as well. So that's how it works. Sir, please change locate into where? Huh? Please change locate into where? What is that? Achha, locate into where like this? It became 7 because we remove the previous locate, right? So these many characters constitutes of 7. So it's 7th index, it starts. Where starts from 7th index.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards a career growth with the full stack developer course.
We talked about very first thing about printing any statement in Java. So we talked about print statement and print ln statement, which is print line. Okay, that was the first thing we discussed. Second thing, we talked about how to put comments in Java, which is as simple as just using 2 forward slashes and you can convert that statement as a comment. For multi-line comment, what you can do is you can start with / followed by a star, and then you can end with a star followed by a /. So that's how you can have a multi. So this is for multi-line comment. Next we discussed was about variables. So we learned how to create variables. If it is a string, how to create that, and also if it is an integer, how to create that. And we saw close to 5 different types of variables, which are string, integer, float, character, and boolean. Okay, we also used variables to print a value of that variable rather than directly printing the value. And then we went to operators. We discussed about arithmetic operations. Okay, addition, subtraction, multiplication, division, modulus, increment, and decrement is something we discussed. And then we saw assignment operator, how you can use assignment operator to assign left hand variable the value of the right hand part. Okay, moving on, we saw multiple different operators as well around comparison operator, which is equation operator if you're trying to equate 2 different variables, or not equal to operator, greater than operator, and less than operator. We also have greater than equal to and less than equal to. Next, we followed Java logical operators, where we saw AND operation, OR operation, and negation operation. So these operators are used to combine multiple statements like the example given over here, right? X less than 5 and X less than 10, X less than 5 or X less than 4. Okay, we discussed in detail about how will this logic will be evaluated, and we discussed that in detail. And the last thing we discussed was about strings, the length of the string, and converting the string to uppercase, lowercase, or finding a character in the string. So these all part we discussed yesterday. Anyone has any kind of doubts so far in whatever we have discussed till yesterday? You can just mention if you have any doubts. Okay, any kind of questions you have, you can just mention over there. All right, so if there is no doubt, we'll start with concatenation. Today, we'll start with string concatenations. Now, string concatenation is nothing but joining 2 different strings. Okay, imagine, let's open this. What we have over right now is 2 string, John Doe. Let's say it's the first name and the last name. And let's say we want to print both of John and Doe in the same line. Now, one thing we did yesterday was we used 2 print statements and we removed ln so that it prints in the same line, right? But what if you want to use only one print statement and print both John and Doe? For that, you'll have to concatenate string. You'll have to add the strings. And that's how you add a string. You do simple plus operator, works by adding the string. The middle part that you see is used to add a space between first string and the second string. Okay, that's all concatenation is. It just uses the addition operator to join first string with the second string. Okay. Now, the second way of concatenating it is this way. Let's say you have 2 strings and you want to concatenate. Instead of using directly the plus index and followed by a space in between, what you can do is you can use a concat function itself. Now, this concat function, what does it do? It joins, it acts as a method of a string. So first name over here is a method, and .concat is a method applied on that string, and the parameter passed in that method is another string. Once you do that, automatically both the strings are concatenated, and also there is a space introduced between both the strings. So you need not go through this particular path of adding a space explicitly. Okay, that is it was a very small topic about concatenation. So this is something you should keep in your mind. Okay, next thing is you cannot add integers with strings. Okay, For example, let's take the same example where we were trying to add using plus operator. Okay, let's say first name is John, and it's both it's a string and it is also a string. Now let's say I create a new variable called integer a equals to 59, let's say. Okay, now I try to add a string with an integer. Since a is an integer, I'm trying to add first name with an integer. Let's see what happens. Okay, system.out.println first name plus a. Let's see what happens. Okay, so it added both of them, even though we have an integer over here. Can someone explain why? Even though it was an integer, once we did addition, a added. Okay, so here is the logic. String is something that precedes in terms of priority. Let's say if I try to add a float and an integer, answer might come as an integer because integer precedes in the priority. In the same way, string precedes in the priority. So if you're trying to have a plus operator in terms of adding a string to an integer will automatically be converted into a string and it will be concatenated, right? But now this string, that 59 string that you see as part of the result, will no longer be an integer. It will be a string itself. Okay, it's a part of a string, and it is now if I break it and get the last two last two segments of this particular string, it will come as a string. Okay, so that is the way you can handle string additions as well as adding string with an integer. Okay, so special character is something we can skip that for now. Now, so far, whatever problems we had done, so far, whatever we discussed was more about creating a variable and adding a demi variable on top of it. Okay, now if you want to take input from a user, right? Let's say you do not want to put a dummy data into a variable. You want to take an actual input from the user. How will you do it? For that, there is a very simple method to do it. Okay, for the sake of not getting confused, let me remove certain parts. Okay, it's already executing. Let me just do. Okay, so if you see over here, we did not use a random value of the variable by putting it into the code. What we did was we took an input from a user. Or let me just explain the code first of all. What are we trying to do over here is we are trying to print a username. Okay, last line basically prints a username, but we are not defining username in the code. What we are doing is we are first importing a package that can help us to accept input from a user. And that package is java.util.scanner. You need to remember this. Java.util.scanner is a package that can help you to import the scanner class. After scanner class is created, you need to create an object of the scanner class. Okay, now this object word might be confusing to you, okay, because we have not covered the oops concepts. Okay, but for now, I would just like you to understand it for now, that this is the process. Once you import a package, you can't just directly use the package. You have to actually create a replica. You can just imagine object as a replica of what is already present in scanner. So scanner contains all the code that can help you to take input from the user. And by creating an object, you are creating a replica of that scanner package. How to do it? You can do scanner my object. This name could be anything. New scanner system.in. Once you do that, you can leverage my object obj to accept any kind of input. Okay. So string username is something we have defined a variable called string, which is username. Okay. And using that username, we are trying to get the input from a user. All right. Or just understand in a way that this whole code is intended towards just making you understand the way you did the system.print.out, system.out.print. Why do print stuff, right? You did this to print stuff. Just opposite way you need to do to accept stuff from the user, right? Taking input is something you need to do just opposite. So that's where you need to import this class, and then using the creation of object, what you can do is you can accept the user input through my object.next line. Okay. Is it getting confusing for you guys? Shall I push this topic to a later segment, or is it okay? You'll be able to understand, because I know object has not been covered. So you will have to just memorize the way we are doing it. We'll do it later. Okay. Okay. So for now, I think whatever we have covered, we'll be using dummy variables to create it. We'll use the input for the later segment. Okay. So let's continue with the current topic. Okay. So next topic we have is maths, the math library that we have in Java. Now, maths library has n number of functions, but I'll just cover what is usually required. Okay. And it's a very simple, you don't have to, put much effort into that. So mostly there are 4 different math methods that are required. Okay. First one is, all right. So maths module has mostly 4 main methods. Okay. You would not be required to go beyond those 4 methods. First method is, let me remove this system.out, or let's say, let me create integer a equals to okay. So the first method is the max method. For calling the math function, you don't have to import any package because it is already included in all the classes of Java. So math, you call the library math and you invoke a method called .max, and you pass 2 parameters into it, right? Between which you want to judge the maximum. And then you assign that max value to integer a, and then you print that integer. Now, if I run it, the answer I will get will be 10, because between 5 and 10, we have max as 10. Now, what if I pass only one value? What will happen in that case? I do not pass 2 values. Okay, now is it fine? The code size, guys. Now, when I pass one value, it's saying not suitable method found for max, because it needs at least 2 values. Now, let's say we pass 3 values. What will happen now? So again, it says no suitable method found for max, because you cannot put more than 2 elements in the math function. It should be only and only 2 functions. And also it says math method had 4 types. Either you can say send 2 integers, 2 long data types, or 2 floats, or 2 double. But the number should be always 2. All right. So making sure that this is always 2, that has to be done. Now, other function that needs to be executed is min. Okay, that's the second function that you should make use of. Minimum is as same as maximum. It will, yes, input is limited, Farooq. So what if we need for more than 2? You'll have to do a nested. So let's say you have to compare max between 3 numbers, as I mentioned, right? 5, 10, and 12. What would you do? You will use a nested max. Yeah. Now, if I do it, the max function will be executed twice. One for the inside and one for the outside. Now you will get the answer as 12. Okay. So that's a limitation of max function. That's why it's not as famous as other methods that we have, but that's what it is. And for min, it's as same as 5, 10. And then you do it, and then you get, sir, module and method are same. No, method is, let's say for math and min, maths is a module. Math is a module. So module has already been built and it's there in the Java library, Java package. Using math inside modules, we have multiple methods. And that's what we are using min as a method. Okay. So max and min are 2 different topics. Next, we have square root. So it's as simple as whatever you do. dot sqrt, it gives you a square root. So let's say I want to see a square root of 25. I should get an answer of 5. Okay. Now if you try to send someone which is, what happened? sqrt 25. What did I do wrong? Did I miss the braces? What does it say? Okay, so it's a loosely conversion from double to int. So to fix that, let me take this part as well, and then let me directly print it, because that was an integer data type, hence it was giving error. Okay, because usually square root returns you in a double, and you need to typecast it to int, so you need to extra typecasting. Okay, so these are the main three functions of math. And then last one is absolute value, which basically gives you the absolute value instead of, giving you, if you pass a negative value. Absolute value is basically removing the negative element from it. So that's what it is. Usually we do not use math function, but in case you are required to use it, you should be aware of that. Hence, we covered that part. Now, coming to the heart of this session, which is going to be the crux of next 1 hour discussion, the loops part. Okay, loops part and the conditional statements. So make sure everything we have learned in the last session is very up to date for you all, because this session, even the questions that I will be giving you will be mix of easy, medium, and hard. So the people who already have an accustomed understanding of Java will have to spend some effort to make sure they're able to solve questions. Okay, cool. So if statement, this particular next 15 minutes, we'll talk about 4 different segments, which is if statement, else statement, else if statement, and switch statement. Okay. Now, before I talk about anything, regarding if statement, the only thing I want to tell you is using a real world example. Okay. Let's say you're stepping outside your house and I tell you, take umbrella. Okay. That's a simple statement. I'm asking you to take umbrella, and then I expect you to execute it. I mean, I expect you to take action according to my statement. But what if I tell you, if it is raining outside, take umbrella, right? Now, what will you do? You will not directly follow my decision, follow my words and take the umbrella. What you would do is, you would check if it is raining outside. If it is actually raining outside, it's a condition, then you will take umbrella, right? That's exactly how we make our code work for if statements, right? You see over here the syntax. It basically contains a if condition followed by if word followed by a condition. Now this condition should always return a Boolean. If this condition is not returning a Boolean, it doesn't make sense. I mean, you will get an error. So this condition should always made and written in a way that this returns a Boolean value. And depending upon Boolean is true or false, it will execute the second block of code. Okay. For example, very quick example, if 20 is greater than 18, print 20 is greater than 18, right? And now what if I say, okay, font size is getting a problem. Are you guys, Jay, are you on the phone, mobile phone, or are you on the laptop? Laptop. Okay, still you are facing this problem. Okay, I'll make sure that every time I go here, I'll increase the font size. Okay, so this is the if statement. So every time you get a positive answer from this if statement, you execute the next statement. Now, what if I make this statement to be false? What if I make it equal to, if 20 is equal to 18, print the statement. Now what will happen? Nothing will get printed, right? Because we are only saying that if this statement is true, then only execute the statement. If it is raining outside, then take the umbrella. Okay. Now let me change again the statement while you are stepping out of the house. Let me change the statement a bit. What if I tell you, if it is raining outside, take umbrella, else take my parcel with you, or anything. If it is raining outside, take umbrella, else take this parcel with you. Okay, so now you will not directly take the umbrella, or you would directly take the parcel which I am giving you. What you would try to understand? First, the if statement clause. Is it raining outside? If it is raining outside, you will take the umbrella. If it is not raining outside, you will take the parcel which I'm asking you to. Right? So what happened here? I gave you a second option if the first condition is not true. And exactly doing that, let's say I have created an integer called time, right? And the time is equal to 20. Then only if is enough to run the condition statement. So else is not mandatory. Absolutely not, hurry. Else statement is not at all mandatory. It is only required if you want to execute a statement if the condition is false. Okay. So integer time equals to 20. I have initiated an integer called time and equated it to 20. And then I'm putting a condition over here that if time is less than 18, then print this statement, good day. Or else time, if it is not less than 18, if the statement is false, it will print good evening. Okay. So over here, what it should print? Definitely 20 is not less than 18. So it will print good evening. That's how you see over here. Okay. So that is about if else statement. Now let's come to another clause. Let's say same condition. I'm saying you, if it is raining outside, take umbrella. Else if it is sunny outside, take sunglasses. Else take my parcel. Now what I have done? I have applied two conditions. First condition is if it is raining outside, take umbrella. Else if it is sunny outside, take sunglasses. Or else, if none of the above conditions are true, take my parcel with you. Right? So it's a nested conditions. It's a list of conditions. How will we do that? Again, going by the time example that we had, integer time equals to 22. We created a time, equated a value with 22. Now, what we are doing over here is three conditions. First, if time is less than 10, print good morning. Will this be printed? No, because time is not less than 22, because time is 22, right? 22 is not less than 10. Okay, is indentation mandatory in Java? No, no, Yaman. It's not mandatory in Java. It was only mandatory in Python. And the second is if else time is less than 18. Again, time is 22, so it's not less than 18. Hence, this statement will also not get printed. And finally, if none of these conditions are true, we'll print good evening again. So that's how if, and else works. Okay. I hope there are no confusion. In case there is, please let me know. Okay. Now coming to a switch statement. We talked about if else statements. Coming to switch statement. Now, switch statement, let me just go back to that example again, which I was talking about the raining part. Let's say when you are stepping out, I say, in case it is raining, take umbrella. In case it is sunny, take sunglasses. In case it is cold outside, take my jacket. In case it is a snowfall happening outside, take snow caps and snow gloves with you. In case it's windy outside, make sure you put on your helmet while you're driving, anything of that sort. Or in case it is stormy outside, don't go out. Now, what did I do over here? I put a lot of conditions while you were going out. I gave you n number of cases. If it is sunny outside, if it is raining outside, if it is winter outside, if the storm is there, if it is windy, right? Now, if you start writing if else statement, you might be able to achieve the goal, right? But it will be a lot of same repetition of if words, if else case and all that stuff. Instead, why not I do something like create a condition that can give me the weather of outside, like condition weather. What is the weather outside? And depending upon that answer, I create the case. Now it will be more clear if I tell you with the help of an example. Now let's say there are 7 days in a week, right? 1, 2, 3, 4, 5, 6, 7. One starts from Monday, Tuesday, Thursday, Friday, and Friday, right? Let's say I am trying to print the day 4. What would be day 4? Day 4 would be Thursday, Monday, Tuesday, Wednesday, Thursday. Day 4 is Thursday, right? I'm trying to print Thursday, but I know I know day is equals to 4, and I'm trying to print which day 4 is. Now, one way is to have multiple if statements, that if day equals to 1, print Monday. Else if day equals to 2, print Tuesday. Else if day equals to 3, print Wednesday. It can go on and on. Or the other case could be using a switch statement. What will switch statement do? Switch statement takes a parameter, and in this case, it's not a Boolean expression. The switch statement doesn't take care of Boolean expression. It takes care of a value. Parameter of switch statement is always a value, and that value is equated with cases. So you create case, and automatically switch statement will equate the value of the parameter with the case. So these are not case numbers. Don't get confused with these as case numbers. These are values. Okay, these are values, and with this value, day will be compared. So day 4, value of day is 4, and this will be compared, and Thursday will be printed. Now, if you see, there are break statements in between. Okay, that's very common in case of loops, and switch statement is the best way to talk about breaks. Break is basically saying that once you come over here and execute this particular statement, once you see the break, come out of the loop. No need to recheck or do anything. Come out of this loop and go over here. It's as simple as that. So whenever you see break, make sure you can understand that code will automatically go to the next line after the next parenthesis it has. So once it sees break over here, it sees the parenthesis over here, and it goes here. That's how you can understand breaks. Okay, so next example, if I give you, so that it makes you clear that it's not a case and also a default value. Let's use the same example. Suppose, okay, let me change day to 72. Right, there is no day called 72. Let's see what does it do. For that, if I execute it now, nothing will get printed because none of the cases are matching with the day value. So in those cases, what we use is we use a statement called default. Okay, let me copy over here only. Default will say looking forward to next weekend, or anything it can say. Basically, it says that it has not received any value that is matching with the cases. So in that case, it will just return looking forward to the weekend. All right, so we'll start with the first problem. Okay, the first problem is write a program, Java program, to check whether a given number is even or odd using if-else statement. Okay, let's just try to understand here what is being done. So very first thing is you initiated a variable, and you the variable name is a, and you initiated with any random integer. Over here it's 4. Okay, that's all. And then problem was check if that number is even or odd. Now the best way to do it, you remember we discussed one of the arithmetic operation, which is modulus. What does modulus do? Once we do a modulus of a number with other number, it basically returns the remainder, what you will receive once first number is divided by the second number. And what is the property of even number? The property is once it is divided by number 2, it would return you remainder 0. And same thing has been leveraged inside this particular statement. And if you remember, we discussed inside if condition, inside if statement, the condition should always return you a Boolean value. And this a modulus 2 double equals to will make sure it's a logical operator, and it will return a Boolean value depending upon the expression. So basically this expression is saying if a is divided by 2 and the remainder is 0, return true, else false. When the remainder is 0, that means the number is even, and when the remainder is not 0, it means the number is odd. Okay, so quickly we'll come to the while loop. First of all, in general, if I talk about loops, right? So previously, when I was talking about if-else statements, what criteria I gave, what example I gave, that if it is raining outside, take umbrella, else take my parcel and go away. And then multiple if-else is, if it's raining, take umbrella. If it is sunny, take sunglasses, else take my parcel, right? So those were one statement. The job has to be done once. Taking umbrella has to be done one. It's a single time doing an action. But loops are something where same action is repeated over and over time. Okay, let's say I tell you, keep stirring the water till the time you see all the salt getting mixed, right? So stirring the water even right now over here is an action. And I have said, keep doing it till the time you see all the salt which I have put in the water is mixed and you can't see any more salt, right? So that is the condition. And that is the loops part, where same action is repeated again and again till the time a particular condition is met. That is loops. Now loops are two types. First one is while loop and second one is for loop. Okay, so we have first one as while loop and second one as for loop. First, we will be discussing about while loop. Okay. Now let's see this particular scenario. Initiating a variable, I think most of you are comfortable in doing this. Integer I equals to 0. Now what it says, while integer I is less than 5, while I, the value of I is less than 5, print I and then increment I by 1, I plus plus. Now when I execute it, it will give me everything from 0 to 4, because once I becomes 0, this is true. This gets printed as 0 and then I is incremented by 1. So I become once, I became 1, 1 is still less than 5. So again, this statement is printed till the time I becomes 4, 4 is still less than 5 and 4 gets printed, I becomes 5. Now when I is 5, this statement becomes false because 5 is not less than 5, right? So this statement does not get printed and while loop exits. Correct? You guys tell me, what if I want to print 5 over here? What is one small change I can do? I can do multiple changes, but let's say I want to print from 0 to 5. Okay, Hari is saying I can use less than equal to 5. I can replace 5 with 6. Both the answers are absolutely correct. If I do less than equal to 5, fifth condition will get executed and then I will see 0 to 5. And other way around is I can use 6 till the time I is less than 6. Pre-increment. Okay. I like these kind of answers as well. So Shafak, I'm not sure how to pronounce. It's like Shafak is saying, instead of I plus plus, what do we do? Plus plus I. Second, guys. Okay, plus plus I will not help over here unless and until you put 6 over here, because even though increment is happening before, I is taking care of what the final value of I is. Okay, so this was while loop. Any confusion in while loop, guys? Anything that you want to discuss? We can discuss one more problem or one more thing. Let's say I want to print even numbers only till 50. I want to print even numbers till 50. What can I do? I'll put I equals to 0, I less than equal to 51, or let's say I less than equal to 50. And instead of I plus 1, I can what I would do is I equals to I plus 2. So every time this is executed from I equals to 0, it will go to I2, right? So it will give me even numbers from 0 to 50. That's what I got over here. Tell me, what can I do to get multiples of 7 from 0 to 100? What can I do? Print all multiples of 7 from 0 to 100. Quickly write a code, everyone, please. Write a code while loop that can give me all the numbers from 0 to 100 that are multiples of 7, including 0. So repeat your question, please. Question is, okay, let me write the question. Print all the multiples of 7 from 0 to 100 using while loop. This is the question. What you can do is less than equal to 100 while I is less than equal to 100, and instead of incrementing by 2, increment by 7 every time. That's all. It will give you all the multiples of 7 starting from 0 to all the way. Okay. Starting from 0 to all the way till 100. Okay, 100 is obviously not the multiple, so 98 is the last multiple. So this is how you can get the multiple. There are n number of ways to do it. Either you can do it this way, or you can take modulus and loop till all. So I is less than equal to 100, and you can do a if condition. If x mod 7, like this, x mod 7 equals to 0, system.print out x. Okay. But in this case, what will happen? The loop will check for all the values. Every value from 1 to 100 will be checked by the code to divide it by 7. So not ideally, optimal. What you can do is just plus 7 so that not all numbers are checked. Every time I is incrementing. Did you get what did I say last? Execution time is higher. Yeah, that's right, Vaibhav. But did you everyone understood what is the difference between what I just said and before that, if you do modulus 7? Okay. In this case, only I think the number of prints, how many there? 6, 6, 9, 12, 15. Only 15 times the while loop will run in this case. But if you try to do a mod approach, 100 times loop will run, because you're trying to look for all the numbers from 1 to 100 and try to do modulus with 7. Okay. All right. So this was all about while loop. Coming to for loop. Now, again, a real world example, because that way I feel people understand it right. For loops are the loops where same thing are repeated for exact number of times. In case of while loop, it doesn't, is not very clear that for how many times it will run. While loop can be made infinite as well. Let's say I pass over here as true. Okay, this while loop will never fail. This will keep executing forever. You will get time limit exceeded. Your CPU will say, I can't execute it because it's an infinite loop. Right? Let's try to run and see what happens. It will keep printing I. It will keep printing 0, or it won't even print. It will keep buffering. Right? You saw. It kept buffering. It print infinite numbers of 0 and it will keep printing. Right? So while loops can be made infinite. But second, for loops run for a defined number of steps. For example, I tell you that keep chopping the onions till the time you have chopped 10 onions. Now, this cannot be infinite. You are chopping, you are cutting the onions, slice onions, right? One by one. And I've told you, do that till the time you have chopped 10 onions. So as soon as you chop the 10th onion, you will stop, because that was the instruction given to you. Right? So if I show you in terms of code, how it will look like, it will look like something like this. Let's do the same thing. What we are trying to do over here is we are trying to print integers from 1 to 5. This is the syntax. Do not forget the syntax. There are 3 parameters for loop takes. Unlike while loop takes 1 Boolean parameter, but for loop takes 3 parameters. First parameter is assignment. It makes sure that you are assigning something. You are using a variable and you're assigning and initiating that variable to something. Okay. Initializing happens in the first parameter. Second parameter is the condition. Till what time, just like while loop, right? The middle part will always be a Boolean expression, which will make sure that this is a expression that can turn false or can stay true for a while. And then last one is updation. The same integer should keep on updating. Okay. Now, if I want to print numbers from 0 to 5 or 0 to 4, right? What I can do is I can use this for loop where I'm initializing I as 0 and making sure I is less than 5 and then doing I plus plus. If I execute it, I will get numbers from 0 to 4. An exact same thing what we did for getting 5 in place. Either you can do this, so it will print 5 as well, or it will do, you can change 5 to 6 and keep the condition as it is. Now quickly use for loop to print all the multiples of 7 from 0 to 100. So what you need to do, I equals to 0, I less than or equal to 100 won't matter because 100 is not a multiple of 7. And in case of increment, you do I. So if you do it like this, you will get all the multiples which are from 0 to 98 or 0 to 100. Okay. Now, one thing. Do you all know what is a Fibonacci sequence? What is a Fibonacci sequence? Fibonacci sequence basically is first 2 numbers are constant, 0 and 1, and next all the numbers are the sum of previous 2 numbers. And the first 2 constant numbers are 0 and 1. Right? Next number will basically become 1 because 0 plus 1 is 1. Next number will become 2 because sum of the previous 2. Right? Next number will become 3, then 5, then 8, then 13. Clear, everyone? This will go on. This is Fibonacci sequence. Nothing to do with Java or programming. This is a sequence. For this kind of sequence, the term has been given, and we call it Fibonacci sequence. And this is the term. Any number is the sum of previous 2 numbers, and first 2 numbers are 0 and 1. Okay. Okay. Quite a complex code. I'll try to simplify it, but let's go to the question first. The question is, write a Java program that has an integer variable and check whether it is prime number or not using while loop. So all you have to do is check if a number is prime or not. Okay. You got a random integer over here. Let me remove this part. System.print.out. You initiated a integer called prime and assigned it to 17. Okay. I'll have to just understand the code first. We'll come to this part once we use it. And then for 0 and 1, okay, you can just mention that it's not a prime, right? If it is 0, if the number is 0, if the prime number is 0 or 1, you can just mention it's not a prime, because after that, you'll have to figure out if the number is prime or not. Okay, so for 0 and 1, you can have extra case assigned that these two are not prime. Then comes the else part, which will have the heart of the logic of checking a prime number. Okay, and how are we checking prime number over here is, we initiated inc, which is another variable inc, as 2 to start dividing that number by this variable. So what is a prime number? Prime number, let's say 17. 17 is called a prime number because it is not divisible by any number starting from 2 to 16. Right? That is the condition. It should not be divisible by any number that starts from 2 to 16. So what are we doing over here is, while the INC, the number inc variable is less than the prime number itself, we are checking if it is actually divisible by any number in between. Okay, any time if this condition gets satisfied, the same time statement will be printed that this is not a prime, and flag will be updated to 1, and then this will break. Else, if this doesn't happen, variable will keep on increasing. So 2 will become, please explain using some other code, sir. Okay. This will loop more. We'll just have to go through. This will loop more, Sumit. I know. Even if you go to just half of the number, that will also work. Okay. Pick mine. Okay. I mean, the problem is absolutely correct, Vaibhav. It's just that students will not be able to understand because of multiple use of variables. So I'll pick some other problem. Let's say this one. If this also doesn't work, I'll pick my own solution. The reason I'm picking your solutions because, you know, this creates motivation for you all to put and solve questions. Or let me just do it via. Guys, I'll use my solution only because I don't want people to get confused. Okay, so this is the only logic. That's all you have to. That's all you have to look for. What am I doing over here is integer num equals to 17 and integer I equals to 2. Okay, Boolean. We initiated a variable called Boolean, which can control that if the number is prime or not. This Boolean will try to use this Boolean to print final output if a number is prime or not. So by default, we have initiated this Boolean value as true. Okay. And next, what we are trying to do is we are trying to use while loop to run from integer I, which is I equals to 2 to num divided by 2. So basically, here is the logic. We don't need to check from all the numbers from 2 to 16 if the number is divisible. Even if we check, because after, let's say 17 divided by 2, how much it is? 8. Let's assume 8. If a number is not, if 17 is not divisible by any number till 8, it will not be divisible by any number after 8. Right? Because that's a logic. If you're trying to check if a number is divisible by something, you can just check the prime by half of the number. It is enough to check until square root of the number. Square root of the number, that is also a debatable topic, Farooq. Yeah, that might be the case. I'm just thinking if there could be a corner case on that. I think there could be a corner case for that. Yeah. But yeah, let's not go there. Maybe it works. I'm not very sure, so I would not comment on that. If it is working, it's perfectly fine. But for now, we'll check only till half of the number. So while I is less than equal to number divided by 2, we are checking if that number modulus I, if the number module I is equal to 0, that means the number is completely divisible. Make is prime equals to false. That means it's no longer a prime number, and break the loop. So once the loop breaks, it will come out of the while loop. Right? I hope there is no confusion. That's all you have to check over here. So this Boolean is important in terms, you can also, yeah, over here itself, you can print that it's not a prime number. Okay, but if you want to print that it is a prime number, that I mean, the Boolean just puts a clean code. That's the reason we are using Boolean. Without Boolean also, you can do that. Instead of doing if else over here, what you can do is you can do system.print is a prime number. It's not a prime number directly at this place. That also can be done. But using this if else with a control variable creates more sense. This logic will basically check if any number is divisible by the given number from 2 to half of the number. Okay, and depending upon the Boolean value, you can print appropriate statement using the is prime Boolean method, Boolean variable. Can you please repeat the logic written in while and if? Okay. So you initiated a number, a random number, 17, let's say, is a random number. And then you need to initiate two different variables. First is the integer I, which starts from 2. Because you need to check if a number should be divisible by any number between 2 to number itself, 2 to the number before that, right? So what we are trying to do is, what is a prime number? You are aware, Mayank? What's a prime number? It should not be divisible by any number except 1 in itself, right? So we are trying to make sure that it is not divisible by any number between 2 to the number minus 1. Right? So basically for 17, we are trying to make sure that it is not divisible by any number between 2 to 16, inclusive 2 to 16. And at the same time, you can check for all the numbers. You can check for all the numbers and try to have modulus of 2 modulus 17, 3 modulus 17, 4 modulus 17. You can do till 16 modulus 17. That's also is the case. So I can do this as well. Basically checking if I is less than number, this loop will keep running, and then number modulus I is less than number basically will create a loop from 2, 3, 4, 5, 6, 7, 8 till 16. And then if number modulus I will basically every time 17 will be divided by 2, 3, 4, 5 and checked if remainder is coming as 0. Anytime if remainder comes as 0, that means that number is divisible by I number. And it will make our is prime Boolean value as false.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.
Okay, so the very first thing we discussed was the if statement. Okay. If statement, I gave a clear analogy of that rainfall and umbrella example. Take the rainfall, and if it is raining, take the umbrella. I am not going to repeat the examples again, but I hope you remember it, right? So that is something we discussed as an example. If statements are basically conditions. Once the condition gets fulfilled, the code, whatever is present inside the if statement, gets executed. Okay, that is the crux of if statements. Now, if you see an example, anything that goes inside if is a condition, and then whatever follows gets executed only if the condition is true. That's all if statement is. If statement is enough by itself, but it can also be complemented with an else condition. Else condition gets executed when the condition is false. Okay. On top of that, we can have multiple statements and multiple conditions. When we have more than one condition, what we use is else if. This can be used between if and else. If statement can be alone as well, and if it is ending, it should always end with an else statement. In case, you can also have else if statement as well. Any combination will work. Only this will also work. Starting with if, only this will also work, and the whole snippet will also work, right? So that is something we discussed on the if statement. Next, we discussed on the switch cases. Switch cases is Let's say you have multiple conditions, multiple cases. What you do is you use a switch statement and you put an expression. This expression is not a conditional statement. This expression is a value. Okay. Switch statement takes a parameter called expression, which is a value. This value gets equated with the cases. Case X, case Y, whatever cases are there gets equated with expression. And let's say expression is equal to X, then code block under case X will get executed. Else, if it is equal to Y, code block under Y will get executed. And if expression is not matching with any of the cases, it will go to the default code block and execute that. All right, it's as simple as that. And we discussed then while loop. While loop takes a condition, and that condition is a condition which till the point it stays true, the code block under the while condition keeps getting executed. Okay, so that is the condition in the while loop. The same code block gets executed till the time the condition is true. Okay, if something goes wrong, it's very much possible that condition stays always true. When the condition stays always true, the while loop goes under infinite loop. Okay, do while is something not required for now. Then we discussed for statement. For statement can consist of 3 parameters. First parameter is initialization, right? You initialize something, you set the variable. Second is comparison. Comparison is always a conditional statement. And the third is incremental statement, right? We have discussed all that. Any confusion anyone has, please let me know. You can have nested for loops as well. A for loop inside which there is another for loop, right? So that was the essence of for loops. We discussed about break. Continue is something not required for now. And arrays is something we are going to discuss. But before that, we are going to take up one palindrome problem that we discussed last time. Okay, so I don't remember the question word by word, but the question was, you have been given a number. Okay, there is a number equals to 101, or it could be 1, 2, 3, 4, 5, or it could be anything. And you need to verify if that number is palindrome or not, right? Let's say 101. First of all, everybody knows what is a palindrome. Palindrome is basically, it's same, number is same irrespective of you read it from left to right or right to left. That's a palindrome. Okay, 1, 2, 3, 4 is not a palindrome. 2, 3, 7, 8 is not a palindrome. Whereas 44 is a palindrome. 1221 is a palindrome. 6556 is a palindrome, right? 1, 2, 3, 4, 3, 4, 2, 1, right? 3, 2, 1. This is a palindrome because number is same irrespective of you read from right to left or left to right. So to execute that, the simple approach that we can take is we reverse the number and then equate it. So number is 1, 2, 3, 4. We reverse it. What will the reverse of this number? 4, 3, 2, 1. And then we equate. Then we put a if condition and says if number is equal to reverse number. If this comes out to be true, that means it was a palindrome. Else, this is a pseudo code, guys. Okay, it's not actual code, obviously. Else, not a palindrome. Right? Simple. So basically, the whole palindrome question boils down to one logic of reversing the number, because this line is a very simple line. You just equate two numbers. If they are equal, send palindrome. If you are not equal, send not a palindrome. Right? So basically, the crux of the question becomes, how will you reverse the number? Correct. So that's the logic. Let me just copy the existing code that I have, that I had created that time, and then I'll show you how to reverse a number. Okay, so what do we do over here is, let's say we have got an original number. Let's say we have the number called 1, 2, 3, 4. Okay. We have got a number called 1, 2, 3, 4. This is taken by the user or hard coded. Anything will work. Correct. Now, what are we doing over here? Let me just remove the comments because with comment, it becomes slightly bigger. Okay, now we initiated a second variable. Second variable is reversed number. And reversed number is nothing but we have initialized it as 0, and eventually we'll fill this reverse number with a value, and then we'll finally equate original number. If it is equal to reverse number, we'll send it is a palindrome, else we'll send back that is not a palindrome. Okay, so the whole logic lies between this while loop. We are reversing the number in this while loop and later on comparing original number with the reverse number. Okay, and how we are doing that? The very first thing what we are doing that is, if number is not equal to 0, number here basically means the original number. Let me change the variable name as well so that it doesn't become confusing. Okay, this is basically a number. You can just take it as a number. All right, so same thing is happening over here. What we are trying to do is we are basically trying to reverse a number in this particular place. Okay, number is 1 2 3 4. We have initiated a variable called reversed rev number. The reverse number is equal to 0, and then this while loop is what we are trying to use to reverse a number. Now and try to understand what is happening over here. While loop we have initiated till the number is not equal to 0. So till the time this number doesn't become 0, we'll keep this while loop going. Okay, till the time this number is not equal to 0. So what we are trying to do here is, while the number is not equal to 0, we'll keep running this loop. Now let's put in the comments what will happen at each step. First thing, integer digit. Number modulus 10. What will be the value of digit at the first round of while loop? What will be the value of this particular 123.4? No, that would not be the case. I'm not dividing it by 10. It's modulus. What does modulus mean? Yeah, 4. It will be 4. Can you tell me the compiler you are using? I'm using this online IDE Megha, and over there you can just select Java. You don't have to worry about which compiler is going on in the background. Anyways, so 4 will be used, right? So first time 4 came over here. And then next time what we are doing over here is reversed number is equal to reverse number multiplied by 10 plus digit. What was the value of reverse number? 0, right? So what will the value of this expression now? What will be the value of this expression now? 4. Exactly. So now my reverse number is 4 in the first iteration. And finally, what I'm doing is number equals to number divided by 10. This is a short form. So basically it says number equals to number divided by 10. Okay. What will be the value of number now? 123. Exactly. Why not 123.4? As someone mentioned above, that we are dividing it by 10, right? And number was 1 2 3 4. So why 123.4? What will be the value of number over here, guys? Will it be 123? Type is int. Exactly. Type is int. That's why it's an integer division. So the number will also be an integer. So it will become 123. Now the while loop will see again. If the number is equal to 0? No. Then again the while loop will run. And this time again digit will be equated with number modulus 10. Now what will be the value of digit? 3. Exactly. And then this reverse number equals to reverse number multiplied by 10 plus digit. Digit is 3. Reverse number value was 4. Now what will be the value of reverse number? 43. I hope everybody is getting not, because I see only few people responding. So guys, reverse number already had a value of 4, right? And now in this statement, we saw a value of 3. Digit has a value of 3. So this expression will become 43. 4 multiplied by 10 plus digit. So it will be 43. And then number divided by 10, this will become 12. So eventually what will happen? Reverse number will be able to reverse your number, and eventually this will come as 2 and 1, and this will become 0. finally. Okay, and the last number shifted will be 1. So this doesn't matter much, but you will find a reversed number, 4321. Okay, this is a simple logic of reversing a number. You keep taking remainder from the original number by dividing it by 10. You take the first unit place and then put it in the first place. So this is the problem of nested for loop, where you need to print a pattern, something like this. It's kind of an inverted right angle triangle. All right. So what you do over here is you start with I equals to 5 and go till I equals to 0. Okay. Or I greater than or equal to 1. Basically, you start with I equals to 5 till I greater than or equal to 1. And then you do a second for loop where J starts with 1 and it goes to all the way to J less than equal to I. Anyone who has not understood it, I mean, this is kind of self-explanatory, but anyone who has not understood this particular problem, how did it execute? Got it? So basically, when I equals to 5, right? When I equals to 5, J runs from 1 to 5. Why 2 variables? That's what, because there are 2 for loops. There are 2 nested for loops. And because of that, we have 2 kind of a statement. Okay, I equals to 5. It runs from J equals to 1 to I, because we want to control 2 things. We need to control. We need to control the row numbers and we need to control the number of stars in each row. Hence, we have 2 variables. Okay. All right. So the question is, write a Java program that calculates the sum of the digits of a given number using a while loop. Okay. So basically, it's asking to write a Java program that calculates sum of the digits of a given number using a while loop. Okay. The program should continue adding the digits until the sum becomes a single digit number. Now, what do you understand by this? Let's suppose number is again 1, 2, 3, 4. What will be the sum of all the digits of this particular number? Tell me, guys. 10. Okay. But the question says you should continue to add until the sum becomes a single digit number. So basically, after that as well, you need to add these 2 numbers and become 1. So once you pass 1, 2, 3, 4, the program should return 1. What the program should return if I add 899? You have to do 8 plus, okay, 8 plus 9 plus 9. The whole thing. Be specific, Juliet. I'm not sure what to explain if you say whole thing. So basically, the question is, you have to add the sum of the digits of a number and then keep adding it till the number becomes a single digit. Okay. So 8 plus 9 plus 9 should be 8 plus 9 plus 9 would be how much? 26. And then you have to add 2 plus 6 as well till the time it becomes a single digit number. So it becomes 8. Okay. So that is the concept. All right. So the program, if I show you, first thing you have to do is, because you need to return a number, right? Let's say you have, in this case, our number equals to 1, 2, 3, 4. Okay. Now, till the time number is greater than 9, it can never be a single digit number if a number is greater than 9. Naina, I think sessions are already recorded, so don't have to worry about that. Yeah. So number is 1, 2, 3, 4, while number is greater than equal to 9, because any number which is greater than 9 will never be a single digit number, right? So what we are doing over here is, till the time number is greater than 9, we are calculating this thing. Okay, which is integer sum equals to 0. First, we are initiating some variable to be equal to 0. And while the number is not equal to 0, till the time number is not equal to 0, we are executing this particular statement. Now, what this statement is doing, if you see closely, it's similar to what we were doing for the reverse of the number. We are taking the last digit and we are putting the sum. Basically, you can understand it like this. Sum plus number modulus 10. So we are taking the last digit of the number and adding it to sum. And we are changing number equals to number divided by 10. Okay. Same thing, what we explained for the reverse of number thing. Same thing is being happening over here. Adding the last digit to the sum, remove the last digit. That's what we are doing till the time number is not equal to 0. Now, once number becomes 0, this will become 0 when the sum is equal to how much? 26, right? Because one by one we are adding it to sum. And now 26 will be assigned to number, because once it is 26, number will become 0. I hope you're getting, guys. At any point, if you're not getting, just let me know. Okay. Sum will become 26 at the time when 1, 2, 3, 4 will become 0, because every time we are doing the division. And in later part, we are assigning number equals to sum. So number is becoming 26 now. Now it will again, this while loop will be checked. Is 26 greater than 9? Yes, 26 is greater than 9. Okay. So what will happen? Again, this loop will go on and 26 will be again converted into 0 and sum will be brought it up as 8. And number will be assigned the number 8. Now 8 is greater than 9? No. Then loop will come out and number 8 will be returned. Factorial is going to be a very simple method. You need to put out the factorial of a number, right? Where is the chat? Yeah. So what are we doing over here is, first of all, number 0 or less than 0. Negative numbers do not have a factorial, right? So if a number is less than 0, throw an exception. Ignore this, guys. Ignore this one. I think you can just use print, print statement, println or something like that. Okay, system.print.out. I mean, system.out.println. Okay, factorial is not defined. And if number is equals to 1, I mean, the integer number that you have received for which you need to find the factorial is greater than 1, you need to follow this approach. Factorial equals to factorial multiplied by number, and then number minus minus. Now, what we will do, we will discuss to deliver the shape according to first half and the lower half. First half, what are we trying to do? Again, any problem which involves, a shape or something, you need to have two variables to control it. Okay, that's the reason one can control the rows, other can control the column. Upper half is going to be this one. What we are going to do right now for the first upper half is going to be this one, and the second half is going to be this one. Okay, now let's start. Upper half of the diamond. We are starting with integer I equals to 1 and going till 5. So from 1 to 5, we are going I 1 to 5. So basically row 1, 2, 3, 4, 5. We are going to take care of these 5 rows in the first half. Inside that, what we are doing, we are printing space first, followed by the star. Now make sure, how will you print this particular places, right? How will you put spaces? You have to print space as well. And that has to be taken care of. Now see the logic that we are using. What logic we are using? Very first time, to print the space, we are moving j from 1 to size minus I. What is size? Size is 5 minus I. For the first case, I is 1. So number of spaces will be 4. 1. Okay, over here you won't be able to understand, but basically these are 4 number of spaces. As I becomes bigger, j starts moving from 1 to size minus I. So first time j will move from I to 4. Second time j will move from 1 to 3. Third time it will move from 1 to 2. And then it will move from only 1. Right? So basically, first time it will print 4 spaces, 3 spaces, 2 spaces, and 1 space. So this is for the first half of the problem. Within that, we have just discussed about the space. Okay. Next, we are going to discuss about the star printing. Now, for the star printing, what you need to do is basically for all I, same, this for loop will be true for both the within for loops. Both the inside two for loops, the above for loop will hold true, right? So for I equals to 1, we are moving from k equals to 1 till k equals to k less than equals to twice of I minus 1. Now, this is something mathematical equation comes into the picture. How many stars we have printed in the first row? 1 star. Second row, 3 star. Fourth row, 5 star. Next, 7 star. How you can equate row number with the number of stars? That's what we have done over here. Number of stars equals to twice of the row. Okay, let me put it over here. Number of stars equals to 2 into row number minus 1. Now keep putting the row number 1, 2 multiplied by 1, 2 minus 1. So 1 star. Row number 2, 2 multiplied by 2, 4 minus 1, 3. 3 star. Row number 3, 3 multiplied by 2, 6. 6 minus 1, 5. 5 star. Right? So that's how you can calculate the number of stars in each row. That's what we have used in this for loop. And this is something you have, it will come to you with practice, right? It will come to you eventually with practice. Now it's clear with the logic, sir. Okay, great. Okay, so that's how you need to develop a logic. This is a diamond case. Any other shape might come. So every time you'll have to equate the row number with the number of things you want to print. So that's how you'll be able to print the upper half of the diamond. Okay. Now the lower half is very, very similar. Lower half is just that you have to start reverse. Over here, we started with I equals to 1 and we went till size. Basically 5. In this case, you have to start with size minus 1. And go till I is greater than or equal to 1. And keep subtracting I minus minus. Right? Because we are doing lower half. So we have to start with 4. 4, 3, 2, 1. Like that. Above it was 1, 2, 3, 4, 5. Now for lower, we start with 4. Size minus 1. 4, 3, 2, 1. Okay. And then we need to print the space first. Again, space starts with 1. Space goes to 1, 2, 3. Then, it starts with 1. It goes to 2. It goes to 3. And it goes to 4 spaces. So that's how the equation we have designed over here. It goes from j equals to from 1. Size for the lower, no. Size is 5. Size basically defines, okay, how should I tell you? Size basically defines the length of the diamond in terms of, for lower it's 4 because the total size of the diamond is 5. Okay. Size you can assume is it as, how can I explain this? 1 second. Okay, this is not the right example. Size over here, don't take it as another. Let me just print a size 5 example. 1 second, just give me one side. Print above. I'll explain this with a diagram. Okay, so size here, you can use the same diagram. Only thing is, the size here defines the height. Okay. No, the maximum star in the row, that is not the size actually, Amit. What you can assume is, this was the height. I mean, it depends on the question. Okay. Within the question, it will be given as an example. What I created the example thinking of is, the height of the diamond is 5, right? Basically from the base of the diamond to the top of the diamond, that is 5. So that defines the size. From the base till top, how many rows are there? So we have 1, we have 2, 3, 4, 5. So that's how I imagined the question to be and how I designed it. You can also get a question where, as Amit said, it can say that size is the maximum number of stars in a row. So in that case, these particular thing will become upper half, but don't worry about that. So size is the height of the diamond. Now, when size equals to 5, the upper half diamond size, what we are discussing over here, becomes 5, because this is 5. And automatically, since we want to print the lower half as well, what does the size of the lower half becomes? -1, because the base is common and you have printed the base in the upper half. So the lower half will become -1. Is it clear, Naina and Ambika? Can we directly write 5 in place of size in? Okay, cool. All right. So for the lower half, we need to start by printing 1 space followed by 2 space, 3 space, 4 space. So for that, what logic we have used? We have started j with I. J with 1. And we have moved j till size minus I, size -1. And then we're doing j plus plus. So for the first time, since I is already size -1, so j will become 1. Because in place of I, if you put size -1, j will become 1. So j will move from 1 to 1. That means only 1 space will be printed. Second time, I will be decremented. Right? So I hope this logic makes sense. Right? Every time you are incrementing j, hence you are able to print more spaces.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.
So the very first thing is arrays. There are certain things which is not mentioned over here, but I still like you to tell you. Arrays are the collection of multiple values. Okay, just like we had variables. Let me just do one thing. Okay, just like we had variables like int, or let's say string only, which will take, let's say string my str. Okay, just like variable used to have only one values. Okay, we have arrays that can take multiple values in the same variable name. So here, if you see my string, my str, containing Shubham as the only one value. But cars is again a variable. But the data type of cars is not string, is array with data type as strings. Here, the data type is a string. Okay, but over here, the data type of the variable cars is an array. Okay, you can call it, people to call it as an ND array, basically means n dimensional array. Over here, it is a 1D array because we have only one list. There are no list within the list, right? No array within the array. So it's 1D array, right? And what is the difference of declaring an array? What we can do is we can initiate the array with 2 square braces. That's how you can declare an array. Now, this array declaration can happen like this as well. This was for string. For int, what will I do? I'll do this. I'll say nums, and then I'll create this. 3, 5, 7, 6, 43, 00. This is also a array, but now this is the array of integers and this is the array of strings. Okay, I hope till this point we are clear how to initiate the array. Okay, now the other thing is, if I want to print this variable, my string, what will I do? I'll do system.print.ln my str. If I do this, I get Shubham. What happened, guys? Okay. Once I do this, I get Shubham as printed because the value of my str was Shubham, right? But what if I want to print BMW from the array? How will I do it? Let's try to print the whole variable itself, cars. Let's see what happens. Okay, it has printed some gibberish characters, which says java.language.string, and then it has mentioned something which is not something what we desired. Now, to access a particular element, what we need to do is we need to do indexing. Now, indexing is nothing but it tells you and it gives you to access how to do it. I mean, it starts with 0, 1, 2, 3. Now, automatically arrays gives indexes to its values. Okay. And now if we try to access, let's say BMW, if you want to print, if I do car 1, now we will get the required result, which is BMW, because we have cars as the variable and we are using the index of that particular variable and getting the answer. Similarly, for nums, if let's say I want to print if I want to print 43, what is the index of 43? Tell me, guys, what is the index of 43? 4, because 0, 1, 2, 3, 4. It's 4. So if I print 4, it will give me 43 because 43 is at the 4th index of nums. All right. Now, there is how to print complete string. Complete string as in? Okay. Now, let's say you want to change something. This was accessing. Now, let's say you in case of BMW, I want to print, let's say, quid, KWID. That's a different car altogether. What we'll have to do? What we'll do? We'll try to override it, right? Let's just try to override it. Okay. Let me try to override this using cars 1 equals to, and we assign a string, which is KWID quid. And let's try to print cars 1 again. Okay. Now what we saw that strings are mutable. Now there is a property called mutable and immutable. I'm not sure if you guys are aware of mutable and immutable. Okay. Mutable basically means you can change the value of that particular data type in which it is present. So basically I have values inside array, right? But I can modify it by accessing an element and overriding it or changing it. And then once I print it, cars 1, it gives me quid, right? So that is the immutability factor of arrays. Now somebody asked how to print all the strings. What you can do is you can very easily use a for loop, right? By using a for loop, you can do integer I equals to 0, I less than equal to over here you have to put size of the array, less than size of the array. I'll come to how to calculate the size, but for now, since we know the size is 4, let's put 4. Okay, I'll tell you, hard coding is not required. You can actually put the size of the array. I'll come to how to do that, and then do I plus plus. And then you do this string dot print dot out over here, and you pass on I. Right? Now, if I try to execute this, you would see all the values which are present in cars getting printed in the line. Right? So that's how you can print all the values in the array. Okay. Okay. Now I was talking about calculating the length part. Now, the very first thing what you can do, and it's the simplest thing, to calculate the length of an array, all you have to do is use the dot length functionality, which is already present in the main class of Java. So all you have to do is system.print.out cars dot length. If I do that, I would get answer as 4. 1 second, I keep forgetting to put semicolon. I'm actually a Python developer, so yeah. So yeah, you see 4 getting printed. Now what we do, instead of hard coding it 4 over here, what we'll do, we'll put cars dot length, and then we'll remove this, and then print this out. Okay. I hope till this point there are no confusions. If there are any confusion, feel free to let me know, and I'll just pick that up and talk about it. All right. Now let's move on to looping through the array, which we have already covered actually over here, that how to use for loop over an array. Can't we use cars instead of for loop? Can't use cars instead of for? I did not understand your question, Navya. Can you, instead of for loop, you want to print cars? I mean, are you saying this? Let me just tell you this. This will throw you an error because you're not specifying what you want to print. But let's see. Is this what you're saying? Can't we use print cars directly instead of? We can't do that. If you're using this way, you'll have to pass on the index to let a system know what exactly has to be printed. If you want to print all the values, you'll have to go through the loop to print all the values. Okay. Now there is a different way of doing it, but it doesn't matter much. Instead of for loop, it's just the a modified version of for loop that can help you to shorten things up. So basically in the new version of Java, this is being supported, where what you can do is, just like in Python, I hope you have been taught a basic looping part of Python. In the for loop, instead of defining I, instead of letting I run from 0 to size of the array and then keeping I plus plus doing every time, what you can do is you can initiate a variable I and then use this colon and say cars. With for loop, what will it do? It will keep putting the value of cars one by one into this I, and it will keep printing it. So if I do like this now, it will print the values of cars. Okay. Keep this in mind, guys. The arrays will always take one data type values only. Unlike Python list, in Python list, you can put anything in the Python list. First element could be string, second could be integer, third could be a dictionary, fourth could be another list, right? But in Java, all the array elements will be of the same data type. Okay, I hope it makes sense. Now let's say, so far we were talking about a single dimension array. Now single dimension basically means you have directly the values inside it, right? It doesn't have anything. Arrays does not contain any other data structure. Arrays contains the values directly. Now there could be certain arrays which are two-dimensional. Basically, you can imagine two-dimensional arrays to be a kind of a square. Let's say, I'll give you an example. This is an example of one-dimensional array. Two-dimensional array could be, two-dimensional arrays could be, this could be an array. So basically, you can imagine it to be a square. It's tough to visualize like this, but basically understand that each column is the element in the array, and each column is itself an array, right? In this case, each column, again, each value is directly a value itself. Each column contains only one value, so it's directly a value. So it's a 1D array. But over here, each column is itself an array, and each column is a value in a particular array. So it becomes a 2D array. For 3D array, you can just imagine that each value has a 2D array. Okay, it might take a slight confusion to visualize this. We'll have both row and column as index. Yes, I'll come to that, Dipshika. Yeah, but just understand the 2D array and 1D array and 3D array, it could be n-dimensional array as well. Obviously, after 3D array, you won't be able to visualize it, right? After 3D array, you can't visualize it, but that's it. Box within a box, yes. So if I talk about multi-dimensional arrays, it's a very great example. I'll show you how to initiate that. It's like this. Very first thing is data type. You have to specify that of which data type you are creating the arrays. And then in the 1D array, we were specifying only one square braces, pair of one square bases. But in case of two-dimensional array, you have to use two pairs of square braces. Can we use step values in arrays in Java like Python? Step values. What is step value? I'm sorry, I can't recall what is step values. Do we need to define row and column differently? No. I'll show you how this has to be done, Rohit. Okay, so let's talk about the 2D arrays. 2D arrays is you defined an array and there are two elements in the array. First element, second element. Now these two elements are not values, are an array itself. So basically this is also an array and this is also an array. First array has 4 elements, second array has 3 elements. Now each of these values can also be an array. In that case, it will become a 3D array, right? That is one thing. Now let's say I want to print a particular value. Whenever you want to print a particular value in a 2D array, what you need to do is you need to assign the row number and the column number. So if I put this as a visual representation, so value 1 is equal to 1, 2, 3, 4 array, and value 2 in a main array is 5, 6, 7. Okay, value 1 is basically a 0th index, 0th row, right? First row, 0th index, and this is first index. You can assume it as row 1, row 2. Okay, 0th index has 4 elements. First index has 3 elements. Now what are we trying to access? We are trying to access first index, and I mean, in terms of rows, first will always represent a row, second will represent a column. So first index in case of row and second index in terms of column. First index in terms of row, and what is the second index in terms of column? This is 0, this is 1, this is 2. So we got 7. Okay, so that is what you see 7 being printed. All right. Okay. Now let's say I want to print 2. What should go in the indexes? Tell me. If I want to print 2, please zoom a little. Okay. 0, 1. Absolutely. I need to print 0, 1. Everyone is clear with this, guys? I mean, I know there are people whose name I remember now, like Vaibhav, Prachi, Archana, Deepshika, Amit, Prachi. These guys respond every time, right? But I have not heard from the rest 60 people, right? So I hope this is clear, because this is very basic and you need to understand, you need to visualize it. Okay, cool, makes sense. Okay, so this is how you can do a you can create an array, a 2-dimensional array, and access the element. Does index always start from 0? Yes. In case of Java, Shiva, it starts from 0. In case of Python, it starts from 1. So it's a language specific thing, but for the most of the languages, it starts with 0. Now, a very interesting thing. Now, if I want to print all the values in a whatever fashion I want to print, right? How will I print it? In the previous 1D example, what did I do? I used a for loop, and I just created a for loop that can go over all the index and print it. But in this case, it is going to be slightly different, because 2 arrays are involved. We'll have to create a nested for loop. Only one for loop will not be enough. Why will it not be enough? I'll tell you why. If I print only one for loop, okay, let's do and see. So for int I equals to 0, I less than my numbers. Anything that is nested basically means it contains the same thing within it. Nested if is if statement within a if statement. Nested while loop is while statement within a while loop, like that. My numbers dot length, leng length. Okay, and I plus plus. Now let's say we try to print all the values using only one for loop. Let's see what happens. What are we going to do over here? Okay, I'll have to type the whole thing. System dot out dot print ln. Now what should I pass? I will pass my numbers, and then I'll pass I. That's how we did in the 1D array, and it solved our purpose, right? Let's try to do that here as well. And I try to print it. Let's see what happens. It gave me gibberish character. These are not, but basically a memory location of where these arrays are stored. Okay, I think someone asked as well. Memory locations about thing, right? So for I, we need to give row length. Okay, anyways, so these are memory locations. So we are able to access this particular array memory location, but we are not able to access the elements within it. So to access the elements within it, we'll have to create another for loop that can loop in. So in the first for loop, we'll loop between first element and second element. That's how the first for loop will do. Second for loop will be looping inside each of the rows and take the values. And that's how we'll do. We can't use the same variable inside the second for loop. So we'll be using a different variable, which is j. And j less than. Now tell me what should come over here. So far we were using the array length. My numbers dot length. What should this place should come? Just fill in the blanks and then we'll come to j plus plus. J is less than what? Only I. So you're saying I should put I dot length. I is not a array, Sarvesh. I dot length will be undefined. Yeah, some people are saying it correct, but I want to hear from rest of the people as well. My numbers dot I will give you a value. You have to get a length. So basically over here, what will be there? It will be my numbers dot length, which is basically I'm saying when I'm iterating with the top array, when I'm iterating, I'm basically getting the length of this array, right? So length of array is I'll get 1 and 2. So the length of the first original root array is 2. But when I'm iterating in this array, I need to get the length of this particular first array. How will I get the length of this array? First, I'll have to access this element. Accessing this element will involve my numbers and I, because I is running from 0 to length. So first this will be accessed, and then dot length will give me the length of this particular array. Is there anyone who has not understood this? Because this is something, without this we can't move ahead. Okay, so anyone who has not understood this, please let me know. Okay, now what you see over here, we are able to print things. 1 2 3 4 got printed through this for loop, right? Then this for loop got ended because this was ended, and hence this for loop, it came out and printed this, that first row has been printed. Then it went back again because it is going through all the elements. So it went to the second element. It printed, this for loop printed the second element, 5 6 7, and then it printed out second row has been printed. Has everyone got this? Anyone who has not got this? Anyone who has not understood it? Let's try with both the places. Let's see what will happen then. Because concept has to be clear, should be clear. It gave you errors, right? So basically it has to be only at one place. Either you add it there or you add it here. Regarding the behavior of strings like an array. Okay, so let's say if I define a string called str and I assign it to Shubham. Okay, each this string, this whole string acts like an array. Everything that is applicable to an array will be applicable to this string as well. Now, when I say everything that's applicable to a string will be applicable to this particular array, what I mean is, let me just show you one quick example. Okay, let me just write for int I equals to 0, I less than str dot length I plus and then let me first use a normal thing. 1 2 3 4 5 6 7 this one. 5. One second, guys. Let me just showcase you to this string. What you see over here is string. I am able to access individual element using a for loop. Right? This is not possible with integers. This is not possible with float, decimal, boolean, anyone. But with string, I can use a for loop that can access things individually. Also, string length I can do by str.length length, and that will give me the length of the string. And to access the element, instead of directly accessing by using a square braces, the string library of char act, which is basically means character at this index, I can use it. Now if I run this basically will loop through all the characters I have in the string and it will give me the result, right? So that is something I wanted to showcase you, the behavior of string just like an array. Let me write this function, paste it over here. Okay, and let me just create a random integer. I'm using a previously written code because I don't want to, waste time or anything. All right. So let's say you have an integer like this, right? Random integer, you can put n number of values over here in case of any order. Okay, assign max to any one of the integer. Like let's say first element, you assign that this is the max value. You can also take, you know, if it is an integer, you can also take int min. There is something called int min. Basically, it says the minimum value of the integer can hold, but you don't have to go to that specifics. What you can do is you can assign max as the first element of the integer. Now run a for loop from first element of the array to the last element of the array. Simple. If you encounter any value which is greater than the max, if you encounter any value from first element of the array to the last, and you find any value which is greater than the max element, which was our first element in the array, replace max with that element. And then finally, you can print max. Is it clear to everyone? It's a very simple problem. Anyone who, sir, is it mandatory to write? No, it's not mandatory. It's not mandatory to write this, but some of you I see have done it like 0. But what if I do like this? What if your integer is this? If you initiated max as 0 and all the arrays in your integer, in your array are negative, max will print 0. Right? So this is the corner case. But in fact, answer should be, what should be the answer? -2. Because -2 is the max number in this one. But it will never get printed. Right? So either you write array 0, right? Or you write int min. Int min basically says the minimum value an integer can take. Because 0 is not a minimum value. You would find numbers lesser than 0 in the array, right? So have a int min will basically say lowest possible value an integer can take. It's the first element of the array. The question says that you need to find the maximum element in the array. Okay. Now, what approach I have taken? I assume that my maximum element is the first element. I assume that. Okay. And then you, first you're assuming. And then you ran a for loop and checked if any element is more than my assumption, replace that element with the max. Okay, let's say this is your 3 by 3 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, what I did was I calculated, and okay, matrix, if you guys know about difference between a matrix and a 2D array, matrix will have same number of columns, and I mean each of the row will have same number of columns, right? That's matrix basically, right? So if I am assuming column variable and getting the length, if it is 3 for the first element, it will be 3 for the rest of the element as well. Okay, so what I'm getting is, first I'm creating matrix, a random matrix I'm generating, randomly putting numbers, and then I'm getting the matrix length. Okay, and then I'm getting the number of columns. Number of rows I'm getting by matrix length. This will give me how many arrays are present inside the root array. And then columns will give me how many values are present inside the each value, which will be same for all. So this is also equals to 3. And this is also equals to 3. Now what I did, I created a new matrix called transpose. Okay. And then I created new, okay, this is something might be new to you guys. Let's say you want to create an array, but you do not want to initialize it. So far, what we were doing something like this. Even for 1D array, we were doing like int arr equals to something 1, 2, 3, right? We were directly initializing it. But what if I just want to have a empty array of certain length? Okay, if I want to have an empty array, this is empty array. Let's say I want to have something like this, that it has allocated the spaces, but the values are missing right now. I will put the values later. This is the way you can do it. The first left hand side is same as the first one, but next I'm using new int, and I'm passing the number of columns and rows I want. Okay. Now, why do I pass columns and rows? Because I want transpose, right? So number of rows in the matrix will become number of column in the transpose, and number of columns in the matrix will become number of rows in the transpose. So basically, I created a new array which has 3 columns, 3 rows, but all are empty. And the name is transpose. That matrix name is transpose. Okay. All right. Now what I will do, I will simply start a loop and going through all the elements, right? One by one, the same way we did for printing the numbers, right? Similar way, I'll be going through all the numbers, and I'll start filling the transpose in the opposite way. Basically, transpose is what? The index become the column, and the column becomes the index. So for matrix ij, I'll be filling it in the ji. That's all it is. What did we do over here? Where is that? Where is, I removed it? Kya? We wrote a sample of that one. Okay, I removed it. Anyways, so basically, the rows will become column and column will become row, which basically means ji will get interchanged in case of transpose and matrix. Let's say I have a matrix, same matrix I'm using 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Number of rows will be matrix dot length. Number of columns will be the length of first matrix. Okay. Clear so far? Similarly, what I'm doing is I am creating a array called row sums, which is a empty array and has number of values equal to the number of rows, because we want to return the array which is the sum, which is basically the sum of each row. So number of rows will be equal to the number of values we will have in the final array. Now this will be the heart of the solution. I'm just walking through each rows, initiating a sum equals to 0, and then I'm calculating sum for the jth, for each row. Are you guys getting it? Yeah. Okay. And then I am appending that row into the sum. This is very straightforward. You just have to visualize it. I'll make it slightly more doable. So I'm initializing sum equals to 0, but for each row, I'm using j to walk myself through each row, right? And then I'm putting sum, appending the matrix result, whatever I'm getting, into the sum, and then I'm pushing that value into the ith column of row sums what I have created. Any confusion, guys? Anywhere? Because I have tried to create the solution as clear as possible. Anyone who has any confusion, especially for the people who are not able to do it, I want to hear from them, because I think Kritika, Amit, Vaibhav, Dipshika, you guys have been active and you guys have been putting solutions. So can we run with output? Absolutely, we can run with output. Let me do that. I'll have to comment this out. Like with each iteration. Oh, I'm not sure what you mean by that, Farooq, but let me do that. Do someone remember the multi-line comment? I have forgotten that. What was a multi-line comment? Okay, yes. Thank you, Reshma. Okay. Now let's try to run this. I think it's all good, all good. Okay, let me do that. And run. I should get an array which should have 3 values. Row sums, where is row sums getting missed? Okay, return row sums. 1 second. I should print it out. Let me just print the row sums out. 1 second. Let me just do it this way. For I and row sums. Okay, now let me try to run this. I hope I don't get any errors. Let's see. Okay, got it. So now you see, it's basically an array. Okay, Suraj, I'll explain that line. It's basically an array. I'm just printing that array into, I'm printing that array values into separate lines for the ease of understanding. Okay. All right. So what do we see over here is it clear now? Because now you see each row that we have will give us this output. First row is 1, 2, 3. So answer is 6. Right? The sum is 6. Basically, what is happening? One iteration, I can show it to you. So you started off with the first array. Let me do this part as well. It's more like 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? When I equals to 0, I equals to 0 is this first. The I equals to 0 is the first row. Right? And then we are iterating from j equals to 0 to j plus plus. Basically, it will go from 1, 2, 3. Right? Column, j is the column, right? So it will go from 1, 2, 3. And it will print the sum. Take the sum of 1 plus 2 plus 3. And then it will append to row sums. Row sum is nothing but an empty array which has the number of spaces equal to the number of rows. Right? So that is something you can use to visualize it. Okay, any confusion, anyone? I think someone had the confusion. Suraj, you had the confusion on this one, right? New int. New int is nothing but you create a new you create a new array with spaces equals to rows. If you visualize it, this will be basically like row sums is equal to, this is what it will create. An empty list, empty array with specified number of empty spaces. All right. You got an array. Fine. You created 2 pointers, start and end. Okay. Start is 0. Basically start index. End index is array length minus 1. This will give you the last index. Okay. So start and end, these 2 indexes are clear to you. Right? You create a while loop. While start is less than end. Basically, this is your start index. This is your end index. If array start is not equal to array end, return false then and there. Basically, it's saying at any point of time, if start is not equal to end, just return false from there. Or maybe if you are printing, you just, yeah, over here you can say break. You can say break, and you can here print itself that it's not a palindrome. Print that not palindrome. Okay, and then you break. Else start plus plus, end minus minus. If these both are equal, you do start plus plus. Now start will move to this place and end will move to this place. Right? Again, these both will be verified. This loop will keep running till the time start is less than end. If these two matches, again 2 and 2 matching, start plus plus, end minus minus. Now what will happen? Both start and end will come over here in the third position. I mean, in the place of 3. Now this will not hold true. This will come back of the loop. And if it has came back out of the loop without breaking or without printing anything, it will return true. Basically, this was a functional approach. So return false. Okay, I took a functional approach, but if you're taking a Boolean approach, this is something flag approach will work, which people have done. So basically, you create a Boolean or anything. Let's take an int only. Int flag. By default, keep it as 1. 1 becomes 1 basically means true. If this happens, you put it as 0, and then you do break, and then what you can do over here is if flag double equals to 0. I mean, this is very simple, so I'm just putting it in print not palindrome, and then else print palindrome. Okay, so this will also run for only half of the time, similar to what Tami said. Okay, his solution also runs to the half. So you don't have to compare every time. You don't have to compare one with this first with last, second with second last, and then reverse it. You just have to use 2-pointer approach. I mean, this is one of the solution which can keep comparing using this while loop. And as soon as anything mismatches, it will break and convert flag as 0. And later on, using that flag, you can put non-palindrome. Okay, so let's say I have a matrix like this, same matrix which we have been using, and we need to find 5. Same thing we are doing. We are basically making sure this thing you can do it over here as well. But just to make the code look clean, what I have done is calculated a row length and column length beforehand itself every time. And then I'm using rows and columns with the help of those variables. Not doing anything at all. What I'm doing over here is I'm just using a if condition. Walking through each and every element of that matrix and using the if condition. If any value meet my target, I return. People who have not used function approach, you can do it in a way which is just printing out. Print out I and j, calling them as row and column index. Okay, and you can just break over here. Okay, and also if there is no functional approach, you'll have to put flag approach, flag equals to 0 and stuff. And over here, you can just apply if flag is equal to 1, print -1, -1. Okay, I have kept it in a very short form. I mean, because I feel that now you should be able to understand these kind of commented code, right? So basically, I'm doing nothing. I'm just walking and passing through the matrix. I'm comparing. If anything gets compared with the target, I print out I and j because that is the position of that particular element. So let's say we'll have to write it here. System dot print dot system. Okay, let's see if this works. I have just written it very quickly. So let me try to run it. How to run it? What is the issue? This is for this line number 31. Okay. Farooq, 1, we are getting because 5 is at a position where it is 1, 1. Now let's say I change the target. I change the target to 9. Okay, let's see what we get now. We should get 2, 2 because 9 is at the position which is at 2, 2. If I change it to 6, it will give me some different answer.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.
Next week, who will take session? It will be a professor from IIT Guwahati, Reshma. I'm not aware about the name of the professor, but he is a working professional professor from IIT Guwahati. Okay, all right. Vaibhav, yes, we'll try to cover the continuous statements as well, but I just want to cover this data structures because this is required. Maybe if time permits, we'll do that today or else tomorrow, but definitely within these 2 sessions, we'll do that. Is it continuation of DSA? Yes, Reshma, it will be a continuation of DSA. Okay. All right. So ArrayList, if I talk about, it's very similar to what we have already discussed, which is arrays. But the only thing is ArrayLists are resizable. In case of array, how did we perform the action? If you remember, we defined the size of the array. It will be of 5 or it will be of 10 size or n number of size we used to define while initiating it. Okay, or we used to put a required amount of space specialized for the array, right? That actually created a lot of limitations in case of industry use case of arrays, because in the industry for academic purpose array makes sense, but for in the industries the requirement keeps changing, the things keeps changing, and you might have to alter the data structure, especially truncate it or elongate it depending upon what is the requirement. Okay, hence ArrayList is a kind of a second version of array which is resizable. For ArrayList, you need to import the ArrayList package from util library. Okay, so if I just show you how to do that. All right, so working code will be covering that part, but right now I'll just show you through the example. So if you see over here, we need to import ArrayList from java.util. That's the Java is the library, util is the package, and inside util package we have ArrayList, which is the module. Okay, and to initiate a array list, this is the statement you need to create. Now I would just like to create it using this. I hope code is visible. Ignore the below aspects, just focus on the first part. All right, this is something we covered, that ArrayList is something you can import using java.utils package. Okay, once you have imported that, you can use ArrayList to create a ArrayList object. Object, since we had already discussed, object is nothing but a replica of that particular module or that particular library, you can call it as, which you can use for your purpose. So what are we doing over here is we define ArrayList using ArrayList keyword. Inside that, we need to define the data type that we want the ArrayList to contain. Strings is the data type which we are using for this purpose. It can be int as well. Once you do int, you'll have to change it over here as well. But for now, we are using strings. And we are creating new ArrayList with the same string data format and creating a new object. Okay, so basically we are creating cars which is of ArrayList type using a new ArrayList object using from the module. What if we directly use util star? Okay, so there is a question from Gautam that what if we use directly like util star? In that case, you will have to do util dot ArrayList. In this case as well, util dot ArrayList, which is not the ideal method. So better to use, ArrayList by directly importing ArrayList as well. So the reason star still works, guys, if someone is not aware, if you put util dot star, the import statement will onboard all the packages that are present inside util. Okay, so this may still work as well, but util dot ArrayList you might have to create. Shall we use ArrayList int to define 2D array? Yes, that's right, Vaibhav. We can use int to define a 2D array. Okay, all right, so let's move on. The very first and basic thing is, how do you add elements in the array? For that, there is a simple add function that you can use on the variable that you have used to define the array list. Okay, what you can do is, you can just do cars, which is the variable name in our case, dot add. You can add Volvo, BMW, Ford, Mazda, anything. I mean, you can keep doing it without a limitation in the size. But that again restrict array size. No, Vaibhav, it does not restrict array size. It restricts the dimension. So if this is the string, dimension, dimension will be restrictive. Yes, I mean, if you change the dimension, that goes to a different data structure altogether. The intent is having a data structure that is expandable or truncatable. Okay, the basic requirement has to be made sure that it's actually dimension wise we should be clear, and after dimension is clear, we should be able to restrict or truncate or expand it. Is it mandatory to write string? I did not get this. Yes, it is mandatory to write string, Mayank, because okay, let's say over here we were trying to add Volvo, BMW, Ford, or Mazda, right? Let's say we want to have an array list that contains age of all the students that we have in the call. Okay, and age is an integer, correct? In that case, this array list would not contain string. It will contain integers. Hence, over here you will you will need to have int as a data type, array list that contains int. Or let's say, in this call, we just create a poll. How many of you are, let's say, in college or not in college, or let's say married or unmarried, anything of that sort. That will be a Boolean value, yes or no, true or false. So in that case, we will have bool over here. So this keeps on changing. All right, so moving on, we now know how to add items. Now, one thing you can see over here is I can keep adding item as per my wish. I can keep going on and keep adding items till the time I feel that I have added all the items. So there is no restriction in terms of how many characters, how many names I can add. Okay, so this way. So please repeat fourth line. Okay, we have been repeating it, Suraj, multiple times. We are not doing anything except creating an array list called cars. Cars is a variable name. This is the data type of cars. Cars is an array list of strings. And over here, we are trying to create a new array list that is basically we're trying to create a new object of array list strings. That's how you create an object, right? Okay. All right. So if I run this code, you can see I will get Renault as well as the fifth item without altering anything in the code. So basically it's expandable. It's expandable to, the memory allocation size of your system that you're using. So basically you can call it as an infinite. Okay. All right. So we covered the item of adding in the list. Now let's say I want to get some item. Get as in taking an item. So the best part of array list is time complexity, or the effort that is required to get an item is order of 1. Basically what it means is you can access any element in a unit time. And how you can do it is using .get functionality. So just put the variable name, use .get, and put the code, and put the inside parenthesis, put the index number. Let's say I want to have the third index number printed. Okay. What I can do is I can use this particular cars.get, and I can just print it out using cars.get.myIndexNumber. And now if I run it, what will I get? I should get Mazda, because that's the fourth element in my list and that has index number 3, right? I hope that's clear for everyone. It's a two very simple methods, adding and getting. You add something and then you try to fetch something out of the array list. Next is changing the item. So array lists are mutable. What are mutable? We discussed that in the last session. Mutable data structures are the one which allows the system to alter the data within it. Changeable, exactly. And how can you change it? You can change it by using variable name dot set. Now if I do it, cars dot set, and then it takes two parameters, only two parameters. First parameter is the index number, that which index you're trying to change. Let's say I'm trying to change Mazda itself, okay, to something called COVID. But data type should be same in set, right? Yes, absolutely. You can't just put over here as an integer or float or Boolean value. It has to be in sync with what is defined in the first place. Okay. And when I do cars.set, what I get is, okay, I set it out and I need to print it as well, right? 1 second, guys. So first it printed Mazda, and after I did the set, it should print COVID for me. Right? So that shows the mutability quality of array list. Okay. So what have we discussed so far? The very first thing we have discussed is initializing an array list. Second is adding elements in the array list. Third thing is setting a value or altering the value in the array list. Okay, got it? Now again, removing an item. It's again as simple as dot remove functionality. What we can do over here is we can do cars dot remove, and let's remove the third element index only, since we're talking about third index multiple times. Let's remove third index and then let's try to print the third index. Let's see what happens. Yeah, because the array automatically shrinked. It doesn't create any empty spaces in between. Okay, so when we deleted the fourth item, which is Mazda, which we had converted into COVID, and we deleted it, so Renault took the place of the fourth item or the third index. Hence, we got the item as Renault printed once we try to access the third element. All right. Okay. What will happen if we do cars.clear now? Let's say you're fed up with everything and you just want to clear everything up. Let's try to clear this up, and let's try to print the whole cars again. Right, cars variable. Let's see what happens now. Okay, if you see, you saw an empty array list getting printed, right? So basically, dot clear clears out each and every element that is present in the cars. Okay. All right, moving on. Next is cars dot size. I mean, these all you will have to remember. I mean, it might be tough to, understand in the first place, but you need to remember all these aspects to make sure that you are able to solve questions. Any guesses what would car.size will give? I mean, obviously, it's a very simple guess. It will return you the size of or the number of elements present in that particular array list. Okay. So it says 4. Why does it say 4? Because before that only we deleted the third index one. We removed Mazda. Hence only 4 are left. Hence, once we do this dot size, we see 4 getting printed. Size is same as length. Yes, Mayank. I mean, you can call it as anything. It basically says the number of elements in that array list. Yes. So you can length of the array will also be same only. Yes, that you can say size, and size is same as length. Yes. Okay. All right. Moving on. Now there is something called looping through the arrays. Okay, let's try this one. We created the same array that we are discussing so far. Now what we are trying to do is, instead of printing all at once, I mean, there is one way to print all at once, is just print the whole car variable itself. Okay, I can just print it like this, and if I execute it, you would see whole values getting printed, right? But what if I want to print it like this and not like that? Not like an array in a single line, but like a individual elements in different line. So in array list, just like arrays, we can do loops. We can perform loops, and loops are nothing but initiating an integer starting from 0th index to all the way to the last index, right? Incrementing that variable by 1 every time and printing out the element using get method. Try to relate it with what we did over here. We did the cars.get to print an element, to get an element, right? Same thing you can do, but with the help of loops. Straightforward. You need 2 for loops, one for adding the elements, other one for printing the elements. You can directly print the whole array list as well, but I prefer to, print it line by line in the order. So first line, you're just initiating array list with integer. Someone asked me the question around if you need to specify the data type in right hand side as well, but it is not required. Okay, once you have specified for the variable that you're creating, that is enough. You don't need to specify it again. Okay, so numbers we have created, and we ran the integer I from 1 to 10, and then we added the numbers. Okay, and that actually inserted number 1 to 10 in the array list called numbers. And then using this for loop, we printed it using get method. All right, so we added 3 random integers, 1, 2, 3. It could be anything. It could be 100 or 10 or 222 or 34. Anything could be there. And then we calculate the sum. How do we do that? We initiate a variable called sum equals to 0, and then we create a for loop. Don't worry about this for loop. This is a modified for loop. For the people who are experienced in coding, they might be able to understand. But you can write a simple for loop using I equals to 0, and similar to what we have done it. I is less than numbers dot size and I plus plus. And over here, what you can do is sum equals to sum plus numbers dot get I. Okay, and then you'll get the sum. So what it will do? Sum previously is 0. Now integer I starts from 0 to the last integer, the size. So basically it iterates through all the 3 elements, and it appends or adds the previous value of sum into the current value of numbers. Nice. So we see the question is, write a Java code to remove all the occurrence of a specific element in the array list of strings. Okay, so there is something I'll be introducing you a term as well, using which you can do it in a better and a faster way. I just want to show you one more method to perform the same action. Okay, so first, what are we doing over here is we are adding the elements to the array list. Let's say I added apple, banana, apple, cherry, apple. And then I want to remove all occurrence of apple. This is one way of doing it. Obviously, what you can do as well is, like most of the people have done it, you can again create an initiate a for loop with int equals to 0. And then I does contain work like, okay, I'll come to that. I less than words dot size. And then I plus plus. And over here, you can keep comparing, right? If, what do you say, words dot get I equals to apple, then words dot remove apple, right? This is one way and it's a perfect way. No problem in that. It's just that I want to slowly introduce you guys towards building something which is much more coherent, much more understandable, and much more in towards the industry standards. Okay, so over here what you see is, in the while loop, what we are seeing is every time it checks if the word contains apple till the time word is containing an apple. This loop will keep getting executed. Okay, and whenever it touches a case where it's actually apple, you can just use words.remove.apple. So you mean if you put over here apple pie, the loop will not start because apple pie is not present in the words. Okay, so guys, I think remove all, you guys are getting confused because it's a part of collections, and it's also relevant in Python and some different language. That's the reason. In ArrayList, you don't have remove all functionality. That is one. Second thing is, if you talk about this particular statement, words dot contain apple pie. So I think the question was, this will give you a true result because apple is present, right? So even if a subset is present, it will return true, correct? But within that, we are trying to remove only the instance of apple. Okay, let's try to run this program. Yeah, so let's try to do that. I am printing words over here. Let's see if it works. If it doesn't, we'll try to fix it. Where is the symbol? Okay, so I need to put over here as colon. All right, so very simple. Double is something we are creating because we want to have a array list of doubles. And then we are adding numbers just as a bunch of numbers inside the numbers array list to find the maximum element. Okay, the ideal approach is to initiate max with the minimum possible value. Okay, and that is something you can do by using double dot min value. Now, min value is relevant not just in double, but also in float, also in integer, and also in any other data type as well, except string, obviously. But all the continuous data types, min value is present. So over here, by defining min value equals to max, what you're doing is you are making sure that max is set to the minimum possible value of the double, so that any number that comes, it can, this statement can execute efficiently. In wrapper class, it is present, right? Yes, Dinesh, it is present. For loop, you can just create your own for loop the way you have been doing it. That doesn't create much of a difference. Okay, the way we have been doing it, so that's, I don't need to write it again. And if num is greater than max, over here num will be nothing but numbers I. If numbers I is greater than the maximum value is set to minimum value, right? So this can make sense. Now, some of you, what I've seen is, at times some of you defines max value as 0, right? But that is not going to work, because what if your all the values are negative in your array list, correct? Max value will give us 0, which is not even present in the array list. So that's not a right way to just create the max value as 0 or any other number. Try to have minimum value. Some of you have initiated max value with the first element of the array, right? Right now it might work because you are manually creating the array list and putting the numbers into it. But your logic should be valid even in cases of there are no numbers in the array. The array list is empty. Right? In that case, if you're trying to access the first element and assign value as max, that might fail because that array list is empty itself. Okay. So this is the way we are creating a 2D array list. Okay, let's break it down one by one. First thing is this line. This keyword is clear. We are just writing a variable name called 2D array list, and then right hand side it's clear that we are using a module or a library of array list and initiating an object of array list. Okay, now comes to the main part, which is this one. This defines what exactly is our variable all about. Over here, what you see is array list contains an array list, right? But instead of having strings and integer, you see an object. And that's the way you create a mixed data type 2D array list. Okay, using an object. How do we create 3D? 3D would be similar way, where you just copy this thing up. And then paste it inside the object this way. Okay, obviously you'll have to change the object, which I'll go through, but initiation will be like this. Now, once you have done that, you have to manually put up the rows. Okay, you'll have to manually put up the rows and create the rows. Rows are nothing but the individual value of that 2D list. 2D list you can imagine as an example of, you know, this thing what we talked about, right? 1 2 array. What is this? 1 2 3 4. Okay, so over here what we have is, can't we add a row? Once yeah, so we are, what we are doing over here is, the first is the integer and second is a string. Okay, can't we do row dot add? No, you can only pass one parameter, Vaibhav, not two parameters at a time. Remember the add functionality what we discussed about. Add will always take one parameter. Okay, and that's where over here what we are doing is, we are creating row 1, which is an array list of object using new array list, and then we are putting the values of that first row, and after that we are adding that row in the 2D array list. But this is not this is something you won't find commonly being used. Okay, so you don't have to stress about it. It's just that I wanted you to be aware about how do you create it. Okay, so this is about creating the row and creating first two rows, followed by accessing the elements. Now to access the element, you just have to append the get function twice, right? So integer element, if you're trying to access the integer part, you need to have integer data type, else string data type. Also, you need to typecast it because it's an object. It will return you as an object, and once you typecast it, you'll be able to get the original data type. Okay, first way is, this is something I showed you, right? And it worked, correct? That we iterated from first element to the last element in the words. And if we found apple, we removed it, right? This works. I think there is no confusion on this one by anyone. Okay. One statement was, what if we remove the if statement, right? And it iterates from first element to the last. And in case, I mean, for every case, it tries to remove the apple. This will work as well. The reason being, it will iterate through 5 times. 3 out of 5 times, it will find words.apple over there and it will remove it. Okay. The question was, what if there are no apples in the code? Will this throw an error? Someone asked that. It will not throw an error because It just tries to remove the apple. We're not, it would not throw an error. Let me run this code as well. So it contains banana and cherry only, and we are trying to remove apple, and it did not throw an error. Okay, so this code will also work, that looping through and then removing apple. Now another response was, what if we remove the for loop itself and we just do remove words dot remove apple? Okay, let me uncomment this first. Let's try to run this code. What did we get? Banana, apple, cherry, apple. It only removed the first occurrence. Banana, apple, cherry, apple. These are as it is. It only removed the first occurrence. Hence, it's important to have the for loop in place. Okay, so that it runs exact number of times as you have the elements in the array. Till this part, is it clear to everyone? Solution won't work for continuous apple. Which solution would not work for continuous apple? This solution, Tammy. Okay, so what we see over here is it's trying to remove apple, and we still got 2 apples left. All right, so now this solution will take place till words, which is an array list, contains apple. So over here, we are not dependent on size of the array list anymore. It's independent of the size of the array list. It only depends upon the presence of apple in the array list. Until the time it is present, words dot remove apple will execute, and it will remove the first occurrence of apple. Now let's try to implement this, run this in the same number of apples. So now we got an empty list. Now if we change it anything to banana and let's say cherry, it gives you cherry and banana, removing all the apples. Okay. Yes. So we did get the result by going one level back, because obviously the size got truncated. Okay. The only reason is this will improve, this will increase the number of iterations, right? So right now we have only 5 elements, so it doesn't make much sense over here. But let's say we have 5,000. Okay. So in that case, it might be multiple back and forth. So here is the solution. You create the array list. You drop elements in the array list anyways using for loop. You put the 1 2 3 4 continuous things, or use random. You need to count 2 things: number of elements and their sum. How will you calculate the sum and the count? Using for loop approach. I hope by now you should be able to understand this approach. What we are doing is int num, numbers. Basically, what does it do? Num takes the value of all the numbers one by one in the for loop. So let's say we have numbers equals to, for example, we have numbers equals to 1 2 3 4 4, anything like that. So num will keep on taking value of 1 2 3 4 like that, right? So that's what this basically makes sense. I hope by now you should be able to understand that. And if it's a even integer, this is something we have already covered. If modulus of 2 is equal to 0, that basically means if you divide the number by 2, remainder comes out to be 0. That means it is even. You count it, and also you include it in the sum. And using double, you get the average. Okay. Start putting the second question, guys. All right. Now Navya has given the solution size. Okay. Second Mac. Okay, perfect. Tammy. Kavya. Okay. Akshay. Why less number of people? I saw only 4 solutions over in this question. 5. I'm not able to solve as fast. Okay, no problem, Surveys. Take your time. Raj has given solution as well. Emmanuel has also given the solution. All right, so I'll put my solution and explain it. People who have not done it, I mean, that's perfectly fine. You can see the solution and take the third question as homework, which you can practice later. So this is just a slight modification of finding the largest number. Over here, what we are doing is we are creating the array list, adding the elements in the array, and then instead of one variable, we are creating 2 variables. Okay, instead of creating one variable, we are creating 2 variables. The 2 variables are largest and second largest. Okay, and then same thing we are doing for loop where we are using num as a variable to iterate through all the numbers that we have in the array list. If num is greater than the largest, which will be always true for the first time, because largest is the minimum value of an integer. Okay, so if number is greater than the largest, second largest becomes largest, and largest becomes the number. Take your time to see the code and digest it. Only till this point. Clear to everyone? Else, if number is greater than the second largest, it can also happen that number lies between the largest and second largest, and number is less than the largest. Then second largest becomes number. Okay. So in this case, what are we supposed to return? We are supposed to return 7. And then second largest, we are supposed to return as 6. So basically, to the solution, we should be able to return 6. Correct? Okay. Now, largest and second largest are integer, minimum value of the integer. So this will be always way negative, the minus minimum integer value it can hold. And now we are iterating for loop from num to numbers. So basically, one by one, num will start taking the value of all these numbers. First time when if statement arises, num is greater than the largest. Num is 6. 6 is bigger than minimum value of the integer. So second largest will become largest. Let's keep changing over here is second. We'll keep updating over what is the value currently these guys holds. Just array. Okay. First time mein, these both were minimum value, but once the while loop has gone in, second largest is equal to largest. So value of second largest will be equal to largest, which is this, and largest will be num, which will be 6. Right? Clear? And next time, else statement, it will go num greater than second largest is not true. Right? Num right now is 6 we have, and it is not greater than second largest. Okay, hold on, guys. If statement has executed, so else will not execute, right? Okay. Next time, when num goes to 4, 4 will be compared with the largest. 4 greater than 6, which is false. So it will go to else part. Now, 4 greater than second largest. Second largest is integer minimum value, which is true, and 4 less than largest, which is also true. Then second largest will take the value of the number. This will become 4. Okay. Similarly, it will go on and it will give you the value of largest and second largest, right? We just saw these two cases, right? 6 and 4. Between these two, 6 is largest and 4 is second largest, and it was able to, the statements were able to collectively segregate them into largest and second largest, right? So that's how it works. Next time also, when 8 comes, largest will take the value of 8, second largest will take the value of 6. Okay, and so on.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards a career growth with the full stack developer course.
Now, linked list, if I just give a brief before we go ahead, it's a data structure which is slightly different than what we have been seeing so far. Okay. And if I just give you a quick introduction about linked list, a linked list is a data structure which can change during execution. Now, the unique thing about linked list is the successive elements in linked list are connected by pointers. Now, what exactly are the pointers is something we'll be discussing in this session as well. But linked list is something which has two parts. One part contains the actual data, and the second part is the pointer part, which points to a next element. Okay. Now, if I show you a quick brief of how linked list looks like, this is a kind of a structure which you see in the bottom. A, B, C is a linked list. Okay. In this linked list, there are 3 elements. Each of the element has 2 parts. First part contains the actual data, and the second part contains the pointer to the next node. Okay. Last element points to null because after the last element there are no elements, and hence it points to null. And the unique thing about linked list is summarized in these 5 points. The first one is successive elements are connected by pointers. Okay, it's not a continuous allocation of memory. In case of arrays or in case of linked list, it gets allocated in a continuous form. That, let's say, memory location 1 contains the first element, then memory location 2 will contain the next element. That's how those data structures are usually stored in the memory of a system. But in case of linked list, these memory locations can be at different positions. Okay, irrespective of whether they are adjacent to each other or not. And hence we require pointers that can connect one element to the other, even though the location are not continuous. Last element points to null. Okay, that you can see the element C, the pointer of element C is pointing to null. This is the kind of structure we use if you want to point something to null. Third aspect is it can grow or shrink in size during execution of a program. Just like ArrayList, it can grow if you need more elements. You can add more elements, as well as you can remove elements from the linked list. It does not disrupt the rest of the elements because each of the elements are stored in the independent memory locations. They are just connected by pointers. So if I start pointing A to C, right, we can somehow delete B from the linked list. We'll cover that in detail, but that is how it can be done. Hence, it says it can be made just as long as required. Also, it does not waste memory spaces. Now, how does it not waste any memory space? Remember the initialization of array, how we used to do it. Let's say we need number of elements which can grow till 100. So we initialize an array of size 100. But let's say we ended up using only 10 elements, or we ended up using or adding only 20 elements. So 80 to 90 free spaces will get wasted, right, from the array, because we allocated those spaces for the array. But that does not happen in linked list. We are not allocating any memory space till the time we do not need it. Okay, so that is the significance of linked lists. Some nomenclature. First element, we call it as head. Okay, that's the nomenclature we use. So if we say that this element is a head of a linked list, that basically means that is the starting position of a linked list. Okay. All right. So how do we keep track of a linked list? There are two nomenclatures, as I mentioned, head or start. You should know the pointer to the first element of the list. So basically, we are able to get access of a linked list using a pointer variable, which is called as head. Now, what is pointer? What does it do? We'll cover that eventually. But just now understand, head is not a data. Head is not something that contains a data like ABC. Head is just a memory location. Memory location that tells us address of A. If we know memory location which is contained in head, we are able to get the start of the linked list or the head of the linked list. Okay, that's how we track a linked list. Now, linked list provide flexibility in allowing the items to be rearranged efficiently, inserting an element and deleting the element. None of these cases wastes any memory, or it's very much easy and possible to allocate any element in between the list, start of the list or end of the list. We'll cover that in detail eventually. Now let's say insertion. Let's talk about how do we insert the element in the linked list. Once we cover things theoretically, we will cover on the code aspect as well, but let's see how do we do that. Let's say we have a linked list called ABC, where A is the head of the linked list and C is the last element of the linked list. And we want to insert this element X into this particular linked list. Okay. How would you do that? And let's say we want to insert it between A and B. The best way and the only way to do it is by changing the pointers. For now, our head pointer or the start pointer is pointing to A. And we are not going to change the position of A, because even after we insert X between A and B, the start element will still be A. Correct? So though no change has to be done on the current or head or start of the index. All right. But if we want to insert element X, what we want to do is we want to alter some pointers. What we are trying to do over here is, previously A was pointing to B. Without changing memory location of A, B, or C, what we will do now, we will start pointing A to X, and the pointer of X will start pointing it to B. So it will appear something like this, right? And that's how, without changing memory location of A, B, or C, we are able to adjust element X between A and B. Is this clear to everyone? At least theoretically, is it clear to everyone? I know implementation wise, we have not even touched upon that. Yeah. Will you share this PPT file also? Yes, Megha, I'll share that. You can also take a screenshot as well. I mean, that's not a big deal, but I can share. I'll share with Aman. I think Aman is the point of contact for you all, I believe. So someone from Intellipaat, I'll share this with them, and then they can share that. All right, now let's come to deletion. Let's assume we need to delete item B. I think you all can guess it very efficiently. What we are trying to do over here is, you don't have to do anything. You just have to start pointing, instead of A pointing to B, you need to start pointing A to C. How it will look like? You start pointing A to C, and then you free up this memory location space by deleting the element or by deleting the data stored in the element, right? That's all is required for deletion. Okay, so it's all about the rearrangement of the pointers, but B has still memory associated with it. Then how it memory efficient use? That's what I said. Once you have changed the pointers, you can use, depending upon what language you are using, either remove the element or delete the data, or just some languages already have the garbage collections feature, so it will be taken care of. But if you're using, let's say, C or C++ or Java, you will have to delete it. The data deletion has to be done by yourself, but from linked list it will be removed. Okay, so in essence, for insertion, a record is created holding the new item, right? You create a record, you create an element. The next pointer of the new record is set to link to the item which is to follow in the list, and the next pointer of the item which is to precede it must be modified to point to the new item. Basically, it's summarizing what we did in the insertion part. And deletion is quite simple. The next pointer of the item immediately preceding the one to be deleted is altered and made to point to the item following the deleted item, right? That's what it's just summarizing the things what we have already covered in pure text form. Now let's compare some of the aspects between arrays and linked list. So there are certain benefits for arrays and there are certain benefits of linked lists. If I talk about benefits of arrays are inserting and deleting an element at the end. You can insert the elements only at the end and delete the element. If in order to insert element in between, you need to have a proper shift of all the values and make free spaces, all that pain you have to go through. Hence, from the ends, you can insert the element or delete the element quite efficiently in case of arrays, right? Because arrays are continuous allocation of memories. That's one suitability, that inserting and deleting an element at the end is suitable, not at the beginning, only at the end. And second is randomly accessing an element. You can do it quite efficiently in unit time complexity if you are using arrays. Also, searching the list for a particular value is efficient in terms of arrays. You can easily sort it. You can use multiple sorting techniques, or you can just iterate through the arrays and look for the element, right? So these three aspects becomes a suitability point of arrays. If I talk about linked list, inserting an element and deleting the element is suitable in case of linked list without altering the memory of any of the elements which are already present in linked list. And how does it happen is something we have already seen through the diagrams and practical approach and theoretical approach. It is suitable for applications where sequential access is required. Okay, where you're not required to access a particular element from middle of the list or randomly access the element. It is not suitable for those. It is suitable for applications where sequential access is required. Okay, and the best and the most suitable use case for linked list is in the situations where the number of elements cannot be predicted beforehand, where we do not have the clarity about how many elements are going to be stored or be required to store. When there is that uncertainty, linked list comes into suitability factor. Okay, any confusion till this? Please keep letting me know the questions. Farooq has a question. What are the industrial implementation or uses of linked list? These all aspects, Farooq, if it meets the requirement, linked lists are suited. Okay. Types of list. Now, linked list itself can be of multiple types. We just saw one type where one particular element was linking or was pointing to another element, right? But depending on the way in which the links used to maintain adjacency, several different types of linked lists are possible. And we'll discuss all of those one by one. One is linear singly linked list or simply linear list. This is the one we have discussed so far, where one element, the head element, points to the next element points to the third element, and then if it is the last element, it points to the null. Okay. Other one is, this is a representation of linear singly linked list or simply linear list. There is something called circular linked list. Circular linked list is something where the pointer from the last element in the list points back to the first element. Now, if I show you the representation of it, this is how it might look like, where head points to A points to B points to C, but instead of C pointing to null, C is pointing back to A. So that is circular linked list. All right. Third type is doubly linked list. Doubly linked list is something where pointers exist between adjacent nodes in both the directions. So what did we see in the simple linked list? The pointers were going only in one direction. It was unidirectional, right? But in doubly linked list, it's bidirectional. The list can be traversed either forward or backwards. And hence, to keep track of the two pointers, these linked lists do not have just two parts in each element. They actually have three parts. The first part contains the pointer to the previous node. The second part contains the actual data. And the third part contains the pointer to the next element. Okay, and we represent it by head and tail, the first pointer and the last pointer. So this is how it might look like. Okay. The pointer which is going away from A towards left will be pointing to null, and the pointer which is going towards right from C will be pointing to null again. This pointer which is coming towards A is called the head pointer, which is represented by head. And this pointer which is coming towards C, represented by tail pointer, which is called tail. Okay, so let's hear about some basic operation on a list. Okay. Very first thing is creating a list. That creating a list basically means you create a single element. You divide that element into two parts, which one contains the pointer and one contains the data. And then you create similar elements multiple times, and then you join the pointers according to what you're trying to achieve, and then you create a list. So that is the most basic and the first operation usually that goes around list. List is basically linked list is something that what you're doing. Next is traversing the list. Traversing the list basically means just like we used to have for loop and while loop in case of arrays, where we used to traverse the elements present in the arrays. Traversing the list basically means going through each of the element. Okay. Third operations is inserting an item in the list. Just now we discussed, if you want to insert a particular element in the existing list, we can append that item at any point, be it start, be it middle, or be it the end of the list. Fourth is deleting an item from the list, which we saw right now. If you want to delete an item from the list, we can do that by the approach that we followed by changing the pointers and altering the pointers. Okay. And fifth one is concatenating two lists into one, which basically means, let's say if you have two different lists and you want to concatenate into one, how will you do that? It's again the game of the pointers that we will be discussing once we talk about the implementation. Okay, so linked list, if you talk about practical, there's a question from Mayank that, but practically where all these used? This can come handy at various different places, Mayank. Now, if I talk about a real world example that you might be able to relate it more efficiently, just like any music player that you use, right? The next button or the previous button, right? Behind the scene, they might be implemented on a linked list, right? Because you do not have a fixed number of songs in your playlist. If you use Spotify, if you use JioSaavn, or you use Geo Music, anything of that sort, you can have n number of songs in your playlist, right? So definitely arrays is not a suitable option for the developer of that app to have that as a data structure. So linked list becomes a most handy and usable data structure for such applications where the number of items are not defined. So next button will be acting as a next pointer that can take you to the next element. Previous button will take you to the previous pointer. So it might be a doubly linked list kind of a structure. So that's a one and the most common example. Back button in browser is circular linked list. Back button in the browser is circular linked list. No, how come it will be circular linked list, Sanket? It circular linked list basically means you keep hitting back button and you eventually land up in the same place where you started, which is not the case in the browser, right? Browser back button in the browser is single linked list. It will only go in one direction. Doubly linked list, it can help when you are talking about both back and the forward button, going back and going forward in the browser. And that's what we are going to talk about right now. So list is an abstract data type. And when I talk about what is an abstract data type, it is a data type that is defined by the user. So linked list in itself is just a concept. You can just assume it as an empty truck. Whatever you want to fill it with, it's something can be defined by the user. Okay, typically more complex than simple data types like int, float, etc. Okay, it can be as per what user has defined and created the element of. Okay. All right. So conceptual idea, I think we have covered that these are the most common functions: insertion, deletion, and traversing. Creating a list, if I talk about, let's head to the Java point, and let me start sharing that particular part. Okay. So let's talk about how do you implement linked list in Java. Just like yesterday, when we talked about ArrayList, we imported the package called java.util.linklist, .ArrayList. In this case, we will be importing java.util.linklist. Okay. Very similar to what we have already done. Exact same syntax is followed when we create linked list using Java. All you have to do is use the linked list keyword, insert the value of the string, the data type of what you want to have in that linked list, and create a new linked list like this using the object method. Okay. Similar to that, we have a function called add function that you can use to add elements in linked list. And once you print it, you will get what is required by you. Just like integer list, just like array list, you can have integer as well created in the linked list. And instead of strings, you can add integers, and you would find integers getting printed once you try to print the linked list. Okay, so that's how the creation of linked list can be done using linked list part. Now let's come to some operations that linked list had, or some methods that linked list has. Okay, The very basic and the very first method is add first method. Okay, add first method. Now you can imagine behind the scene how it must be happening, right? You know the structure of linked list, you know how it works. So add first basically adds the item to the beginning, and then you can imagine by yourself how pointers gets changed. The head pointer will start pointing to the Mazda, right? The new element, and the pointer from the new element will start pointing to Volvo, which was previously the start of the linked list. That's the add first method. Okay. Next method is add last. That's also a simple approach where you can add something towards the end of the linked list just by using the method called add last. Okay, I hope it makes sense. Any confusion so far, please let me know. We are dealing with a most basic linked list right now, only strings part. We will come to some complex linked list as well. Okay, but right now, let's try to just go ahead because I don't want some people to get left behind. Just like that, we have remove first and remove last. What will happen if I do remove last? Let me first comment this out and print the element. It prints all the values, the 4 car names that we have. But now when I execute cars.remove last, it will basically remove the last element. Now, Vaibhav, your question was, how does it take care? Because memory will still be left. This will be taken care by remove last function itself. This function is responsible for not just changing the pointers, but also garbage collection and removing the data that we had stored in the element which was containing Mazda. Okay. Similarly, if I do remove first, Volvo will be deleted and BMW, Ford, Mazda will be printed as part of the remaining items in the list. Okay. So we just discussed add first, add last, remove first, remove last. Now, just like the pointers, can we also restore the deleted element? No, we can't do that, Prachi. Once we delete it, the garbage collection takes care and deletes the element altogether. So we can't do that. Okay. So this one is cars.get first. Cars.getFirst basically prints, or sorry, gets you the first element in the linked list. Okay, because it is in linked list, it is not possible to index out the elements. You can't give the index and get the item. I can't see that what is the element and data in the second element or third element, right? You always need to get from the first element or the last element. So get first will remove you. We will give you the value which is present in the first of the list, which is Volvo. Similarly, get last will give you the item from the end of the list. Okay, get last will return you Mazda. Okay, now before we begin, I just want all of you to write a simple program, only one program, nothing more than that. Write a program to create an integer linked list. Okay, give 5 random values into it. Okay, and remove the last element and print the first element. A simple program so that everybody knows the implementation approach and they are on their toes to implement this. I would repeat, remove the last element and print the first element. 5 elements has to be there, random 5 elements, 5 integers, and the program should be able to remove the last element and then print out the first element. Okay, please do it. Not more than 5 minutes. You should just take it and to finish it off.
Okay, great. Now we'll just talk about slightly advanced concept that would need a substantial amount of time for you all to understand and go through, which is insertion of linked list, insertion of element inside the linked list. I keep missing the ID link. Okay, this is the one. All right. So guys, we are going to talk about two different approaches of inserting an element inside a linked list. One will be by using whatever we have created using the linked list of the Java util package. And the other approach we are going to talk about is the approach where we would not use any of the inbuilt package of Java. So that as a academic section, you would be able to understand what is exactly going behind the scene. All right. Okay. So let me just put the code over here and show how does it work. Now, instead of putting it in the beginning or in the last, we are trying to insert a linked list in the middle. Okay, let's say we are trying to insert the element right after the third element. What are we doing over here is we are creating a linked list of integers, and then we are putting random linked list 1 to 5. Okay, for the ease of understanding, let me print out this linked list as well. So now you see 1 to 5 gets printed. Okay. Now let's say we want to insert a number with value 10 in the middle of a linked list. We are going to use two inbuilt functions. The first is dot size, which gives you the size of the linked list, which is equals to 5. And then we divide it by 2 to get the kind of a midpoint. The result of this would be 5 divided by 2, which will give us 2 because it's an integer and it will return you the floor value of the division. Now the middle position, the value of middle becomes 2, and right in the next line, we use this function called dot add again, where if you pass two parameters, it's kind of a constructor overloading here, absolutely above. If you pass only one parameter, it assumes it as the value that needs to be inserted. I'll repeat that, Shubham, no problem. And if you add two parameters, the first gets assumed as the index where you want to add it. And then the second one is the actual value. Now, if I try to print it, it will give me 10 in the index of 2. Okay, so index of 2, I got 10, and that's how I was able to insert the element in the insertion. Okay, what if you want to add after 4? That's the exact thing I want to give you all as an assignment to do it in the next 5 minutes. Try to do it if you want to do it right after 4. How will you do it? Between 4 and 5, I want to insert it. How would you do that? Using the index, obviously, but just try to write a code for that. Everyone, this was the approach where we try to follow the middle index. If you want to write the find middle of middle, no, Vaibhav, no. Just use the index approach. If you want to add something, add the second last position. Let's say the question is add this element in the second last position. How would you do that? That's the kind of assignment. If we want to assume two parameter that is index. What is your question, Nishant? I did not get it. Sir, please repeat why we have to divide by 2. We had to divide by 2, Shubham, because we are trying to insert the element in the middle of a linked list. Right? How would you get the midpoint of the linked list? Right now we had 5 elements, so it's easy to just visualize and say, okay, the second pointer or the third pointer, third index or the second index will be the midpoint. But let's say you have n. You do not know the size. How will you make sure at what index you have to put? You have to divide it by 2, right? That's the reason. Is it clear, Shivam? Okay. Everyone, please write a Java code that can insert an element in the second last position. Okay, cool. So we didn't have to do anything. All we had to do was, you don't need this middle index anymore. All you can do is dot add functionality, And when you have to put the position, the index, what you can do is you can use the dot size approach and put -1. Okay. Now, if you execute it, 10 will be stored right before fourth element, right after the fourth element and before the fifth element. Okay, clear to everyone? Okay. Now there is one thing I'm going to talk about that is also a inbuilt functionality, and that is something like this. You can, one second, why is it not taking up like this, man? Okay, cool. What you can do is you can iterate through the list using index of function to get the value of the index in which a particular target element is present. Now, when I say target element, let's say I want to check if there is a number called n equals to 4, let's say, right? Is it present in the list or not? What? Okay, in the linked list or not? What I can do is I can create an integer called target index, and I can search using linked list dot index of n. This function will help me to return a particular index of the element. So right now, my question was insert an element after 4. Okay, but then I changed this to insert the element at the second last position. But let's say the question actually says put the number, insert a number after number 4. Let's say that is the question. Okay, and you have no idea where is number 4 in the list. It could be at middle of the list, it could be at last of the list, and this is also not visible to you, let's say. So you would need to find the index of 4, right, in order to place the new element at the right part, right? For that, this particular index is going to come to be handy. That is the function of index of. All right. Now, when I try to print this index, target index, what do you think would be the answer of target index? Ayo. It will be 3, because the index in which it is stored is equal to 3. Now, what if I try to search for 10? How it gave result 3? Okay. What is the index of number 1? 0. So index starts from 0. For 2, it will be 1. For 3, it will be 2. And 4, it will be 3, right? Got it? Okay, cool. Now, I change value of n to 10. And now I am trying to print the target index by figuring out, okay, it will be null. Okay, that's an interesting answer. What do you think, guys, rest of the people? What will be the answer? Error. Okay. What else? Error. Let's see. Let's try to run and see. It will give you -1. That represents the number is not present in the list. All right, cool. So we'll move on to discussing one of the approach using which you can loop through a linked list. Okay. There are multiple approaches of looping through the linked list. I'll give you one approach using the iterator. Okay. Obviously, though, there are some people who have already done it by using get functionality and stuff. Same way what we did for ArrayList yesterday. But there is something I want to discuss with you, which is around using iterators. Okay, so what is this? Guys. Okay, let's create a new linked list called strings, and we inserted apple, banana, orange in that string. Now, using iterator, basically my aim is to iterate through this list. Okay, one way is to create a for loop and then just go from I equals to 0 to I to size, and then using get functionality, keep getting the values. That's one way. Second way is iterator. What is iterator? Iterator what does iterate mean? In literal terms, Prachi, iterate basically means that you walk through the data structure from the first element to the last element. You traverse from the on the data structure from the first element to the last element. Okay, and iterator is a inbuilt method that is present in the java.util.iterator package, which you need to import if you're trying to use iterator. Okay, how to use it? You use it in a way where you create a iterator variable using iterator method on your linked list. Iterator is a built method. Okay, so the thing is, the built-in methods are case sensitive above. So we are able to use it because we have used in the small I, right? I mean, I can change it off. I can do it as IN as well, or let's say we can use it at X as well, anything. But iterator is an inbuilt method. That's why capital I would not work here, but small I will work. Right? It's the names are case sensitive. Make sense? So you need to specify what exactly do you need to iterate. If you're iterating through a linked list of strings, you have to create an iterator of string data type, create a variable name, and then start the iterator on the linked list. It's being used as a method above over here. That's why you are able to do it, and iterator can be used as a variable as well. Yes, data type of the iterator should be same as the linked list. Once you have created this, what you can do is you can start a while loop with iterator dot has next. Once you do this line, iterator starts pointing to the first element of your linked list. Okay, which basically means if that first element has a next element, this loop will keep going on. So basically, this loop, the loop will keep going on till the time there is a next element present in the linked list. Okay, let me change the variable name, guys. Maybe that might be creating the problem. Let me put a variable name as I. Okay, now I change it to I dot has next, and then I do it I dot next. Okay, this iterator function can be used in multiple places as well. It's not only for linked list. This can be used for ArrayList as well. This can be used for any synchronous category of data structures. All right. So iterator method is actually provided by every collection class. I think till this point, everything is clear. There is nothing to be repeated. Correct. All we have to do is repeat this point. What we are trying to do over here is first we are trying to define the iterator variable. What the iterator variable will be always equal to the iterator keyword along with what exactly are we trying to cover. Let's say we are trying to iterate through a linked list. Let's break it down into two. Okay, this line should be clear to everyone. First, right hand side, what we are doing is whatever data structure we have, we are putting an iterator keyword on top of it, iterator method. This basically says that we are going to iterate through linked list. This could be array list as well. This could be array as well. It could be anything. But dot iterator basically says that we are going to iterate through this particular data structure. And then iterator string defines the data type on which we are going to traverse. Since it is a linked list, this iterator keyword is compulsory. Okay. And since it is a linked list of string, we are putting a string over here. Okay. Now, once we create this on top of a linked list, this I starts with the first index, the first element. The first element of the linked list I starts off with. Using that, we can create a while loop and use the has next method. This basically says if, and this will always return you a Boolean value. This will be either true or false every time. When I, which is the first element for the first instance in the first loop, I is pointing to another element. It's not pointing to null. If it has a next element, this statement will be executed as true. Okay, once this statement is executed as true, we will be executing the below statements. And below statement is we are creating a new string not named as element, and we are doing I dot next. Okay, now two things are happening over here. Let me first execute this statement and showcase you what exactly happened over here. Okay, let me just comment out this second approach. So it basically is printing out apple, banana, orange every time. Okay, so guys, this is something, the while loop is basically looping through the elements of the linked list, right? If I show you in the way how we are envisioning it, let's say it's a head pointer. Let's act as a one. Right now we have renamed it as I. This is iterator. Okay, and this I is pointing to a first element of linked list, which is containing apple. Okay, and then apple is pointing to banana. And then banana is pointing to orange. Okay, this line has initiated this particular part. Okay, clear everyone? And then inside while loop, what we are checking, does I pointer has a next element? Does I pointer has a next element, which is true? We have a next element called apple. Hence, this while loop came as true. And now what we're doing inside is we are creating a new string called element, and we are putting as I dot next. So basically what will happen? I dot next will be apple. So now this will become as element. Okay, I hope that's clear everyone. And next statement, we are printing out the element, hence apple is getting printed. Okay, and this automatically has next takes care of switching from it to next variable. Okay, I dot next. So I will be at this position. First of all, Navya, did you got the clarity? What is the use of iterator? Iterator uses, if there is no iterator, you'll have to write the whole for loop function where you have to calculate the size of the array, size of the linked list, iterate, create a new variable called I equals to 0, iterate to that, and then use the get functionality every time, right? Over here, you are doing the same just by using I dot hash next. Iterator is taking care of everything in terms of making sure that it's looping through the whole linked list without worrying about the size or worrying about any additional variable creation. Okay, and also I dot next has a better complexity in terms of any other approach that you will take, because it's an inbuilt functionality. Does it make sense, Navya? Okay. First topic of iterator, Krish, I mean, we have just discussed these 3 lines only. So iterator is something, what I can summarize it as is a method that can help you to iterate through your data structure without you getting worried about the size of the data structure or creation of any variable that can keep a track of which element you are in. It basically abstracts those 2 requirements into a method called iterator, using which you can create your own iterator with your own variable by mentioning the data type that you want to access and appending dot iterator method on the data structure on which you want to iterate. Iterator is a class and iterator is a keyword. Iterator is not a class, Dipshika. Iterator, you can call it as a method. It's a method over here. And anything that you do it by dot, keyword, and then parenthesis, it's a method. And I dot hash next basically takes care of making sure that it's iterating through the whole array, whole linked list, right? And I dot I next happens that it keeps looping in automatically every time I next is called.
All right, so let me just run this to check if it is working, and then we'll discuss. Cool. So I don't think we need to explain this part. It's just creating a linked list, adding 1, 3, 5, and 2, 4, 6 into the linked lists. Okay, then I created a new list, which is now empty, which is called as merged list. Okay, first list is list 1, second list is list 2. Okay, I think so far there shouldn't be any confusion. We'll move on. And then I created 2 pointers, I and j, and initiated them to 0. Okay, now the logic that we need to apply. Okay, what before I go to the code, let me just talk about a logic. What are we going to talk about? We have 1, 3, 5, and then we have 2, 4, 7. What we are going to do is we are going to iterate through both of the linked lists at the same time. Okay, I will be iterating from the first one. Let's say this one will be I. This one will be I, and this one will be J. Okay, 2, 4, 6. Okay, thank you, Mansi. Yeah, it doesn't make difference, but yeah, thanks. So I and J we have initiated, and now every time we are going to compare I and J. Whatever is smaller, we are going to append that into our merge list. In this case, between 1 and 2, 1 is smaller. So we'll append that in the merge list and increment the I by plus plus. So this will go to this one. Again, we'll compare I and J. This time, J is smaller. So we'll append 2 in the merge list and do J plus plus. Okay. And then again, I and J will be compared. This time I is smaller. I will be inputted as 3, and this I will go like this. Make sense? And then eventually we will be receiving this as the output. Now, what if this case was the case where both the length of both the arrays were equal? Correct? What if one element is bigger? Let's say 7, 9, and then 10. This will be the final case, I and J position, right? Till the time we have got this. But now we see 7, 8, 9 is still there in the first array. Let's say this is a different case altogether. This is the case different than what I had given as the question. I just increase the length of the array. In that case, what we need to do, we need to create 2 different while loops as well. I'll come to that. Let's ignore for this for now. Let's first understand the code. I and J initiated to 0. While loop, we started it off. While I is less than list ka size. Size of the list is 3. I is 0. Both of this will get satisfied. I and J both are 0. Size of both the list is 3. Okay. So first time we are getting element 1 and element 2 from the list, which we were doing when I was here and J was here. We were getting the element 1 and 2. And then we are comparing. If element 1 is smaller than element 2, we are appending element 1 in the merge list and doing I plus plus, else opposite. Make sense? This will be enough if both the sizes are equal. Correct? But what if one size exceeds the other? Let's say both I and j reach the value of 3. Let's say over here I and j reach the value of 3. Okay. And size of first element, size of array, not list 1 is equals to 3, and size of list 2 is equal to, let's say, 7. Now what will happen? This statement will start failing because 3 is not less than 3. This will start failing. So doesn't matter this statement is true or false. While loop will break. Right? Hence, we need 2 more while loops to make sure the longer array, the elements of longer array, if the elements over here is 7, 8, 9, these 3 elements are also accounted and added in the merged list. Why? While this will anyway fail because I is now 3 and the list is size is also 3. But in case of j is 3. J is 3, but the size is how much? 6. So it will do nothing, but it will keep rest of the elements. It will take rest of the elements and add it here. And then we'll print out the merge sorted list with the merge list as an example. Is this code too clear to every single person? Anyone who did not understand this? I want to hear from everyone, the people who were able to do their code as well, because I didn't see this approach being followed very relevantly, everyone. Cool, makes sense. Let's say we have two lists, size 3, 135 and 246. Let's try to see how things goes in this while loop. Okay, this will answer Vaibhav's question, and this will also answer for the people who were facing problem in. And then post that, we'll talk about Dipshika's question about why these two while loops are required. Okay, first, let's just see the example of these two as a use case. We have I equals to 0, j equals to 0, and we started this while loop, right? These statement will hold true because I and j are equal to 0 and the size is 3, right? So this statement will hold true, and the element 1 and element 2 will be accessed using I and j. So basically, I is here and j is here. At any point, if someone does not understand anything, ping stop. Okay, just ping stop and just put the question, okay, right there. Okay, that's great, Dipshika, that you have understood. That's right. Okay, I and j are here. We are comparing I and j. And let's say we have third element here as merged list. Okay, we are comparing using this element where 1 less than element 2, which is true. Element 1 is less than element 2. So we appended element 1 and did I plus plus. Element 1 is 1 and did I plus plus. So it went to 3. Same thing will be followed. Now, I and j, 3 and 2 are element 1 and element 2. Element 1 is 3, element 2 is 2. This if statement will not hold true because element 1, which is 3, is not less than element 2, which is 2. Hence, else part will take care of, and element 2 will be added. So 2 will be added over here, and j plus plus, j will go over here. Now, again, I and j, element 1 is 3, element 2 is 4. Compare element 1 versus element 2. Element 1 is smaller. So element 1 will get appended and I will go plus plus again. Now, what will happen? Then again, I and j will be compared. Correct? And then 4 will take place over here. That is right. And once that is done, it will go to j plus plus. What is the value of I and j over here? 3 is the value, right? I mean, if you do list1 dot get I, you will get 5 and 6. But the integral value of I and j are 3. That's the reason this while loops will still hold true. Okay. Sorry, yeah, it's 2. It's 2. Guys, sorry, I also got confused. It is 2, right? A value of I and j, it's 2 because its index. First index is 0, second index is 1, third index is 2. Okay. Now this comparison will happen again. And now it will go to 5. How? Because element 1 and element 2 is being compared. Right? So it will move to 5. Now what will happen? I has moved to value 3. The value of I has become 3. Value of j is right now 2. Tell me yes or no. Will this while loop be able to append value 6 over here? No. Why? Why no? Why no? Not out of bound. That is not the right explanation, Vaibhav. Out of bound will happen if we try to access something which is not there in the list. The condition will fail. Yeah, it's not out of bound. It's the simple operational comparison operation will fail. I is 3, list ka size bhi 3 tha. The size of the list was also 3. Hence, this condition will fail. So 1, 2, 3, 4, 5 will get printed from this while loop. And we are left with j equals to 2, I equals to 3. Size of both the elements is 3. So next, this while loop will come. Over here, value of I is 3. Value of size is of list 1, 3. This will not hold true. So it will move to next while loop. Over here, value of j is, what is the value of j here, guys? Except Vaibhav, guys, tell me, what is the value of j over here? 2. How? Because we one. No, Deepshika. J will be 2 because the value sustains. Whatever value has been kept it over there inside while loop or whatever it is, since it was a global variable, the value will sustain. So we will have value equals to true, 2. Okay. And what is the size of the list 2? Size of list 2 is 3. Perfect. So this condition will hold true. And hence the second index value of list 2, second index value is 6. First in 0th index, first index, second index, 6 will be merged into merged array and j++ will happen. And that's where 6 will come into picture over here. And this explains, even if the sizes are different, it would not matter. Is this clear to everyone? What if extended list of 1 is 8, 7, 9? How will we sort it into merge list? It will automatically get sorted. Let's say. So you're saying 8, 7, 9 over here, right? 8, 7, 9. Correct? That's what you're saying, Vaibhav? Yeah, it will automatically get sorted, right? Should I do it again? Or let me just do it very quickly. The size will become 6. Size is 3. And let's say till 5. Till 5 it will be clear. Till 5, what is the scenario? Once 5 is printed, I will be here and j will be here. Till this point, are you able to understand, Vaibhav? This will be the situation when 1, 2, 3, 4, 5 is printed. Yeah. Now this statement will be true. 6 will get printed here itself. Yep. And now this statement will fail because j went out. And 7, 8, 9 will be printed by this particular while loop. Is it clear? Yeah, it has to be sorted. That's the requirement, Archana. Both the linked lists will be sorted. Yeah, it's clear, right, Vaibhav? Why? How come 8, 7, 9? Achha, 8, 7, 9. Oh, sorry. 7, 8, 9.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.
Now, before we talk about stack and queues, we need to understand two concepts first, which is first in, first out, and first in, last out. Okay. Now, these two concepts are independent of any kind of data structure. It's just like a simple concept. But the reference, I will be relating this concept with stacks and queues when we reach there. All right. Now, what is FIFO? FIFO is basically first in, first out. It basically means that first element that enters that data structure will be the first element that will leave that data structure. It's more like a queue that a simple queue, maybe, a queue in a ticket counter or a queue in a metro station. How does the queue work? The person standing in the first, as the first person who comes at the line stands at the first position, and that's the first person who leaves it. I mean, that's the first person whose job is done. A usual queue that we see in the real life. And that's exactly what first in, first out means. The element that enters the data structure for the first leaves the data structure in the beginning as well. And this concept is used by a data structure called queue. The spelling is Q-U-E-U-E. Contrary to that, what we see is there's a different kind of data structure which is called as stack. Stack is nothing but a data structure in which once the element goes in, the first element that goes in is the last element to get out. First element is the one who goes in is the last element to get out, or the contrary, what you can say is the element that goes in the last, that enters the data structure in the last, is the first one to get out of the list. Okay. And this concept is called LIFO, last in, first out. Okay. Simple concept. I don't think there is much of a complexity over here. And this particular concept of last in, first out is used by a data structure called stack. Okay. Now coming to the reference of stacks, just see this particular image. Now these are the 5 most basic functions that is used in stack. The first function that is used in stack is push. Push is basically making an element enter into that data structure. Let's say you have initiated a stack and you want to insert an element inside that stack. To achieve that, the function that we have and in Java to push the element is called push. On the other hand, pop is the function to get the element out of the stack. Now, this should be very obvious that let's suppose we have a stack which is containing 5 elements. We cannot perform indexing on stack because it's very clear that the only one element can get out of the stack, and that is the last element that entered the stack. Right? You can't just see what is the second element in the stack, what is the third element in the stack. That is not possible. That is not at all possible, and that is abstract to the user. The only thing that you can do is pop an element to see if the last element, what was the last element that went in, right? So push will push the element, pop will just give you the last element of the stack. The last element that went into the stack, it will just return you that. That is pop. Create is actually creating the stack, initiating a stack. Is empty is basically a Boolean method that returns you true or false depending upon if the stack is empty or not. If the stack is completely empty, it will return you true. And if the stack is not empty, it will return you false. And just opposite to that is full. Okay. If anyone has any confusion in any of these, please mention in the chat. I am monitoring the chat window. As soon as you mention something, I'll make sure that I answer that question. Sir, in real life, any example of FIFO or LIFO? Yes. So FIFO, a very common example, first in, first out. That, let's say, how many of you have faced a situation where you try to, see your 10th result? I'm not sure how many of you are from CBSE, but I faced a situation where when I tried to log into CBSE portal to get my 10th board result, it showed me an error saying a lot of people are there in the queue. Please wait before you see the result. How many? Anyone who faced this issue? I'm not sure. Maybe during my time, the internet was very slow. That's the reason I faced it. Okay. A lot of people have faced it. Great. And that is the concept of queue. Queue must have been implemented over there. Let's say the capacity of website handling a particular number of people is, let's say, 1 lakh. 1 lakh students or 1 lakh users that particular website can handle. And after 1 lakh, if any requests on that website comes, those requests will be stored in a data structure called queue. Okay. What will happen in queue? Let's say I tried to log in at 8 p.m. Someone else tried to log in at 8:01 p.m. or 8:02 p.m. Who should be given the access first? The person who logged in at 8 p.m. or 8:02 p.m.? Obviously, the person who logged in at 8 p.m. That means first in, first out. First in, the person who came at 8 p.m. should be the first one to get, the result first. So that's where queues are implemented. And that's an example of queue, Shubham. Mayank is asking, how is the limit of 1 lakh defined? You can define it, right? I mean, as a developer, I think you are already in the full stack development course. So through DSA, obviously it can't be defined. There are a lot of things that you need to understand, especially on the backend part. You have a backend scripting language, Node.js, MongoDB. You can define that. It's a, it's a hard coded value that you can put in the system that after 1 lakh, 1 lakh is an example. It depends upon the kind of system you have. Like Google can support billions, right? And if I make my project on my laptop, I might be able to support only 100, right? So it depends. Sir, can you please explain is empty? Is empty is a method, Yaman, which can return you Boolean response. Okay. Let me just go over here and show you. So these are 5 methods. I guess you are aware of the data type being returned. So let's say I'm writing a method, right? I'm writing a method void push. Now, why do I read void push? This method has void, but the second method of pop has int in it. We covered that when we were talking about functions, right? What is the data type? Why is there a difference in data type in these 2 methods? Because the first keyword talks about what is that the function returns. And when you're trying to insert an element in the stack, it doesn't return you anything, right? You just entered the element. You don't want that function to return or give you anything. So you push something into the stack, and the second parameter is the int element. That's the element you want to put in the stack. That's why the void is over here. But second case, the pop part is pop. You're trying to access the top element, right? Hence you have int over here, and you do not pass anything. You just mention stack. So whatever is the top element in the stack, you will get returned that. Okay. Third is create. Okay. Create is basically you can create a stack and initiate a stack. We'll talk about more in detail once we go to the implementation part of it. And the fourth one is empty. It checks if the stack is empty or not. No problem. Okay. In case, even if there is one element, it will return false. In case there are no element present in the stack, it will return true. That means it is actually empty. And just opposite to that is full. All right. I hope that's clear to everyone. All right, we'll move ahead. Okay, so let me just try to run this. I just wrote this code a couple of minutes back. Yeah, okay. Now try to observe this particular code, okay? Try to observe this particular code. Let me know if it is too small for you. I'll zoom in, but I believe it should be visible. What we are trying to do over here is we are trying to get the sum of all the elements using stack. Okay. What are we trying to do over here is, let's say we already have a array. Or let me show it over here. Let's say we already have an array like this. Okay, int array 1, 2, 3, 4, 5. But we want to calculate the sum of the elements of the array using stack. How will we do it? And that's the solution I'll be discussing with you that can give you an approach of seeing how to work with stacks. Okay. Now, if you see over here, I'm calling a function called calculate sum and I'm passing the array. I'm calling a function called calculate sum and I'm passing the whole array into this. Forget about last two statements. Just focus on this particular statement. Okay. Now let's see where is calculate sum. Over here, I have defined a calculate sum, which is taking the integer in the form of arrays. Now, this particular code talks about everything which you require to see how to calculate sum of all the elements in the array using stack. So the very first thing that we need to do is initiate a stack. That's what we have done over here. And this is very similar to what we discussed when we discussed linked lists. So I believe this doesn't need much of an explanation because linked list we spent close to 2 sessions to discuss. In stack, what did we do? We use the stack keyword, and before that you have to call the import.util.stack, java.util.stack, right? You initiated a stack using stack integer. Integer basically signifies that you are using an integer stack. You cannot have a heterogeneous mixture of a stack. In Java, all the data structures need to have only one data type. So hence, we are using integer stack. This name is a variable name. It could be anything. It could be as per your wish. And then over here, just mention new stack. Over here, you don't have to pass any data structures. Okay, there is one question from Shubham. Sir, in public static void main, we can use another like you are using. No, actually not, Shubham. What I'm doing here is, if you see, public void main has to be there. It's not like that you cannot use it. The order could be anything. I mean, first I have initiated the function and then I'm doing the main part. But let me, to avoid the confusion, let me do this. Yeah, so main function will be there. That's non-negotiable. It's just that I'm creating a calculate sum, which is a separate function altogether, and hence I'm initiating that function below over here. Okay, I hope that makes sense. So you can have n number of functions, n number of methods inside a class, but main method has to be there. Okay. Now in this case, what am I doing? I initiated a stack, an empty stack. Now what I'm trying to do is I am pushing each element onto the stack using the push method that we discussed. So for int num in number. Okay, I think this shouldn't be a confusion for you guys because I think we discussed last time as well. You can just, instead of this, you can do int I equals to 0 from I run to I0 to size -1 I ++. You can do that, or the very straightforward approach is int num array. What this will do is num will start taking one by one element from the array. So let's say array was 1 2 3 4 5. 1 2 3 4 5 is the array. In the first iteration, the value of num will be 1. Second, it will be 2. Third, it will be 3, like that. And then constantly, it will keep getting pushed inside the stack. So stack.push num. Push function, we already discussed. Stack, we have created. The name could be anything. For sake of, for sake of making sure that you're not getting confused, let me push only s.push.num. So with this, all my elements which was there in the array will be pushed inside the stack. Okay, now let's go ahead. Now we initiated. Yeah, you can use iterator method. This is the iterator method only. Shubham. Iterator means you're iterating through the array. So this is iterator. It's just that the way I have written the for loop is different, which is, I mean, Java 15 handles it. So that's the good thing to see. Else you can do I equals to 0, comma, I less than array dot size minus 1, array dot size and then I plus plus. You can do that. That's the same thing it's happening here. Nothing is different. And then I initiated sum. Sum variable equals to 0. Basically, current value of sum is 0. And then look at this particular statement. I'm simply using a while loop that is checking, or that is executing the below statement till the time stack is not empty. Try to understand this. Stack dot empty, it will return true only if stack is empty, right? But we want to run this loop till the time stack is not empty, and hence we have used a negation over here. So basically this is saying till the time stack is not empty, do sum equals to plus, I mean this is very equals to sum equals to sum plus stack dot pop. Is this line clear to everyone? I just want to hear from at least 10 people. I mean, people who do not respond usually. I want to hear from them. People who are new to coding. Is this line clear to everyone? From line number 26, what we are trying to do is, we are, in the layman term, what are we doing? We are popping elements from the stack. What is pop? We discussed. Pop basically taking out the topmost element from the stack. Taking out the element from the stack that entered the stack in the last. That is pop. Okay, so we are popping elements from the stack, and popping can be done only one by one. You can't expect to take out 2 elements at a time. It has to be done one at a time, right? So we are popping elements one at a time from the stack and calculating the sum. Okay, that's the layman English language explanation of what we are trying to do is. Okay. Popping is, popping will follow, not FIFO. Farooq, FIFO was for Q, remember? FIFO was from Q. For this one, for stack, we have LIFO. LIFO is last in, first out. So just imagine a stack. I'm not sure how much I can use the whiteboard, but let me try it. Okay, stack is basically, just imagine stack to be a container. Okay, what you can do is, when we push it, it goes inside. This is push. I'm trying to make sure that I write correctly and good handwriting. So please excuse if it is bad handwriting. I'm using the trackpad. Okay, this is push. And you can keep pushing elements. Once you push, first element will come over here, right? This is the first element. Or let's say, let me write first. This is the first element. When you push again, second element goes in. When you push again, third element goes in. And then let's say you start popping. Popping will happen like this. So which element will come out first? Element 3 will come out first. And 3 will be gone from here. Right? So that means it is last in. 3 came at last, hence last in, first out. That is stack. Just imagine stack to be a container. That's all. Okay, and you will understand it. So that's what we are doing over here. So while stack is not empty, till the time stack is not empty, we are popping it up. We are doing stack.pop, and we are assigning it to sum equals to sum plus stack.pop. And as soon as the is empty, as soon as the stack is empty, the highlighted portion will return me true, because stack became empty. With negation, it will become false. Hence, the whole while loop will become false and sum will be returned. And after returning, sum will come over here. It will be assigned to this sum. Right? And then just remove this line. Remove this line. And remove this line, and system.print sum of elements sum. Okay. All right. So I'll give you one more example. Let me remove this. That can give certain more clarity, and then we'll move on to creating and solving questions. Okay, so this is going to be a problem where we are going to see how to reverse a string using stack. Let's say input string is hello world. We are trying to reverse a string using stack. I mean, there are methods, inbuilt methods in Java where you can reverse string, but our whole idea is to learn stack. Hence, we are using the stack approach. Similarly, we are creating a new function called reverse string. You can do it in the same method as well. I just want that, the logic can be separately built. That will be easy for you to understand. That's why I'm using this approach. Okay, and then I'm printing out the original string and the printing out the reverse string. Reverse string I got from line number 7. Okay. Now in this particular part, let's closely understand from line number 12 what is happening over here. We initiated a stack just like before, and then over here you see the same for loop we are using. It's just that this time what we are doing is we have got a string input. Input is a string. We want to put each and every character into the stack one by one. Let's suppose if the character is Shubham, what we are trying to do is we want to push each character one by one into the stack. So what will happen? First time I would like to push S. What is happening? Push S, and then I'll push H. This autocorrect is happening on my laptop as well nowadays. Okay. And then we push U, right? So this is the way one by one I want to push. Input is actually a string. This was the input. I mean, input variable name. Input is a name, variable name over here, right? So what are we trying to do over here is I'm using char keyword, because if I break string into the individual characters, it becomes a character. So data type is character. And now I am using input dot to char array. Now remember, we discussed that when we were discussing about strings. In string dot to char array, if you do it, it will convert the string into a character array. So Shubham dot to char array, if I do, it will return me an array of like this. This and go so on till all that. I have actually more letters in my name, so won't go to all the one. So this will basically get returned. So now this is what I'm doing over here when using char array. And then for loop is using character C to loop in from one by one to all and push it into the stack. So now what will happen? Stack will have S will get pushed first, then U will get pushed first, then H, and then U will get pushed first, like that. So by this time, I will have my stack ready, where S will be at the bottom and M will be at the top. Here input is hello world. Yes, input is hello world over here. Let's change it to Shubham since we're using that example only. Let's do it like this. Okay. And now what you have to do? You don't have to do anything. First you use string builder. Okay, string builder might be new for you. So you just created a new string called reverse string. String builder is nothing fancy. Don't get confused. Just focus on this while part. Okay. We are using the same method of while stack is not empty. Till the time stack is not empty, keep popping elements from stack and keep appending it into the reverse string. Okay. And then return the reverse string dot toString. Dot toString basically converts the string builder data type into a string. Okay. Don't worry about string builder. Not much required over here. Just focus on the concept of stack. Right. So this was the example of the character array and character stack. How you can do that? It's very simple in the same way we did the input method as well. Okay. All right. Now let's run it to see how it performs. I have not ran it yet, so let's see. It's public, class public. Let me do this. Could not find the main method. Why is it failing? Yes, strings are immutable. Oh, 1 second, guys. There is some error in the code. Could not find load main class main. Public class. Let me put it main over here. Try to run it. Okay, great. It distorted my name. So basically now you see it got reversed, right? That's the thing. 29, line number 29, I think it was requested by Shubham. It's the same thing, Shubham. What we are doing is reverse string we created, string builder. String builder is a data type using which you can use the append method, right? So you created a reverse string, which is empty right now. And then by using append keyword, you are taking one by one from the stack, popping elements out, and you're putting it into that reverse string. That's nothing. That's a simple thing. That's the same thing that we discussed in the whiteboard part. So basically, S H U was inserted like this, B H A M, and then while popping, M got popped first and was appended into the string, right? And then A was popped and then appended into the string like that. And then H was popped like that. So that's why you see over here M A H B U H S being appended. Okay. All right. So the first question is write the same program that we discussed right now, because it's the first thing, new thing for you all. Very first program will be sum of all elements of an array using stack. That has to be the first program. People who are experienced in stack can skip this problem. Okay, I repeat, people who are experienced in this stack and Java can skip this problem. But everyone who are new to stack and first time they are doing it, they need to solve this. And this is the exact same problem which we discussed as an example for the first time in the first place, right? Second is write a Java program to check if a given string is a palindrome using a stack. Okay, that's the second problem. Third problem, write a Java program to evaluate a postfix expression using a stack. Now, before this, I want you all to do research about what are postfix expressions by yourself. Postfix expressions are not is not a technical term. Postfix expression is not a technical term, to be honest. So you can just Google it to understand what is postfix expression, and then write a Java program to evaluate if a string is evaluate a postfix expression using a stack. Basically, you'll have to write a postfix expression. You have to write some expression. Example, let me give you example like this over here. Okay, this is the example of a postfix expression. Okay, how it is a postfix expression, I would want you all to just go through web and understand, right? And when it says write a Java program to evaluate a postfix expression using stack, this kind of input will be given you. Let's use the same input. Okay, this is the input you need to use, and your stack should return you the answer. And I'll give you the answer as well, so that you are aware about what has to be removed. The answer using stack that you should receive will be 6. Okay, basically the value of this postfix expression is 6. All right. Next thing that I would want you to solve will be converting an infix expression to a postfix notation using stack. Okay, so once you have learned about postfix expression, try to learn about both will go hand in hand. Once you have talked about postfix, it will go infix as well. So the second problem is, that fourth problem is converting a infix expression into a postfix notation. I'll give you an example here as well. Okay, 1 second. Let me just get it right. Just a minute, guys. I'm trying to just see appropriate answer for this that can be used for test case. Just give me a minute. Okay. For example, the infix expression is this. Now, ABCD could be any integers or any numbers, right? You can just assume to be integers. And that's the infix expression, and the corresponding postfix expression would be this. Right? Let me just do this. Okay. So these are the question, guys. Let's start working on them. Yeah. So what I was saying is, time complexity wise, this is going to be slightly more efficient, but okay, I'll just give you a brief on this one. So what is being done over here is, first I'm creating a stack, and then I'm just getting the length of the string I have. Okay. Let's say the length of the string is, I think someone used the key as madam, M-A-D-A-M, right? Let's say this is the string. So what will be my length? Length will be 5. Okay. Half of the length, what will be this? This will be 2. Because 5 divided by 2 will be 2.5. And since it is an integer, it will take the floor value. It will be 2. Okay. Now what I'm doing over here is, for I equals to 0 till I less than half of length, I'm only going till half of the length of the string. And that's where the better time complexity comes into the picture of the string. Okay. So this is 0th index. M was a 0th index. A at first index and D at the second index. Okay. So what will be pushed over here? First time I is 0 and I is less than 2. Okay. So stack will have these values. First stack will have, let me put it in the way which can represent stack. So first stack will have M. Okay. In the first iteration, M will be pushed, right? Because we are starting from 0, and then I will become 1, and then A will be pushed, right? And then I equals to 2. I becomes 2. Just imagine this as a container, guys. Okay, don't imagine as a 2 different line. Just imagine these 2 lines as a container where M is below and A is on the top. Okay. And then I'm not pushing the D. I'm not pushing D, which is the second element. All right. So half length, the value of half length is 2. After 2 iteration, I will become 2. So this expression will fail. So only A will be at the top, M will be at the bottom. And that's the stack position. Now come to this particular line. We are putting start index equals to half length. Now start index will become 2. Right? We are just making sure we have pushed the half of the word into the stack, and then making sure the start index comes after it. If the length is odd, start index plus 1. In this case, the length of the string is odd, which is 5. So what we are doing is start index equals to plus equals to 1. So we'll make start index equals to 3. We are basically skipping the middle character for the odd length strings, because middle character doesn't make any difference in case of odd length strings. If you're checking a palindrome and that word has a odd number of characters, the middle character would not make any difference. Okay. So our start index will become over here as 3. Cool. Now what I'm doing over here is, I am starting from the start index, which is 3. I'm starting from A, going till the end, right? From A to end. And then I'm using the stack to pop the elements. So basically, I am checking these 2 elements, and stack is checking these 2 elements in this order. First A will be checked and M will be checked. At the same time, stack will pop A and stack will pop M. And same thing will be, we'll keep checking this. How many of you did not get this solution? Just tell me honestly. You face problem in understanding this. How many of you? Because this has slightly deep calculative concept. Let's suppose is the string. Madam is the string. M-A-D-A-M. what I'm doing over here is I am pushing only half of the word into a stack. Let's say it's a stack. Leftmost element will be a topmost element. I have that understanding. In this stack, whatever I write leftmost will be a topmost element. Just assume that. Now stack, how do we push? We push half the elements. So in case of madam, which is an odd number, we'll be pushing only 2 characters. But in the case of even numbers, give me a palindrome example which is even. Tam tam. No, it won't be tam tam. Give me a palindrome example, guys, which is even number of strings. Ma'am, okay. Okay. Yeah, that also works. Yeah. So in case of odd number, I'll be pushing the first 2 characters because not touching the middle one. Just take the half of the length of the string and push it. In case of even, it's very straightforward. So in both the cases, what will be the stack position? A and M. A will be topmost, M will be bottommost because we first pushed M and then we pushed A. Right? This is a stack position. Now, what I do is I put the start index. Start index, you can just imagine anything. Start index is just a pointer, just a index number. In case of odd numbers, I put the start index right after the middle index. So at this position, my start index will come. And for even numbers, at this position, my start index will come. And what I do is I just iterate through from start index till the rest. I just iterate through from the start index to the rest, and I keep popping the elements from the stack and keep comparing it. Now let's suppose from start index, I compare, I am at A, right? I will pop the element from the stack. Topmost element is A. It will return me A and it will be a match. Okay. And that's there. And then start index will move ahead, one step ahead. Right. And then stack will return M and start index will have M. Make sense? I mean, does it make sense? I did not go to the code. I just showed you the actual logic. Does it make sense, guys, for the people who did not understand? Okay, so I see there are 2 responses. One is AB plus C minus, and the other response is ABC plus minus. Okay, now we need to verify which one is correct. Okay, for that, what we'll do, let's discuss on how to convert a postfix expression into an infix expression. Okay, because if I give you AB plus, it's I mean fairly simple to understand that it will be A plus B, right? But let's try to understand how to convert postfix into prefix infix. Okay, and let's take the same example that we had. We'll convert this into ABCD, that is there. 6 to A, B, C, D, E. Okay. Now let's say we have this complex postfix expression and we want to convert it into an infix expression. Okay. I would need a whiteboard again over here. Let me use the whiteboard now. You guys will have to manage a bit because this might be slightly tricky. AB plus, let's say, let me write it over here. Okay, this is the expression we have. Okay, now let's try to see how do you convert it. Now, this is the most basic question that you would see commonly being used in case of stacks. All right, and postfix to infix conversion can be done only and only using stack. And how do we do it is something we are going to discuss over here. Now, let me take the pen. Very first thing that you do is, very basic rule that you follow is every time
you see a parameter as in A, B are the parameters you can call it as, and we'll call addition, multiplication, division, subtraction as operators. So whenever you see a parameter, just push it into a stack. That's the bare minimum rule. So I saw A, I pushed it into a stack. I saw B, I pushed it into a stack. That's a clear-cut logic. As soon as you see a parameter, push that into a stack till the time you do not find the operator. Now, once I saw an operator, which is a plus symbol, I do not push the operator into a stack. We do not push the operator into the stack. What do is we pop out top two elements. So what we'll do is we'll pop out top two elements. B will be popped out and A will be popped out. Correct? And what do is we using that operator, we generate the result of B plus A. The first element that got popped out will be the first parameter, and the second element that got popped out will be the second parameter. And we do the operation using the plus symbol. Okay. And the result of the both A plus B will be dropped inside the stack again. Whatever result we obtained, we'll put that inside the stack again, A plus B. Okay, make sense? Now let me do one thing actually. Instead of A, B, C, D, let me take the actual number that can, give us the actual values as well. Okay. Okay, so this was the number 6, 2. So our A equals to 6 and B equals to 2. So basically what is gonna happen over here is our A was equals to 6 and B is equals to 2. Just assume it is 2. Okay, I'm trying hard to make it work. And let me remove this over here. And what will the value over here will be? It will be 8. Because the result of A plus B will be 8. Okay, at any point of time, if anyone does not understand, please let me know. So we are reading from left to right. Yes, we are reading from left to right, Farooq. Okay, so we have covered till this point. Now 5 comes into the picture. 5 is a parameter. So we drop 5 inside the stack. And then we saw multiplication. Multiplication is an operator. What did we do? We popped out first two elements, which is 5 and 8. And we did what? Using operator, we did whatever operator asked us to, which is multiplication. So 5 into 8 became 40. And then we pushed back the result into the stack. So since we had already taken out 5 and 8, the stack would have been empty. Now I pushed the values. It's now 40. And we covered till this part. One second, did we cover till that part? No, we covered till this part, right? Now we had 8. We covered till multiplication part till now, right? Now we got 8. What will we do? We'll put 8 into the stack. And then again we got 4. What will we do with 4? We'll put that again into the stack, right? And then we got a division. Division is our operator. What will division do? Division will take the values out. So 4 will be taken out. And then 8 will also be taken out. And we'll do a 4 divided by 8. And then we'll insert the result into the stack, right? Any confusion? Sir, does the operator get pushed into a stack? No, operator never gets pushed into the stack. Okay, you never need to push the operator inside the stack. Operator, the only responsibility of the operator is to take out the element the top two element and perform the operation on those top two elements. That's it. Okay, makes sense? All right, now we divide 8 with 4 and then we push back the result into the stack. So now what will be the scenario? 40 will still be there and the result of these two division will come over here. And then we'll proceed. Division is done and last we saw subtraction. Now subtraction is an operator, right? Subtraction is an operator, so it won't get pushed into the stack. What it will do? It will take out the elements. It will take out 2 first. It will take out 40 then because 2 is on the top and it will do a subtraction. And then the result obtained will be 38. So the result of that postfix expression is 38. 8 divided by 4, Reshma. 8. Okay. This is the confusion. I got it. So guys, when you pop something, right? The first element that you pop becomes the right hand side element. I'm sorry if I wrote it this way, it would have caused confusion actually. So let me do that. The element which gets popped before, right? 4 is the first element that got popped. That becomes the right hand side element. And the element which gets popped after that, it becomes the left hand side element. Right? And hence it will be 8 divided by 4. Similarly, over here, when you took out 2, 2 became the right hand side element. Right? For the last part of subtraction. And 40 became the left hand side element. And hence the answer came out as 38. Is it clear? Okay, first the expression, the same expression I'm taking over here, and then just ignore these two lines. This is just to print the result, and I'm simply calling evaluate postfix function and passing the expression as a string. Remember, as a string I'm passing. Now in this particular function, expression is being taken care as a parameter and stack is initiated. Okay, and I created a character array using expression string. I talked about 2-char array, right? It basically converts the whole string into characters, array of characters. And if, remember what we discussed, if the character is a digit, what will this line do basically? This line is going to just iterate through the character arrays. Just assume that this particular expression now became an array of characters. Right? Now character has a function of is digit. Now if that character is a digit, we are pushing it inside the stack. The same logic which I explained over here. If it is a digit, we are pushing it inside a stack. Right? And then while pushing, what we are doing is character dot get numeric value. What it is doing is it is actually putting it as a integer. Get numeric value will basically extract the numeric value if the character is a digit. 2 could be a character, like number 2 could be a character, but when we are pushing it inside the stack, we are making sure we are pushing the numeric 2, not the character 2. Okay. Else, if it is not a character, what we are doing is we are popping out 2 elements. So first element which we pop out becomes operand 2, which confusion I think 2 of the people had, right? Reshma had and Kritika had. That which one to say that is a right hand operator or a left hand operator. So the first one that gets popped becomes the operand 2. That's what we saw over here. This became the operand 2 because it was the first one to get popped. This became the operand 2 because it was the first one to get popped out. Right? And then next one becomes operand 1. And then what am I doing over here is I'm getting the result of it. So instead of making the calculation here itself, I just created a different function altogether, which is perform operation. What am I doing over here is I'm passing C, the character. C will define whether it is a plus character, minus, multiplication, or division.
right? Because if it is not a digit, it will definitely be an operator. So I'm passing an operator along with the operands. And then depending upon what the operator is, I'm getting the result of that expression of that two operand along with the operator. And that is something getting stored in the result and getting pushed back into the stack. That's it. Okay, that's all the logic is. And this is the exact representation of what I discussed in the whiteboard right now. It's the exact representation of the same. Finally, once the result 38 comes, as per the norms, what will happen? 38 will get pushed inside the stack. The last element that we receive will get pushed inside the stack. Okay, and that's what we are popping out in the end, stack.pop karke, and we are passing the result.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.
All right, so we'll just start with queues. And without wasting much time, we'll just work on that. So queues, as what we discussed in the last session, contrary to stack, queues work on the principle of first in, first out. So the integers that enters the queue for the first time, those are the integers which comes out from the queue at the first instance as well. All right, that's the whole idea of queues. Now there are multiple methods that are inbuilt in Java that you can use while you implement queues. And that is, the first one is enqueue. Enqueue is basically when you try to insert an element inside a queue, enqueue is something that can be used. Okay. On the other hand, if you're trying to remove an element from the queue, dequeue is a function, is a method that can be used to remove the element from that particular queue. Now, if you see, enqueue takes an integer element. Considering it's a queue of integers, you can assume that it's taking an integer element, which basically means while pushing an element, you would need to have a value of the element as well, right? So that's enqueue. Whereas dequeue does not take any index or any integer, which basically explains the fact that irrespective of whatever it's not possible to remove any integer from a queue, right? You can only remove the integer which was inserted in the queue for the first time. So that's why first in, first out. Only one value which is at the top of the queue, or let's say which is at the rightmost of the queue, will be removed once you use the method of dequeue. Okay. Third method is queue create, which creates a new queue, right? When you're trying to initiate a queue, that's the function that is used. And similarly to before, we have isEmpty function as well, where isEmpty returns you an integer type and defines if a queue is empty or not. In case of the queue, if it is empty, it will return you, 1, stating that it is actually empty, or if it is not empty, it will return you 0. Okay, that's the understanding of queues. And the next is size. Size basically returns you the number of elements that is present in the queue, and it is of the integer type. So number of elements will always be as an integer. So to see the window, this is how it looks like. And I'll show you an example of queues. Let me just bring it up on my screen. We'll use the same coding IDE, guys, that we were using yesterday, and we'll try to understand the queue part. So there are two things that we will be importing in this particular question. This is the simple where I'm showcasing how do you
get the size of the queue? How do you dequeue an element? Or how do you enqueue an element? Basically, how do you insert an element in the queue? How do you check the size of the queue? How do you remove an element from the queue? And how do you peek it into the queue? Zoom in. Okay. 1 second. Okay. So very first thing that we do over here is, first of all, we are making public class main. Let me just run and check if it is running fine. I just wrote it a couple of minutes back. Yeah. All right. So what we're trying to do over here is, very first thing that we're doing is we are creating a queue. Okay. Now, the data structure that we are using to create this particular queue functionality is using linked list. That's why we have used linked list over here. And we are going to define a queue and follow the same principles that a queue has. All right. Now, to enter the element, we have a function called dot offer. Okay. So there are two functions that using which you can enqueue and dequeue elements. The enqueue part, which is mostly inserting the element, takes place using dot offer functionality. Okay, dot offer method you can call it as. And the second one is dequeue, which is deleting the element. Takes care by using the method of dot poll. Okay, dot poll is the method that removes the element from the list or from the queue. Okay, and just imagine it in a way that you do not have to specify, or you actually cannot specify that which is the element you want to remove. The reason being, there is only one element that can be removed from the queue at a particular time. Is it like element is always added at 0 index in a linked list? Element is always added at 0 index on a linked list. Yes, Vaibhav, because okay, I didn't get your point actually. Okay, let me come back to your question. I think I would need some explanation on understanding the question. So 1 second, I'll just explain the queue part. How does the queue work? So whenever you're dealing with queue, just imagine queue to be in a, lines like this, where it has multiple spaces for the elements. Okay. When you do an enqueue, when you do an offer method, you push the element on left hand side. This is left hand side. This is the right hand side. Okay. Just imagine it this way. Okay. When you do an enqueue, this is the way you push the element. All right. And when you do a dequeue, you just take out the last element which is present and you pop it out. Okay. So the functionality of inserting element at any position is not present in case of queues. Okay. Or the functionality of deleting any element in the queue is not present at all. The only thing what you can do is you can just push the element and that will be appended on the leftmost side, and you can pop the element. In this case, we do a poll. If we call it a poll, and it will come out from the right hand side. That's all you can do. Okay. And that is, I would not say a limitation of queue. That is a property of queue. Okay. That's how queues are built to be. All right. Okay. So let me just get back to the screen now. So over here, what we are doing is we are using the queue keyword from java.util.queue, and we are going to create an integer queue. We have named that queue integer as queue. Let me just, for the sake of simplicity, I'll make it only queue. And then we are using a linked list. Now, although we are using a linked list keyword over here, we are not actually creating a linked list. I mean, this might get confusing at times, that over here we are defining it as a queue,
and over here we are using it as a linked list. I mean, we are using linked list as a keyword only because we are using the dynamicity property of linked list of being able to create an element. I mean, how can I explain that? If I can explain it in a layman term, we are using, what is a linked list? Linked list are independent elements across the storage computer, right? These are linked list. These are elements of this. This can be elements of linked list, and we just use pointers to join them, right? That is linked list is, and we are using linked list over here just to help us with creating the elements, because when you keep adding elements, you would be creating the element spaces, right? So that element spaces, we are relying on linked list to create for us. Hence, we create an instance of linked list, but the property remains for the queue. Okay, and now using dot offer, we entered 10, we entered 20, we entered 30. So variable name I have changed. So that's why it's like queue dot offer. And remember this, at line number 19, we are entering 10 for the first time, right? So in case we want to pop the element, 10 will be removed for the first time, right? So that is, it's in contiguous memory. Yes, Vaibhav, the queues are in continuous memory allocation. So we are entering 10, we are entering 20, we are entering 30. And if we do a poll means the removal. The very first item will be removed will be 10 because we dropped it in the beginning. If this would have been a stack, 30 would have been removed when we do pop. I hope it makes sense. So first property we learned over here is dot offer property, right? Dot offer basically pushes the element inside a queue. Now, second is dot size property. Dot size property does nothing but it helps you to get the size of the element. Okay. And last is DQ. And that we use dot poll. And when we use dot poll, what do we get? We get the first element comes out, which was inserted in the first place. Okay. So 10 will come out from this one. And there is something called peak. Peak means you are not taking out the element. You are just seeing the element. What is the value of that particular element, which is lying on the rightmost side. Okay. And that is peak. Now see the response. Size of the queue is 3 because we insert 3 elements. We inserted 3 elements. DQ, we tried to DQ, and the first item that got DQ'd is 10. Right? And then we did a peak. When we peaked, 20 came in the rightmost side, and hence we see 20 over here. Right? And then we checked if the queue is empty or not, and it came out as false. Okay. So that is the understanding of queues. Any confusion anyone has so far? Or and also, guys, this is something, it's nowadays it's more of a I mean, you don't directly use these on the industry, especially not the inbuilt properties. You usually define your own rules, right? So if I just give you an industry relevance of this, I have written a code that can help you to define it. Let me just show that to you all. One second. So generally nowadays, what I have seen industries being following is, let me remove this code and paste this. Look at this particular code. Okay. Linked list is something that has been imported, and most of the time when you deal with an industry use case, you would not be directly using a queue, or you might not be having the same expectation of as a queue. Like your queue has an expectation that only first element can be entered over here, and then only last element can get exit from this particular point, right? But according to your use case, it might be slightly different. It could be anything. It could be as simple as at the time I want to take 2 elements out. right? Or it could be, I want where I push the elements, and depending upon the size of the element, I take one element out. I mean, there could be a lot of customized logic that you want to have if you are trying to achieve certain result in the industry, right? In those cases, you can usually define your own rules and own functions. For example, if you see over here, now over here, I have not imported java.util.queue. I have only imported a linked list, and then I have created a queue of a data type linked list itself, right? Queue is now a type of linked list. And now on top of that, I am defining the methods, right? I'm defining a method called enqueue that can add an item in the last of the linked list. I'm defining a method called dequeue that can remove from the first, right? I mean, these are something you're not required to solve this or that, but I just want to showcase you how you can define your own rules. Let's say there is one thing, there is one kind of questions where in the interviews, especially if you're trying to go for placement interviews, you might be asked that this is the question, solve it, and you might use queue to solve it. That's one type of questions, and those are mostly beginner and medium level type questions. There could be another type of question where the requirement is given to you and it says that you need to create a data structure that has these functionalities so that this particular industry use case can be achieved, right? In those cases, you can use a base class. Let's say I used a base class as linked list, base data structure as linked list. And on top of that, you can define your own methods, and that can act as an abstract methods to control the behavior of the new data structure. Okay, I hope it is making sense. Or add last and remove. Yes, that's right, Archana. Add last and remove first functions are from linked list. Yes, that's absolutely correct. Right. So there are very common scenarios. These are very common industry and placement related questions that you need to implement queue using linked list, implement stack using linked list. Right. Those are questions given because you already know the use case of stack and use case of linked list. Sorry, use case of stacks and queues. You know it is LIFO and FIFO. So how you can use linked list to implement it, you're clear to that. But at a lot of times, especially when you are at least 5 years experience already or 6 years experience already, you would see that a requirement has come up that a data structure should act like this. Now that data structure would not even act like a stack or a queue. You will have to generate the functions, write the functions, and create it. Now, just imagine, or you might be, we are using the Java classes, right? We are importing classes. It is not, but although we are calling it a library, but it is also built in the form of what we have built over here as well. The library also contains code, which contains what linked list should be functioned like, what Java should be functioned like, what is, this is the directory structure. Java directory, inside Java directory, we have util folder, and inside util folder, you have the definition of linked list. When I say definition, let's say, yeah, over here, we have used queue example. In the actual library implementation of linked list, this would have been public class linked list. And that's what we are importing over here. And hence we are able to use these add last and remove first functionalities because these are already defined in the Java library. Okay. Now, if let's suppose you are an RBI, you are the Reserve Bank of India. I'm just using a very real world example so that you can connect dots very easily. Okay. Let's suppose you are RBI and you are trying to implement a software for all the banks across India. Okay. All the banks across India could be SBI, it could be Bank of India, Yes Bank. So all the banks, I can just say all banks. Okay, or let me just do that. Let's do this. Okay, over here we have all banks. Okay, now there are certain functionalities that as an RBI, you would want all the banks to follow. And you would never want to give write for any of the bank to surpass that. For example, this might look like something like this. If I just do it in a layman term, this might look like public class RBI. And this is for everyone, guys. Please try to understand, not just for Farooq. If anyone has any confusion so far, please feel free to ask it. And you would have our method over here. And let's say the first method is public class interest rate. Now, every bank has a different interest rate, and RBI doesn't care much about it. Like if SBI wants to give 5% and ICICI want to give 3% or 10%, anything, RBI doesn't care much about it. So it won't be class public int anything. I mean, just abstractly try to understand, because they have declared it as public, because if I'm trying to inherit the functions, right? Every bank will have to inherit the function. So what I would be writing over here is public class. Let's say I'm doing for SBI inherits. This is the slightly object oriented programming. So try to understand with an open mind, guys. Inherits is a keyword which basically takes all the functions and methods which are implemented in the class from where I am calling from. So if I write SBI inherits RBI, all the things that were defined over here will be inherited on this particular class. Okay. So there are certain things I would not want. RBI would be okay to, all the banks to have their own interest rate, right? So I can again over defined over here a public interest rate or something like that, or I can directly call the interest rate over here and override that interest rate as per my norms. Okay, but there are certain things that RBI would never want to, let any of the bank get the access of. It could be anything. I'm not for I'm PRIVAT, and that's where we use private. Now, once you define a private method, let's say I'm defining a private method as what was that seva scheme, something of that was, right? Let's say total cash in the country, something of that sort. If I have defined total cash in country, I mean, just a weird example, guys. Just try to live with this example. I could not come with anything new. So total cash in the country, this method might be giving you calling this method will give you the access of the value of what is the total amount of cash, or it's with the government, or what is the repository amount in the RBI, something of that sort of information, right? Now, although there are banks which are using RBI softwares and they are inheriting the functions that are built and accustomed by RBI. RBI wants to have some private classes that is not accessible to anyone, even if someone inherits it. Even if someone inherits the class, they should not be able to access those. So private methods are the one which are protected from the people calling or using that particular class or that particular, the system. Now, in the similar way, if I'm implementing something over here, let's say I'm using private linked list. Okay. And let's say someone wants to import this. I mean, someone wants to import this queue example. If someone writes a class called public class XYZ inherits queue example, they will be able to alter all these functionalities. They will be able to use all these functionalities. Use as in they will be able to use the queue functionality, DQ functionality, peak functionality, but I do not want them to directly use a linked list itself or directly create a linked list, right? I do not want to give them the access to create a linked list. So the whole idea was to give them a different data structure altogether. So for them, queue example will be, or let's say my data structure, I should write it right over here. My data structure will be a data structure for them. If I give this to anyone, if suppose I create this as a library, I would not want them to understand how this my data structure has been built up. They should be able to call my data structure and use these functionalities, NQ, DQ, peak. They should be able to use that. Just like we do not know what is linked list meant for. We are not aware. We are just able to create a linked list by create an instance of linked list by by using the linked list method. That's all we are able to do. And we are able to call this add last and remove first methods. Nothing else we are able to do it. Similar way, if someone calls our method, we just want them to use our my data structure class name and use the methods of NQ, DQ like that. So let's suppose you are sitting in front of someone in a physical world. You are sitting in front of someone. Other person gave you a piece of paper. A physical paper is given to you. Okay, let's say it's a piece of paper. All right. Now, along with the paper, you have also been given a pen. And you have been asked to write any integer in that paper. Any integer. Any positive integer, let's say. Okay. From 0 to infinity, any integer you have been asked to write. Any integer from 0 to infinity, you have been asked to write. And let's say I wrote 1. Okay. Someone else wrote 2. Or let's say someone else wrote 77. Okay. Or someone else wrote, let's say 11 again, or maybe 10. Okay. These are the 4 different numbers. I mean, just putting 4 different numbers that I wrote. Now the question is, you need to rotate this paper by 180 degrees. Rotate, not flip. Rotate this paper by 180 degrees so that everything becomes upside down. Basically, if you rotate it by 180 degrees, I'm not sure how I can rotate it. Can I rotate it over here? I'm not sure how to do that. But let's say you rotate it by 180 degrees. Okay. You need to check for 2 conditions. After rotation, leftmost icon, this one. 1 second. Leftmost icon is not rotation, is undo and redo, not rotation. Anyways, so after you have rotated, you need to check for 2 conditions. The first condition is the number still readable? Okay, that's the first condition you need to check. And second condition, is the number same? Obviously, if the first condition is not true, there is no point of going to the second condition. But let me explain these 2 conditions. Is the number still readable? If I rotate 1 by 180 degrees, what will happen? It will still remain 1. I would still be able to see that number, right? Don't assume that I'll be writing 1 like this. Don't assume that. Just imagine 1 to be straight line. Okay. So 1 will satisfy the first condition. The number is still readable. And after rotation, 1 will remain 1 as well. So the number is still the same. So 1 will satisfy both the condition. Right? Coming to 2. Rotate 2 by 180 degrees. What will you get? You will get a gibberish number. You won't be able to understand what is it written. So number would not be readable. In case of 2, is the number still readable? No. The number won't be readable. And there is no point of saying is the number same, because the number itself is not readable. 77. Rotate it will not be readable. So number, first condition only got false. 10. Rotate it. What will it become? Tell me, guys. Once you rotate 10 by 180 degrees, write 1 like what will it become? 0, 1. Exactly. So it became 0, 1. 0, 1. Is it readable? Yes, it is readable. But is the number same? No, number is not same. So find a logic, write a logic. Obviously, you can't rotate a number by 180 degrees in the code. That is not possible, right? It's a real world scenario. But try all of you. I want all of you to think out loud and find a logic. What logic you can implement in the code which can take input as a number from 0 to infinity. Input could be number from 0 to infinity, and output could be a Boolean, true or false? Depending upon which are those numbers which are following both of these conditions. People who are following both these conditions should return true, else false. And the number could be anything, guys. I have just given 4 examples. It could be 88, 99, 567, anything. Right? I want all of you guys to think about it. Right? Because that's a very good feedback I received yesterday, and I want to acknowledge that. Just think about what logic can you build to solve this. I'll give you just for logic building, no coding. 15 minutes only for logic building. Find out a logic. Now the solution is, the very first thing that we'll do is analyze the digits that can be present in a number. So how many digits can be present in a number? 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, any number that someone writes in a paper from 0 to infinity is going to have at least one of these numbers, one or more of these numbers only, right? Nothing can be there apart from these numbers in that particular number which a person has written on the paper. Make sense? Right? Now, instead of trying to analyze anything else, what we can just see is which are those numbers which once rotated is still readable. Okay, and I told you that one, you do not assume that we are writing one like this. You can just assume one we are writing like this, simple one, right? So in that case, number 0 is the one where if you rotate, it will still be readable. Number 1 is the one where when you rotate, it will still be readable. 2 will become unreadable. 3 will become unreadable. 4 will become unreadable. 5 will become unreadable. Will come to 6 and 9. 7 will become unreadable, right? And 8 will be readable. So basically, we have numbers 0, 1, and 8 are the numbers which once rotated are still readable. Now, what we can do is, if anything is written on the paper that is containing any number apart from 0, 1, and 8, we can just discard it. Just return false from there itself. No need to check anything else. Right? Because if any of the digit in a number, let's say I'm writing a number called 000128880, right? All the number will be readable once rotated, but 2 will not be readable, right? So even if one number is present which is not among 0, 1, and 8, will just returns false from there itself. And that will satisfy our first case, which is number being readable. If the number contains 0, 1, and 8, number will always be readable. That is for sure. Anything else, just return false. For the second condition, is the number is same, you need to check for a palindrome condition. Now, we have been talking about palindrome since the first class, where what is a palindrome? Palindrome string or palindrome integer. If you reverse the string or reverse the integer, the number remains same, or the string remains same. That's a palindrome. Examples of palindrome numbers are 010 or 0011 or 11 or 00. 10 is not a palindrome. That's why when we used 10 as an example, we saw 10 changing the number, right? So it has to be palindrome. All right. With these two conditions, you can very confidently return a number or return a Boolean as true or false, depending upon the use case. Depending upon, both the conditions satisfies or not, right? First condition, 0, 1, and 8 should be present. Second, it should be a palindrome. That's it. Now comes a unique case. 69. Reverse this number. What will you get? Write a number on the pen of paper, and then reverse it. No, it won't be 96 Mansi. 69, if you write and reverse it, it will still be 69. Right? Because 6 once rotated becomes 9, and 9 once rotated becomes 6. But these two will interchange its position as well. Right? So 9 will become 6 and come in the first position. So 9 will interchange the position and it will become 6, and 6 will interchange the position and become 9. That's the corner case. I want you all to think of how to figure it out, how to adjust this, because with our logic, 69 will return false, but it should return true because the number is readable and number is same. But with our logic, it will return false. And I would just tell you a simplest approach. Okay. How do you check for a palindrome? How do we check for a palindrome? We create 2 pointers. I mean, there are multiple ways. I'll discuss all those ways. Let's say this is the number. Let me create a number which is readable and is a palindrome. 0 1 6 0 9 0 6 9 1 0. This number will return. Let me do this for easy. This number will return true. This number should return true because it is going to be readable and the number will not change as well. Everybody agrees? Yeah. So what we are trying to do over here is, first condition mein, what we will add along with 0, 1 and 8 will add 9 or 6 as well. That in case of these 5 numbers, go to the second position, go to the second condition. First condition will be satisfied with these 5 numbers in the actual integer. If anything is present apart from these 5 integers, we'll discard it right away. Right? So that's the first change that we need to do. Second change we need to do is in the way we check for palindrome. How do we check for palindrome? We verify the last number if it is equal to the first number. Right? So we equate 0 with 0, 1 with 1, but while equating 6 with 9, we'll be equating 9 with 6 and 9 and 6 with 9. You got my point? So there will be alteration in the logic of the palindrome. The alteration would be while equating and while checking for palindrome, you equate 0 with 0, 1 with 1, 8 with 8, but 6 with 9 or 9 with 6. And you can incorporate Nandini's logic as well, which is very convenient. What you do is you take the reverse of this number and convert 6 with 9 and 9 with 6. Take a reverse of this number and convert 6 with 9 and 9 with 6 and then equate with this number. Right? So in case of palindrome, what do? You reverse the number and then equate it. In this case, you reverse the number, change the number with 6 to 9 and 9 to 6 and then equate it. Any confusion anyone has got so far? This is the actual, and to be honest, guys, this is the same question which I was asked in my Microsoft interviews 5 years back. Right? Exact same question. This was asked to me when I interviewed for Microsoft. Okay. So I hope there are no confusion. If it is, if there is any confusion, please let me know. Awesome. Great. Do you guys want to write a logic for this, code this so that it becomes very, 6 is always pairing with 9? Yes, Mansi, 6 will always pair with 9 because of a reason, right? You write 6 in a piece of paper and then you rotate that piece of paper. What will you see? You will see a 9. And then you write 9 on a piece of paper and then you rotate it. What will you see? You'll see 6. So we are not pairing. It's just that by design, it's happening and hence we are accommodating that change, right? Okay. Array. What else? Rest of the guys started coding. Yeah. I mean, arrays linked list. Okay. So where did we use arrays? We didn't use array, right? We didn't use, I mean, this could be array. Yeah. We can either convert it into an array. Let's suppose we have got a string input. We convert it into an array and then we did it like this, or we could directly use string as well, right? Anything is possible. Stack. Someone is saying stack. The correct answer, if you ask me which data structure was it from, is that it did not use any particular data structure at all. It did not had any particular data structure involvement in this question. Even if you are not aware about arrays, even if you're not aware about list or stacks, you can still solve this question with basic programming skills. And the reason I'm talking about this is such type of questions you will expect in the placements where the question will be independent of data structure or algorithm. It will be purely on your logic building capability and how well you can solve a problem or a question. Okay, so hope it makes sense. So that's the way you should try to approach a question without thinking that which data structure this is belonging to. Just think from an independent mind and solve the best possible approach. Okay.
So actually, this needs to be done in a way where it is integer dot to string and then pass on to a. Let me try this if this works. Yes, that is what it works. So actually dot to string is either in Python or someone. So I got confused actually. In Java, you need to call the data type of a. Basically what you are trying to pass, you'll have to call that. And then since we are trying to convert from integer to string, hence you have to do integer dot to strings. During interview, which type of question ask? I mean theory part or coding part? Okay, very good question. So in the interview, Mukesh, it's going to be a mixture of both theory and coding. If you guys are aware, there is something called as pseudocode. Okay, pseudocode is something where you do not write the complete code, and also you do not write or just talk about it. You need to write something, but you do not have to care much about the syntax. That is the essence of interviews. Mostly you have to write the pseudocode of the questions. For example, the question I discussed around this one, where we discussed multiple approaches of finding a palindrome or doing this logic and all that, right? The interviewer would not ask you to write the whole code. They will ask you to write the pseudocode of it. Okay, so if you're not aware of what a pseudocode, you should just watch a simple YouTube video that can help you to understand that, right? But pure theory questions can also come from the topics like computer network, the OOPS concepts. OOP concepts are very, very essential. Okay, there could be database management system, something of that sort. A bit of theoretical questions can come from there, that part, but mostly the coding part will be only pseudocode, and coding part will comprise of 50 to 60% of your placement questions. Rest 10% might be from theoretical concepts of DBMS, computer networks, OOPS, right? And the rest 30% is going to be more about the projects that you have mentioned in the resume. So make sure whatever you have mentioned in the resume as your project, you have a great command over there, so that if questions are asked, you are on top of it. Which is the best way to apply for a job? Kritika, the best way, if I believe, if you are asking from a fresher perspective, that you are a fresher and you are applying, trying to apply for a job, not from a lateral hire perspective or a person who is trying to switch from one company to other. From the fresher perspective, the best way is to apply for the best and the easiest way is in-campus placement. The company came to your college and then you applied for it and then you got it selected, right? But if you are from tier 3 college or tier 2 college, where the company of your choice and your caliber is not coming in the campus, the best way to apply is through referrals. Get active on LinkedIn, get connected with people from the company you want to join, and seek referrals. Talk about your projects, connect with the hiring managers, connect with the engineering managers, connect with the university recruitment teams of that company, and try your way out, right? That is from the fresher perspective.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.
Okay, so the first sorting algorithm will be the bubble sort, followed by selection sort, and third will be insertion sort. Okay, these are going to be the three sorting algorithms that we will be learning today. Now, the best part is how we are going to approach this is I'll be talking about in this whiteboard how exactly the sorting works. That is going to be the first point of discussion. And the second point of discussion will be the pseudocode of the explanation which I'll give you. Now, once I have given you the pseudocode, you need to write the complete code for that sorting algorithm on Java. And of course, we will discuss that solution once you are done, but it will be your responsibility to write the complete code by yourself.
once we have discussed the complete logic and the pseudocode. Okay. All right. So with that, we'll start with the first thing that we want to do today, which is bubble sort. Okay. People who are already aware of all these sorting algorithms and already aware about their applications and how to write the sorting logic. This session might be a revision for them, because apart from these, we are not going to cover anything. We are only going to talk about sorting algorithms, writing their pseudocode, writing their complete code, discussing their applications, and solving few of the use cases. All right. So let's do one thing. Let's take a array, and let's suppose array has number like 7, 2, or let me do this. 7, 2, 2, 12, and let's say 8, and let's say 3. Okay. Suppose this is the array. Just imagine this as an array where this is our condition, where the numbers are mentioned in this order. Okay. Now we want to sort these elements. Now there could be multiple ways of sorting. Okay. One sorting algorithm is totally different than the other sorting algorithm. We are going to discuss how exactly bubble sorting algorithm sorts the array. Okay. So bubble sort, why is it called bubble sort? First thing, because every time we compare two elements and we keep comparing two elements one after the other, and the way we approach this problem is, the intent is in each of the iteration, in each of the complete iteration, once we move, our first aim used to get the maximum number, get the number which is of maximum value to the last in the array. It might have not been taken up very well. Okay, let me explain it with the help of an approach. So our number is this, right? 7, 2, 12, 8, 3. Now, very first time what happens, once we start, what we start to look at, we start comparing the numbers from the beginning. We compare the first index with the second index. And what does a sorting algorithm does? If the previous index is greater than the next index, you swap them, because sorting means putting the smaller numbers before and larger numbers in the end. Sorting is always in the ascending order unless until specified, right? So here 7 is greater than 2. So this will get swapped. Now after it is swapped, the new condition would be 2, 7, 12, 8, 3. Right? Now 7 will be again compared with 12. Will the swap happen? No, because 7 is anyway lesser than 12. Okay, so we'll move ahead. We'll compare 12 and 8. Will the swap happen? Absolutely yes, because 12 is greater than 8. And hence, after the swap, our new logic will become 7, 2, 8, 12, 3. Now, what will happen? Last thing will be tested, 12 and 3. Swap will happen? Absolutely yes, because 12 is greater than 3. Okay, so this will be 2, 7, 8, 3, 12. Makes sense? Because it got swapped. Now look at this. So one iteration we completed, right? We started from the beginning, we went till end. So one iteration is completed. Now see the case. Were we able to push the largest number to the end? Yes. We were able to push the largest number to the end. And hence, now what we will do? We will just assume that our array size is this. And we will rerun the code, rerun the approach. To show you how does it work, we'll do 2, 7, 8, 3, 12. All right. Now, 12 is already at the right position. We start checking from first again. 2, 7. Do we need to make any change? No, because 2 is anyway lesser than 7. 7 and 8. Do we need to make any change? No, because 7 is lesser than the 8. 8 and 3. Do we need to make any change? Yes. So this time we swap only this. And anyway, we don't want to go ahead because we are assuming our array to be only this much. So we just swap it and we are done with the second iteration. So by the second iteration, what did we achieve? We achieved something like this. Now see, both largest number and second largest number went to their ideal place. Now we assume our array is only of first 3 size. And what do we do now? We try to follow the same approach. 7, 3, 8, 12. Okay. Is 2 less than 7? Yes. So we know we don't need to change. Is 7 less than 3? No. So we need to swap this. And once you swap it, what will happen? Our new array will become something like this. Okay. And now we will take up the last piece, which is this. And once we do that, we will see 2 is anyway lesser than 3. So it does not need to be changed. Hence, this same array will be returned as an answer for bubble sort. And look at the scenario. Were we able to sort it? Yes, we were able to sort it. And hence it is called bubble sort. So just to repeat, the very first thing and the first logic that we do is we use comparison between the two adjacent elements, and on every iteration we try to push the maximum element to the last. The max element goes to the end of the array, and then once that is done, we take care of the rest of the size of the arrays from index 0 to size -2. Right? That's what we did over here, and then again we did over here, and then again we did over here. Now let's write a pseudocode for this one. Let's see how a pseudocode might look like for this particular scenario. Okay, I already have a pseudocode written to save our time, and the pseudocode looks something like this. Procedure, this is not the actual code, guys. Don't get confused. Pseudocode is something that is language independent. It just talks about the logic. Okay, so procedure, you can just assume function, you can assume anything, and then it's bubble sort, and it's taking an array input. Now what we are doing is first we are calculating the length of the array. That what is the length of the array? Once we have calculated the length of the array, what we are doing? We are running I. Just assume that you created a for loop. You created a for loop from I equals to 0 to I equals to n-1. Okay. Just assume you did it from 0 to n-1, and we created a swapped variable, a Boolean variable as false. We initiated it already. Okay, and the second loop we are running from 0 to n-i-1. What criteria will this take care of? This will take care of the criteria where in the first iteration,
In the first iteration, when I was equals to 0, right? What did we do? When I was equals to 0, I is running from 0 to n minus 1. So I will be at this position, then I will be at this position, then I will be at this position. I will keep going forward, right? And then j, what will happen? Will go from 0 to n minus I minus 1. So j will also start from over here, but it will not go till the end. It will go till n minus I minus 1. N minus I minus 1. Now what is happening over here? When I was 0, j was going till the end because it was n minus 1. N is again the size of the array, and minus 1 will make sure the last index, right? So j is going from start to the end. But in the next iteration, when I becomes 1, j will become n minus 2. Hence, j will not go till the end. J will only go till this point, right? Only till second last element of the array. And again, once I gets incremented, again, it will go till third last element and so on. The algorithm, if we try to read the pseudocode, what it says that once we have calculated the length of the array, okay, once it is clear that what is the length of the array we have, in this case, it is 5. So the length of the array, let's say over here, we already have a length of the, what is happening, as 5. Okay, so I will run from 0 to 5, right? I will run from 0 to, I mean, by the terms of index, if we say 0 to 4. So once I will be here at 7, and finally the value of I will keep on incrementing. Okay, the value of I will keep on incrementing. Basically, I determines the number of iterations we need. We won't need I to fetch the index. I determines the number of iterations. How many iterations did we require over here? We needed, first iteration was this, when we pushed 12 to the end, right? First iteration was this. Second iteration when we pushed 8 to the end, right? Third iteration was when we pushed 3 to this place. And the fourth iteration was when we compared this one. So basically 4 iterations were required to achieve the result. And hence I takes care of the number of iterations. Okay. In case of j takes care of till what level the swap has to happen, right? So see over here, for j from 0 to n minus I minus 1, for the first time, we compare everything till the end, because value of j is, this is j, n minus I minus 1, right? When n equals to 4, n equals to 5, I equals to 0, and minus 1, it will become 4. So basically, we need to go till index number 4, which is 3. But next time, this will become 3. So we need to go to index number only 3. I hope I'm making sense. It basically is controlling till what is the array. We need to go to the number of times, right? So that is what we are doing. And then inside it, we are doing the actual swapping. Okay. Over here, what we are doing is, if array of j is greater than array of j plus 1, means the previous element, the first element is greater than the next element, we swap. And then we called swapped equals to true. Now, why we are using this swap variable, it will become more clear when you know when you write the exact logic. For now, just assume that once we swap, we create the swapped variable as true. And if not swapped, we break it and then we return the array. It basically says if the no swapping was required, it basically says that the array is already sorted, and hence it breaks and then it returns the array. I would like you guys to write a Java program for this. Okay, I'll keep the screen open so that what is the use of n equals to length array?
This is the place where we are getting the length of the array. Now, Suraj, using the length of the array only, we are able to do all these calculations, that how many iterations has to be performed, and what should be the value of j, how should j change. N is the main body over here. Okay, cool. So let's go ahead with the explanation of the solution. So the very first thing is this part I don't think I need to talk about, because this is the main part where you are where we have just taken a random array which has numbers from 5 to 8, 12, 1, 6. And then we are printing it out, that array before sorting. And then we are bubble sorting the array. And then we are printing out array after sorting. All right. So this is the case. What is the logic is, it's exactly the way we designed our pseudocode is. The very first thing that we're doing over here is we are getting the length of the array. Okay. After that, we are creating the for loop from I equals to 0 till the last integer, the last index of the array, which is basically taking care of the iterations. All right. And then we are using this Boolean called swapped, which is taking care of making sure if we have swapped any of the element in that iteration or not. And then we have initiated j equals to 0 from j equals to n minus I minus 1, from j0 to n minus I minus 1. Basically, j will every time start from the first index, I mean 0th index, but the end index will keep decrementing by 1, right? And then we check it if array j is greater than array j plus 1. We do this swapping, and then we mark the swapped equals to true. And if it has not been swapped, we break it. Okay, so it is a very interesting array, and how does it work is something I'm going to discuss with you. Where did that go? Oh man. Yeah. Okay, so let's suppose we have an array called 7, 4, 4, 6, 5. Okay, let's say we have the array and we need to sort this element. We have to sort this array using insertion sort. Okay, now what is the basic fundamental thing that insertion sort, I'm sorry, it's a tongue twister, so I might fumble a bit. So the basic functionality that insertion sort takes into account, and the basic assumptions that they take is they divide the array into two halves. Okay, into two halves, and they call it one half as sorted array and the other half as unsorted array. Okay, and you know, any array which has one element, any array which has only one element is always sorted, right? So that's the reason you see one element on this side which is sorted. Okay, now what it does is one by one it starts pulling the element from unsorted side to the sorted side. Okay, that's the logic insertion sort has built up. Now how does it function is, try to visualize this particular scenario. Okay, I would try to draw it as good as possible, but please excuse me if it doesn't go well. One second, guys, one second, I'm getting a call. Yeah, so let's suppose this is an array. Oh man, I think last session somebody suggested me a tablet or something. I should buy that. Okay, just adjust it, guys. Okay, so let's suppose this is the array we have, and we have 7 over here, we have 4 over here, we have 6 over here, we have 5 over here. Okay, now 7, we are assuming this part to be sorted, right? We are assuming this part to be sorted array, And we are trying to move in one by one part of unsorted array into the sorted array. So what the next step usually becomes is, the next step what it becomes, it removes the element that needs to be shifted and marks that space as empty and creates a new variable called key and stores the key over there. So 4 came out and placed over here. Now what does it happens is there are space got created. Okay. And it assumes the space gets moved to the sorted part. This is the space. This is the empty space. It got moved to a sorted part. Now the sorted array contains 7 and a space, 6 and 5 as unsorted. Now, before placing the key into the blank, what does it do is, it makes sure that all the elements which are greater than the key moves to the right side of the space. And then space gets replaced by the key. So what will happen? All the elements which are greater than the key moves to the right side. So it will look something like this now. Because 7 is greater than the key being 4 and 6, 5. Now 4 can come over here because we have made sure that all the elements greater than the key have moved towards the right. Now this part is sorted. This part is unsorted. And the same thing is repeated for 6 followed by 5. Do I need to repeat it for 6 and 5 as well, or it has made clear and we can move to pseudocode? Anyone who has not understood the concept, don't think how will we achieve this in the code, but just mention if you are clear on the. I was distracted. Why were you distracted, Farooq? And where were you distracted? Once again, please. Okay. So insertion short works on a basic fundamental principle of dividing the array into sorted and unsorted. Okay. And the very first thing that they do is they create and they pull the first element as the sorted element, because array which has only one element is always sorted, right? An array which has only one element will always be sorted. So the first element gets dropped under the sorted part. Rest of the elements comes under the unsorted part, right? And each iteration, one of the element is taken out from unsorted array and moved into the sorted array. And how does it happen? Is through the below mentioned ways. The very first thing that happens is the number is taken out from the array so that a blank gets created in the array. And the number over here that was taken out was 4. And we create a variable called key. We assign that 4 into that key, and the blank space is created in the array. Now what we do is we move that blank space towards the sorted part, just like this. We just move it. We don't have to worry about the position of it. We just move it towards the rightmost side. And now before assigning the key back to the empty space, we try to make sure all the elements which are greater than the key moves towards the right of the blank space. All the elements which are greater than the key moves towards the right side of the blank space. What is number is greater than what happens to key, sir? I think, Navya, you mean what if number is greater than what happens to key? Which number is greater? You mean the key itself is greater, or 7 is greater? 7 is anyway greater than the key, right? Navya, just explain by putting, yes, sir, key is greater. Okay, if the key is greater, key can directly come into the space. If let's say in case of 4, it is 40, then 40 will directly come into the space. We don't have to shift it, because the whole point is we need to shift the numbers which are greater than the key towards the right. If that's not the case, we don't have to shift it. We can directly place the key. So over here, we had to shift it. And then in the empty space, we place the key, which is 4. And the same thing will follow with 6 and 5 as well. Okay, so we'll move to the pseudocode, and it's very simple. It's a pretty looking pseudocode, not as big as the previous one we had. So let me remove all these and let me place pseudocode over here. Okay, look at this small sized pseudocode. Insertion short, taking an array, getting the length of the array. Clear? Perfect. Now look at this. Very first thing what you're doing is interesting. We are running I from 1 to n minus 1, not from 0 to n minus 1. The reason being, we assume the first one is already sorted. So we need to start for first index till the last index. Okay. This is something we are doing, and look at this. We are taking key. We are picking up key and assigning it. I mean, we are taking element one by one, starting from this place, and we are assigning it to the key. Okay, makes sense? And then we are creating a variable called j, which is I minus 1. So let's say we are talking about 4 over here. What is the I value of 4? I value is 1 because that's index, right? So j will become 0. In this case, the value of j for case of 4 will become 0. Okay. Now, while j is greater than equal to 0 and array of j is greater than key. So now it basically what it is doing is it is iterating all the elements which is before the key. Try to understand that. So we are basically trying to figure out the right position for the number 4. Right? So what we are doing is we are using while loop while j is greater than 0, greater than or equal to 0, and array of j is greater than key. Basically, if there is a number towards the sorted side which is greater than the key, we are putting that number into j plus 1. And in place of that, we are putting the key. So basically, this is the shift that is happening over here. It's a constant shift that is happening over here. You see, in the array, we have already taken out the key from over here. Okay. Let me try to just make it sound slightly more simpler. Once we know we are going to shift 4, 4 has already been stored in the key. Okay, so there is no chance of losing the number. Over here, if you see, key is already been stored at some other place. Okay, and then j is initiated. J is initiated to check and iterate through all the numbers which are before the key. So let's suppose that before the key, this number is gone from over here. There is no number over here now because we have stored it in the key. It's a blank space now, for example. Okay, what j is doing, j is trying to see all the elements which are greater than the key and it's trying to shift them towards the one greater index. That's what it is happening over here. While j is greater than or equal to 0 and array I is greater than key, array j plus 1 takes the value of array j. So that's a shift that's happening. And then we are decrementing j by j minus 1. And finally, in the empty space, we are putting the key. Okay. Any confusion? I mean, this might look slightly more complex if till the time you have not implemented it by yourself. So people who have got the fair understanding of this, please start implementing this as part of the code. And for the people who have any confusion in terms of pseudocode, please let me know. Okay, so guys, start writing a Java program for this one. So this is the empty space over here now. And key is containing the value of 6. Okay, so once 6 is removed, there's an empty space. What we can do is that line that you saw, line number 23, is taking care of shifting all those numbers which are greater than the key towards their right. So 7 will be shifted towards its right. If there would have been a number over here greater than 6, it would have also been shifted one place towards right, so that the space can be created over here and 6 can be placed over here. That's what we are trying to achieve through pseudocode over here. While j is greater than 0 and array j is greater than key, we are trying to shift the numbers which are greater than the key. And finally, we are placing that key in that particular position. All right. I don't think I need to explain the main part. So I'll directly come in the function part. And it's the exact same implementation what I have talked about in the pseudocode. Okay. What we are doing over here is we are calculating the length of the array. That's the first approach. Second thing is how many elements we need to shift is what this line states. In case of 4 elements, how many elements do we need to shift? Right? It will be 3 elements because 7 is something we have already assumed that it's under the sorted array. So we'll be shifting 3 elements into the unsorted array, into the sorted array, and figure out the rest of the logic accordingly. Hence, the index starts with 1, not 0. Please keep that in mind. And it goes to all the way till n and i++. Okay. Very first thing that we do is we make key equals to array of I. So over here, array of 1 will be equal to the first iteration key, and that will be equal to 4 according to our problem, right? And then int j equals to I minus 1. First iteration mein I ka value it's 1. So value of j will be 0, right? And hence this while condition will start. While j is greater than or equal to 0 and array of j is greater than key. First condition is true. J is greater than or equal to 0. This is true because j is equal to 0. And array of j is greater than key. Array of j is array of 0, 7. It is greater than the key, right? Hence, what does it do? It takes the next position. Array of j plus 1 equals to array of j. So 7 will take this position. And j equals to j minus 1. We are putting j backwards. Right? Once you do j equals to j minus 1, the value of j will become how much? J was anyway 0. The value of j will become minus 1. So basically it says you checked all the elements from this side. Since there was only one element, you had to check only one. And then finally, no problem. And then finally, array of j plus 1 will be equal to key. Array of j plus 1 will be, j was already minus 1. So array of j plus 1 will be j equals to 1. It was minus 1 and plus 1. It will become 0. So the key will be stored in the 0th index. And hence 4 will be stored at this position. You would have to have very strong concentration, guys, to understand this. I hope it's making a little bit of the sense. In case it is not, I would request all of you guys to go through this pseudocode. Let me ping this pseudocode first and also the complete code. Okay. So just a quick implementational question. Let me give you for this one. because anyway, in the direct examination, you won't be asked a straightforward question. So let's have the similar way that we did for the previous one. So over here, what are we doing? Over here, we are not swapping, right? Over here, we are making comparisons. Correct? Comparison between shifting. Yeah. Over here, we are doing shifting. But that application question will be a very straightforward question. So I think we can skip that. Let me see if there is an implementational question that I can bring up. Okay, so let's guys, all of you who have written the solution of insertion short, try to give array as floating point numbers. Convert the integer array into floating point numbers and just check if it is working for you all. If it doesn't, what do you think needs to be changed? 9 and 6. Okay, now suppose this is the array that we have. What does selection sort does is it iterates through the array completely one by one, and once it is at a number, let's say it starts from 15, it looks for the minimum element in the next all of the array, which in this case is 6, and then it swaps 6 with the number. 6 gets swapped with this number. That's all it does. Start from a integer, look for the smallest integer in the rest of the array and swap it. So the next array that it will become like this: 6, 28, 17, 12, 18, 9, and 15. Make sense? And now the pointer will be at 28. Once it is at 28, it will look for the minimum number, which is 9, and it will swap 9 with 28. So the new will be 6, 9, 17, 12, 18. Do we have min to find minimum? You can use that, Weber, but not directly. I mean, you'll have to min takes only 2 integers, 2 inputs. 6, 9, 17, 12, 18. What will come over here? 28 and then 15. You are free to use Weber. If you find min being used for arrays, you can very easily use it. Means one swapping with last, not last. Coincidentally, it happened last. It was a coincidence, Dipshika, that 6 and 9 were at the last. It's not going to be always last. Let's see the next case. Let's see 17. What is the minimum number here now? It's not last, right? It's 12. So swapping will be done with 12. You got it? So now the numbers will be 6, 9, 12, 17, 18, 28, 15. And now the number will be at this position, 4th position. Minimum number will get 15. 15 will move here. 17 will move here. It will come to 18 and so on. Okay. So it's going to be very simple. Again, using the same example. Let me just try to run this so to make sure it is actually correct. All right, this part, as always, I do not need to explain. We'll go directly to this part. Okay. Again, as always, we are picking the length of the array in the line number 5. And from here, we are just navigating from index 0 to index n minus 1, because just like this, we came at 15, then 28, then 17. So one by one, we are increasing the index and we are iterating through the array only once. Okay. Now let's see how we are doing the rest of the aspect over here. We are assuming that this is minimum. We are assuming that this index is the minimum index. I mean, we are assuming that number at this index on which our pointer is at the first is minimum. Hence, we are putting min index equals to I. So in the first iteration, min index will be equals to 0. And then what are we doing over here is we are navigating from ji plus 1 to n. Basically, to all these numbers, we are iterating as part of another for loop. And we are checking if array of j is less than array of min index. Basically, any of the element, if it is less than 15, what we are doing is we are changing the value of minimum index. So that over here, once iterated, what will be the value of min index, guys? Tell me. Once iterated, what will be the value of min index? We got the length of the array, right? We created a for loop. 0, 1, 2, 3, 4. It would be 6, Dipshika, not 5, because minimum index we are trying to find, right? It will be 6. I mean, not the value, but index will also be 6. I hope everyone is getting. What are we trying to do over here is nothing much. We are just putting our pointer at 15. We assume that this is the minimum index number. We assume that the index at this, the number at this index is the minimum. We assumed at this particular statement, and then we created a for loop to actually figure out which is the minimum number. And we took the index of that particular number as min index. So now we have the index number in which the minimum number is there. And now what we do is we just swap. We swap array I and array mid index. Array I is what? Array I is 15. This was I. And mid index is what? The one we found. This is the only logic we have for selection sort. The smallest and the easiest logic.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.
Okay, so that was about, this is about bubble sort. The order of n square is the average and the worst case complexity. I hope you guys are aware about average time complexity and worst case time complexity. If you are not, this basically means on an average, irrespective of whichever array you give to the bubble sort algorithm, it will take order of n square time to execute it or to sort it. Okay, how to get the complexity? It's a complete different method, Mukesh, which is not in the scope for today's session, but just to give you a high level highlight, this is basically the order. The order basically represents how the time taken by the algorithm is related with the input size. Okay, so what is time complexity? This was not actually the agenda, but time complexity is how the time taken for an algorithm to get the output is related to the input size. Okay, this is time complexity. Now, what are we saying over here is irrespective of whatever the algorithm is. Let's say I'm trying to add two numbers. Okay, what kind of algo I'll write? I'll write something like add a b, right? And then I'll open the braces. I'll do this, and then I'll do return a plus b. Now, if I tell you to tell me the time complexity of this one, how will it work? It will simply work that only one comparison, only one operation is required, which is addition, right? So this is order of one because nothing is dependent on the input size. The function itself has determined that only two inputs will be there, and then we are returning a plus b. So we are totally confirmed that at maximum, this function add function will only have one comparison over here. So this is order of one, right? But in case, let's say we have a function called add, and then over here we are passing an array. Okay. And then over here we are checking int n equals to, it's not the actual code, guys, just assume it as a pseudocode dot size. Okay. And then we are running a for loop for I to n minus 1 sum equals to sum plus what will it be? ARR 1, right? And in the end, we will return sum. Return sum, and over here define int sum equals to 0. Okay. Now understand this. What is the time complexity of this? What do you think? Order of n. Yeah, absolutely. Now, people who are not aware, order of how time complexity, basically time taken. Okay. And the time, usually time complexity is time taken for an algorithm to get the output is related to the input size. How the input size is related with the time taken. So look at here, this statement will be executed only once because we are checking the length of the array only once. This statement of initialization, the sum equals to 0, will be executed only once because we are checking the sum only once. But look at the for loop, right? How many times this statement will get executed? Except Webber, I want someone to answer this. How many times this statement will get executed? Okay, n minus 1, yes. Or it could be n as well. Huh? N minus 1 or n. I mean, I'm not going into specifics, but yeah, it will be related to, it will be either n minus 1 or n. Actually, this should be from 0 to n minus 1. I did a typo. So it will be executed n times. Let's assume n times. Okay, if it is going from 0 to n minus 1. Because if the array is of n size, and I'm trying to get the sum of it, I'll have to add all the n elements into the sum. So in order to add all the n elements into the sum, I have to actually go through all the elements. So this is being executed n times. So how many operations did this take? N operations happened, and hence the order becomes order of n. Because now our time complexity is basically time taken for a system to execute. Let's say this array has only 2 elements, right? If array has only 2 elements, or second case, array has 2 million elements. Obviously, we can't just tell the complexity of the algorithm without taking into the account of the size of the array. In case of the above example, we just said it's order of 1, right? Because it's a constant time, irrespective of anything, it will be order of 1. But in this case, when the size of the array is not determined, we need to take into account the size of the array, because what if the size in the first case is 2 and in second case it's 2 million? right? And hence we say that it's order of n, which basically means the complexity of this particular algorithm will be dependent on the size of the array. Okay, now let me give you a third and a quick example. Okay, how to copy this code, man? Can I copy this code? No. Okay, I'll write it quickly. Let's say we are adding array, and this time array is a 2D array. Above one, it was a 1D array. Let's say this is a 2D array. Int n equals to arr dot size, and then int m equals to arr 0 dot size. I hope you are getting what am I doing, because we have already covered the matrices and 2D arrays. Okay, now what I'm doing is for 0 till n minus 1, start a for loop. Okay, and again over here for 0 equals m minus 1, start the second for loop. Okay, and we initialize some over here equals to 0. Okay, and over here we do sum equals to sum plus arr I j. And then return sum. Now you need to tell me how many times. People who have already answered, I don't want them to answer. So Tammy, Mukesh, Navya, Sanchita, Surya Pratap, Archana, Rohit, Vaibhav, do not answer. Okay. For the people who have not answered, I want them to answer. How many times will this statement get executed? Array is a 2D array. ARR is a 2D array. And int n basically represents the number of rows. Int m represents the number of columns. If you can understand this, right? We have already covered, so I'm not getting into specifics. But I mean, just looking by the for loop as well, you can answer the question. I hope you're understanding, because this is something was not planned in the session, but I felt time complexity is something you guys have not been covered. I'm not sure if the professor taught this part. He was supposed to, but that's okay if that was not covered. Okay, NNM. Yeah, so the people who are not able to get it, this will be executed n multiplied by m times. Why? Because the first for loop is going from 0 to n minus 1. Basically, this is getting executed n times, and this for loop is executing m times. And this is a nested for loop. The for loop is inside the other for loop. So basically, the total number of equations and logic will be order of n multiplied by m. Okay, and hence we can consider n and m are a input size. That's why for ease of understanding, what do is we say this is order of n square, right? Because there are two variables involved in multiplication order. We say order of n square is involved. Yeah. Okay, cool then. So I think this is clear. Any confusion, anyone on this? Okay, so we covered the int string part, and the last thing I want to discuss. I hope you guys are aware about binary search. How many of you are aware about binary search? What is binary search algorithm? It's a very simple algorithm. I'll just tell you right away over here. It's a searching algorithm, not a sorting algorithm. It's a searching algorithm that is executed on the sorted arrays. Let's suppose we have an array called 4, 7, 9, 12, 23, 46, 78, like this. Okay. What does binary search do is, hey, what happened to this? Oh man. Okay, 1 second, guys. Let's say we have simple array. Let's say this is a sorted array from numbers from 1 to 9, right? What does binary search do? Binary search basically looks for an element. Any searching algorithm, if you do, it basically returns an element in the form of an integer if it is present. Let's say I am doing binary search and I'm looking for an integer. Let's say I'm looking for A. So whatever we are looking for, whatever we are searching for, we pass it as a parameter. And then binary search is executed over here. Okay. Now this A could be either present in the array or it can be not be present in the array. If it is present in the array, this binary search represents and returns the index of the number. Let's say A equals to 4. For example, A equals to 4. Then this binary search will return 0, 1, 2, 3. Will return 3 because 4 is at index 3. Okay. Or let's say value of A is 92. In that case, this will return -1 because it says it's not present in the array. Make sense? Binary search, if I talk about the algorithm, works on a very simple algorithm. In order to search a number, what does it do? Let's say the number is 4. Okay, same number will take. It will look at the midpoint of the array. First, it will look for 5. Basically, a midpoint of the array, which is 5. It will look for this number. Okay, if that number, or let's say it's 4 is the key which we are searching for. 4 is the key which we are searching for, right? And if the key is not present in the midpoint number, it looks for whether the key is less than the key is less than the middle number or key is more than the middle number. If it is less than the middle number, what does it do? It discards the rest of the array. For example, 4 is less than 5. So basically it says key after 5, this number won't be present because the number is sorted. So it discards this part of the array and only starts searching on this part. Okay. Now in this case, it again looks for the middle number. Now middle number could be 2 or 3, but if you do 4 divided by 2, you will get a number of 2. Yes, binary search only works on sorted list, right? So in this case, the size of the array is 4. You divide the size with the half, and it comes out to be 2. So basically, it will come to 3, right? Index 3. 3 is also not a number. The key is not equals to 3, and 3 is lesser than the key. So it will this time it will discard the left side, and it will look and it will consider only the right side array. And right side array, the middle point will be again 4, and the midpoint becomes equal to the key. So it will return the index of this element, or it will return true that yes, the number is present. Okay, so this is the binary search. Now, the reason I discussed about binary search is because I want you to tell me the time complexity of the binary search algorithm. I'll also show you the pseudocode of binary search. Let me do that. So that it becomes more clear to you. N divided by 2. N divided by 2 is not okay. So this is the thing. N plus n. 1 second. If the time complexity you feel is n plus n. For example, there are 2 for loops, but they are not inside each other. We still consider as n. Okay. If it is n plus 2, we still consider it as n. If it is n divided by 2, we still consider it as n. If it is n multiplied by 2, we still consider it as n, because the constants doesn't make much difference, okay, in terms of the graph. So if you plot the graph of n and you plot the graph of n divided by 2, the trajectory will be almost same. The shape of the graph will be same. It's just that the value will be half. It's divide and conquer, hence it is log of n. Now how does it become log of n? It's not actually n divided by 2. We are not doing it in a way where we discarded one part and we checked all the elements in the next part. We are not doing that. We are discarding arrays at every part. So even once we have discarded this, we are going to discard half of this as well. And then again, we are going to discard half of this as well. So at every time, your number of elements is changing. Every time n becomes n by 2, and then it becomes n by 4, and it becomes n by 5, right? So I'm not going into the practical depth, but Eventually, it will become log of n. All right. So this was good that we discussed. People got it? I mean, any confusion on this, guys? Just assume this one because I'm not going into graphical approach and all that. Once you do in a divide and conquer method where you are dividing the arrays multiple times and you are just discarding the rest, you don't have to go over all the elements, right? Once you are dividing every time by 2, it becomes log of n with a base 2. Okay. All right. So this makes sense. Let me do one thing. The next thing that we are going to discuss is going to be about one of the algorithm called merge sort. Okay, interesting algorithm, which also works on the phenomena and works on the principle of divide and conquer. So let me take an array. Let's say this is the array of 5, 4, 1, 3, 2. Okay. Now what does divide and conquer does, or in fact merge sort, which uses divide and conquer, what does it do? It divides the element. It divides the whole arrays into 2 parts till the time the individual part is already sorted. For example, you can either divide 5, 4, 1 or 3, 2. Okay. 1 second, guys. Yeah. So it divides the whole array into 2 halves. Now dividing into 2 halves, it could be 5 and 4 into 1 half, 1, 3, 2 in the second half. Let's assume we are dividing it in the half where 5 and 4 is in the 1 half and 1, 3, 2 is in the other half. Okay. Now it keeps dividing the array till the time the array becomes sorted. Okay. Now let's use this colored code. Let's say we are calling it as left 1. Okay, let's call that as left 1. And then we'll call this part as right 1. Okay. Now, what does the algorithm do? Algorithm takes the left part first, I mean, whatever part first, and it divides it again. So for example, now we have 5 and 4. Now what will it do? It will divide this array again and would name it left 2 and right 2. We are just naming it for our own convenience. This is not actually required. I'm just talking about the logic. How does it happen? So the division keeps on happening on both the sides continuously till the time it is sorted. Now, once we see the left 2 and R2 are only have one elements. Each one has one element. So both of them are already sorted. Hence, what we do, merge sort, what we do, we create a function called merge in which we merge 2 sorted arrays. ARR1, ARR2. This is the part of the algorithm itself where algorithm has one function that takes 2 sorted arrays and it merges the sorted arrays. Okay. So what we will call merge function passing L2 and passing R2. And what we will end up with? We will end up with an array where 4 and 5 are merged. So basically, we will have the array something like this. 4 and 5. And this will be our L1 now. So L1 is sorted. This was our L1 previously. And the new L1 became this with a sorted number. Okay. Now, if I talk about the R1, R1 takes place, go through the sorting again. And how does it happen? It happens in a way where we divide 1, 3, 2 again. Okay. And how do we divide 1, 3, 2? We divide in a way where, let's say, it divided like this. and we call this as, we can call it as left 3, L3, and R3. All right, we do that. Now L3 is already sorted. L3 is already sorted and ready because it has only one element. So we need to focus more on R3 now. Now to focus on R3, what we are going to do is we are going to divide 3 and 2 again. And we will call, let me just draw it to avoid confusion. 3 and 2 will divide it again. And what if in EEP1, what if we keep 1, 3 in one array and 2 in another array? We can do that, Vaibhav. We could have done that in the first step as well. 5, 4, 1 in one, and 3 and 2 in another one. We can also do it 1 and 3 in one, and that won't make any difference. You will understand in a while. Okay, so we will call it a L4, and we will call this a R4. Now both L4 and R4 are sorted because they have only one number each. So we will call merge function using L4 and R4, right? And once that is done, we will land up in an array called 2, 3, which will be our R3, right? R3 became 2 and 3. And it is sorted now. 2 and 3 are sorted now because it has already gone through the merge one. L3 was also sorted for us because it had only one elements. So we will pass L3 and R3 this time in the merge function. And what will we get? We will get a array 1, 2, 3, which is the sorted R1. Yes, it was previously an R1, right? So we will get R1 over here. So now we have R1 and L1 both sorted, and hence we will forward L1 and R1 into the array. And we will have the final algorithm sorted, which will be 1, 2, 3, 4, 5. So I'll just take up Vaibhav's point of, let me just undo things. And we go back in the step where we were dividing 1 and that. Okay, so let's go back here, and this time let's divide this. Okay, so our L1, our L3 will become this, and this will become our R3, right? So this time R3 is already sorted. So we don't have to spend anything on this part. We just have to spend time on L3. Now L3, once we sort, we'll divide 1 and 3 separately, and then 1 and 3 will be sorted individually. So using the merge sort, we will be coming up with the same array of 1 and 3, right? Because it's already sorted actually. L3 is already sorted, right? So even if you do divide this array into 1 separate and 3 separate, and you go to the merge sort passing 1 and 3, you will come up with the same array of 1 and 3. Now we need to merge L3 and R3. So we will put L3 into array 1 and R3 into array 2, right? And this logic will take care of sorting the two sorted arrays. So we will end up with 1, 2, and 3. Okay, so here is the pseudo code. Now look at this. What we are doing is we are defining two functions over here. The first function is merge sort. Second function is merge. Okay. Merge sort is taking care of the logic, whatever we have discussed. Merge is only taking care of merging two sorted arrays. That's it. Left and right, it's taking array 1, array 2, empty array called result, I and j being initialized to 0. And then same thing what we had discussed, right? If you can remember what we did, we used a while loop to keep comparing the numbers. If left I is less than right I, we append that, else we append the right I. And then once the size is different, we make sure that the other, the longer array, whichever is longer, whether it is left longer or right longer, it is appending rest of the elements into it. You guys remember, right? I mean, I'm pretty sure this was properly discussed. I also remember Vaibhav asking a question on this to use a use case. I remember that. Uh, I can skip that, right? So if you want me to still talk about merge function, let me know. But since we have discussed, I'm skipping it. I'm only talking about merge sort. So in merge sort, the very first thing that we are doing is if length of the array is less than or equal to 1, if the array itself is empty or array has only one element, what will you sort in that? You can't sort anything. So what we do, we just return the array. And this condition becomes our base condition. All the divide and conquer methods work on recursion. All the merge sort and divide and conquer type of algorithms works on recursion because you are calling same function again. What are we doing over here? Every time we are dividing it. We divided the array over here. We divided the array over here. And we did the same thing. We divided array over here. We did the same thing, right? So it's happening again and again. Hence recursion is used. So you would see merge sort being called again. And that's where every recursion function has a base condition. And this becomes our base condition. Base condition basically means at what point this will end. If we keep dividing things like this, at what point it will end? So it will end at a point where the array size becomes 1 or less than 1. Right? That is the point it will end. And that's called the base condition, which we have defined over here. If length of array is less than equal to 1, return the array. That's what we are doing over here. Once the array size is 1, which is 5 and 4, what we are doing is we are not calling anything. We're just returning 5. That, okay, 5 is sorted. We are returning 4 because 4 is sorted now. It has only one element, right? Coming to the other condition, if that is not the case, if the array is not less than 1, the size is not less than equal to 1, what we are doing is we are calculating the mid of the array, right? That's what you see over here. We're calculating the mid of the array. And then we are taking the left, creating the array left by using a slicing approach. We are slicing the array into 0 to mid and then mid to end. You're understanding this? Mid is the index over here. End is the another index. End is basically the last index, the size of the index. This is the pseudo code. That's why you do not see end being initialized. I hope I'm making totally sense. If I'm making not, just let me know. Okay. So left is the new array, which is the array from first index, first element to the mid element. This is the array 1 or left 1. And this is the right one. Right one is after mid till the end. So this is the right one. The second element is not included in the list. So basically mid will not be included in the left. Mid will be included in the end one. Because once you use the slicing method, only the first element is inclusive, second is not inclusive. So mid will be included in the right array. Now what we are doing, we are just calling merge sort again using left and right. What we are doing, we are again doing the same approach. We are doing the same thing with this array separately and this array separately. And we are calling merge sort again. Right? And once we have the result of left and right, we are returning a merged left and right. Basically, once we have sorted this and we have sorted this, what we're doing is we are merging these two using this merge sort algorithm, and then we are returning. And that's what is happening over here. Let's suppose you have, let's suppose the array had 2 elements. Okay. Let's suppose over here, array had 2 elements, 2 and 4, or let's say 4 and 2. Okay. This might clear your confusion. So it is this base condition will not be true. Mid will be, it will be created half. So left will be 4, the array. Left array, it will have a single digit 4 and right array will have a single digit 2, right? And then you call merge sort and right sort. What will it return? It will return the array itself because it's single digit, right? So left will still be 4 and right will still be 2. Okay, but now what you're doing over here, you're returning by calling this function. And what does this function is doing? It is merging left and right. This function is merging 2 sorted arrays, and we have these 2 as sorted arrays. So result that we'll be getting from this function is a array like this. Now, does it make sense? So for example, same thing I have explained over here, right? That's a similar explanation. But anyways, let me try to do that. 4, 2, 1, 3. So it's not less than 1. Multiple calls will happen. So first time, left will be 4, 2, right will be 1, 3. In this case, this is recursive 1. Okay? So just assume before comma, whatever is doing is the first recursion call. What will left become? Now, before you assign value to left, merge sort will be called on 4 and 2. Right? So the function will not go ahead. Function will call merge sort again with 4 and 2. Right? And then now second recursive call, just imagine it as a stack. Second recursive call, left will become 4 and right will become 2. Are you understanding it, Vaibhav? It's a second recursive call. Huh? It will become 4 and 2. Left will become 4 and right will become 2. Okay. And then again, left and right will be called. Right now, nothing has been called. Again, left and right will be called. So merge sort will be called again on 4 and merge sort will be called again on 2. See, since these are single digit numbers, only 4 and 2 will be returned again. And then final thing that will be returned out of the second recursive call will be 2 and 4. So finally, on the first recursive call, what you would see coming over here, something like this, 2, 4. So at a time, merge sort will have on only 2 arrays. Yes. Merge sort will always have only 2 arrays. Yes, absolutely. And then similarly on right, 1 and 3 will be passed inside merge sort, and the same different recursive call will happen separately. And the result will be obtained over here will be 1, 3. And now these two arrays, sorted arrays, will be passed on this merge, and the result will be 1, 2, 3, 4. So recursive call, you can imagine multiple things happens and it comes as a stack. For example, you have called merge sort on a number called 1, 2, 3, 4, right? Before this executed, before this undergoes the final execution, lot of time merge sort will be called. So before this is executed, you can imagine merge sort 1, 2 being called, and also merge sort 3, 4 being called. Okay. And even before this gives the result, you would again see 2 merge sort being called. This is the pure definition of recursion. 1 being called and merge sort 2 being called. Okay. One of the best examples of recursion. Similarly on this one, before it gives the result. So what happens? These two collectively gives the result for this one. And for this one as well, merge sort 3 and 4, we will have merge sort 3 being called, and then merge sort 4 being called. Okay. And these two collectively will get results for this. And now these two will finally give collectively the result for this. So what are we doing over here is I'll also run and make sure that it is printing out the correct output. This is the array that we have taken at line number 57. Okay. So this is the main class that we have created, which is doing nothing but initializing an array and calling the merge sort. And then next lines, we're just printing it out. That sorted array is, and we're just printing out the whole array. But the main work is being done by the merge sort. All right. I hope the screen is visible. Okay, it's not small. So let me just expand it a bit. Now, just the way we discussed about the approach, merge sort, it's the first function that we are doing, and then we are doing the merge, right? So very first thing, let's discuss about the merge first, because it's a simple thing. We'll just discuss and close it. what are we doing over here is we have 3 arrays, left, right, and ARR. Okay. And I is the index for the left array, J is the index of the right array, and K is the index of the merged array. So what we are doing over here is we are returning we are just creating ARR as the resultant array, which is the merged array of left and right. Okay, and these are the 3 indexes. Now the first while loop is taking care of checking the elements one by one from left and right and appending it on the array ARR depending upon the which is greater or which is lower. So in case left is lower, we are appending left one. In case right is lower, we are appending the right one and doing I++ and J++. And then we're also doing K++ so that the next time on the next adjacent place on the ARR, the element will be appended. Okay. I hope this is there. There is no confusion on this part. Coming to the next part, we are doing copying the remaining elements from left subarray, if any. So in case the left subarray is bigger, we are just copying and appending it in the ARR. Similarly for the right array. All right. I hope till now it's a very simple approach. There shouldn't be any problem in that. Okay. Now coming to the main part, which is the heart of the algorithm, which is merge sorter. Now remember the base condition we talked about. If array is null or array.length is less than equal to 1, return. Okay, return as in we don't have to return. We are trying to alter the array itself. So array, if it is already has 0 elements or only 1 element, we are just returning it. We are not doing any kind of operation. So this is the base case. The array is sorted or empty. Now, the exact same question was asked by Weber when we discussed about arrays. So just imagine left is this. Left is 1, 2, 4, 5, 7, 9. Okay. And right is this. Hypothetically, assume right is 7, 9. Okay. Now what will happen? You are incrementing I and incrementing J. Okay. There will be a time when the value of J, or let's assume it is 0 and 1. There will be a time when value of J will exceed, because 0, 1 is the first element, right? Value of J will become 2. Once you have cleared everything on right, value of J will exceed it. Correct? So in that case, this statement will start getting false because J will no longer be lesser than the length of the array. And till this time, when we have reached only 0, 1, the value of I will be only 1 or 0. It could be either it will be 0, right? So these elements might not have been inserted in the ARR. So to take, and this while loop will break because J has exceeded the length of the right element. So this whole is an AND condition. So whole while loop will break. So how will you make sure that the merge takes into account of these elements of the left side? That will happen by this piece of code, because I is still less than the length of the left array. So remaining elements from the left array will be copied to the ARR. So guys, I think we are clear. This base condition will be base condition is something which we have discussed. And then look at this. We are calculating the mid of the array, mid index of the array, and then it is ARR.length divided by 2. Right? And then we are creating a new element, a new array called left, in which we are assigning the array from 0 to mid. Okay. And then we are assigning a new right array from array.length minus mid. Okay. So this is just the creation part. Okay, we are just creating the size of the array because we are initializing the array. So don't get confused why only mid we have used. Mid is basically defining that what should be the length of that array. And over here, we are populating it. If you have used a different approach, if you have used a for loop, that's perfectly fine. It's just that these functions were handy, so I used it. System.array copy, it's basically copying all the elements from 0 to mid to left array and from mid to end of the array to the second array, which is right. Okay. And then we are recursively calling the merge sort and then finally merging it. I mean, this is the exact same code copied as per the pseudo code. And I have already explained all these recursively, how does it function and all that. All right, guys. So the next topic that we are going to discuss is going to be about quicksort, a very interesting sorting algorithm and the last sorting algorithm that we have in the syllabus. Okay, so feel happy. I think yesterday we discussed 3. Today we are discussing 2. So make sure that you know about each one of them by heart. How do they work and how do they function? So that in the company interviews, you might be directly asked questions which you should be able to answer. Okay. So I guess you guys are making notes as well. Please do that, because sorting algorithms, you can very easily get confused, right? Because names, by names, at least I found it very difficult to remember by names. I know the algorithms, but which algorithm is called what is something I faced confusion during my time, and you can also face the same. All right, so we are discussing about quicksort, and let me just mention it over here, quicksort. And the way it works is, suppose you have been given this array, you choose a pivot. That pivot could be any number which is present in the array. And using that pivot, you find an appropriate position of that pivot and then repeat the same thing for the numbers before pivot and after pivot. Okay, lot of confusion, lot of text I told, right? So let me do one thing. For a simplicity of understanding, since we can select any pivot from this array, let's choose pivot to be 4. 4 is our pivot. Now what we will do is, we will move 4 to a position where it actually belongs. And how will we move it? We'll move it to such a position where all the numbers which are lesser than 4 comes on the left side, and all the numbers which are greater than 4 comes on the right side, without changing the order. So over here, what will it come? It will come 3. No, sorry, 1, 3, 2, and then 4, because this is the right position. After that, all the numbers will be greater. And over here, it will be 7, 5, 6. We did nothing. All we did was, numbers which are greater than 4, we move it to one side. Numbers which are less than 4, we moved it to the left side. Okay, and here is our pivot. So now we know that we need to sort this side and we need to sort this side, and we will be good. Okay, so same process. And quicksort is also based on divide and conquer, guys. Quicksort is also based on divide and conquer, and you will see how. We took a pivot, we find the appropriate position of the pivot, and we got 2 arrays. Now we are going to do the same with 2 arrays. We are going to apply same quicksort algorithm in both of these 2 arrays, nothing more, nothing less. So now if I do same with this particular array, what will I get? I will get 1, 3, 2, and then I'll apply pivot on 2. Okay, once I apply pivot on 2, I will move 2 to a position where numbers which are lesser than 2 are towards the right side and greater than 2 are on the left side, right? So this is our pivot. And then I'll apply quicksort on left side and right side again. But now, since both left and right side are single numbers, they will just return me the same array. So basically, we'll be sorted with this particular array. Same thing will apply for this part, where we will put 6 as a pivot. Once we put 6 as a pivot, what we will get? 5, 6, and 7. Because we are moving all the numbers which are lesser than 6 towards the left side and greater than 6 towards the right side. And now we will apply quicksort on the left side and the right side arrays again. But since these are the single numbers, we will be sorted. So this array is already sorted. And now we'll just, no need to merge because it has already been taken care, right? There is no need to merge because 4 is in between and we sorted one side. So it is 1, 2, 3, 4, 5, 6, 7. We got the quicksort algorithm implemented straight away. Okay, so this is the pseudocode for the quick sort. Okay, look at what is happening. There is a main code is over here where I have array low and high. Okay, low and high basically represents the first index and the last index. If low is less than high, I mean, if the first index is lesser than high, pivot index we are finding, okay, using partition. Okay, what is partition? We have under partition, we are having array low index, high index. Pivot, we are just assuming to the array high. Array high means last index, we're just assuming it as pivot. Okay, we are initiating we are initiating index as low -1. You will understand the reason how. And then we are initiating a for loop. For loop that goes from j to for j from low to high -1. So basically we are iterating throughout the array, right? Just assume that this code, it's doing nothing, but it's just iterating throughout the array to make sure the low numbers of the pivot is coming to the left side and high numbers as per the pivot is coming to the right side. Okay. So if array is less than equal to pivot, I plus plus plus, I plus 1, and then swap it. Swap it with I and j, right? And then swapping ke liye we have a different function. And then once you have done that, what you do over here is you call the quick sort again with low being at the same place, but this time index of pivot comes pivot index -1. Pivot index. So basically, whatever was the index of the pivot, index of 4. Next time the array will be only from low to pivot index, which was 4 -1, which is over here. And the next one will be pivot index +1 from pivot index +1 to high. Right? I hope it is making sense because there are a lot of variables involved over here. What I would request you guys, try it out by yourself by coding it. Okay. Swapping, you don't have to worry. It's just the normal swap. That's the way you swap numbers in the integer. Okay. Partition is basically you are partitioning the array. Partitioning as in what did we do over here? We partitioned the array. This place. Could not understand the algo. Please repeat. Okay. Okay. We'll go one by one. Very first thing is swapping. Nothing to be explained. What are we doing over here is swap is taking the array I index, j index, and it's swapping the I index value with j index value and j index value with I index value. Okay. No explanation required for swapping. All right. Let's coming to partition. Partition. What does partition is doing? The approach that we did in the second step of picking a pivot and then making sure that the first part is containing lesser number of, the numbers which are lesser than the pivot, and the second part is containing numbers which are higher than the pivot is called partitioning. This method is called partitioning. Oh man, what did I do? This method is called partitioning. Okay. And that's what we are doing over here. We are partitioning the array. Pivot, we assign the pivot, which is the highest number. We assigned a pivot, which is ARR high, which is the last index of the array. I equals to low -1 is the, so basically when you, okay, I'll have to explain it with the help of a solution. Just give me a second. Let me just go to the desk. I'll use a use case that can help you to visualize why are we using I equals to low -1. It's basically initiating the index from the lower part, but let me just give me a second. Okay, so let's assume this pivot is partitioning mein array is equals to this array that we used. What was the array we used? 7135264. Okay, 7135264. Okay, And pivot is something we took it as 4 because array high is the last index. Okay. And array low over here, low and high is basically the indexes where low index is 0 and high index is the last index that we have, and hence we got the pivot. So basically I over here, we are putting it as -1 because low was anyway 0 and I is low minus this is -1. Okay, just assume, and we'll come after this for loop, we will figure out why exactly we did this. Okay, why not 0? Yeah, we will come to that. Okay, now we have initiated J that is running from low to high -1. Okay, that is running from low to high -1. Now low right now, this basically means J is running from low is 0 and high -1 is what? Till the index 6. So this is 0. 4th was the high index. So 1, 2, 3, 4, 5. 0 to 5 it is running. 5 is the second last index. 6 was the index where 4 was present. Okay, this makes sense, I hope. And now what we are doing is, if array J, so it's checking if 7, 1, 3, 5, 2, 6 is less than or equal to pivot. Is less than or equal to pivot. What are we doing? We are first incrementing I to I plus 1. And then we are swapping I and J. So let's suppose we landed up on number 7. First iteration, J will be equal to 0. Let's say first iteration J equals to 0 and the pivot is equals to 4 and ARRJ equals to 7. Okay, this condition holds true or not? ARR is less than or equal to pivot. No, hence this will not get executed. Let me just take a situation where it gets, where it actually gets true. Let me do one thing where I just make it for 3. Let's make it 3 and then put 7 over here just for the sake of simplicity. Okay, so now this will be 3 and this condition will hold true. Okay, so first we are doing I plus 1 and then we are swapping. The reason being, if we would have initiated as 0, we would have to first swap this and then do I plus plus. I mean, just imagine the situation. We have to, we are swapping 4. We are swapping the ith index and the jth index. Okay, so in case swapping, in case I would have been initiated to 0, if we were initiated this as 0, we would have had to not do this, right? Not do this, and instead we could have swapped directly. And for the next time, we could have done that, right? But we don't want to do it every time. What's the matter if we swap first? If we swap first, we will have to do I plus 1 after that. Is that right? But we want to do this I plus 1 only if we are sure that swap is going to happen. Making sense, not making sense. We want to do I equals to I plus 1 only if couldn't get it. Okay, Weber, would you like to just write the code, because I'll be able to explain this much better in the code. Would you like to, all of you, not just Weber, obviously, would you like to just have the code? Maybe during writing the code, you might have, you might figure out why exactly we are using as -1 and not 0. You can use this pseudo code. Start with the actual Java implementation, because I believe rest of the things is something it's making sense, Weber. Is it right? So maybe you can start with the code part, and then in next 15 minutes, we'll discuss the exact code with the help of a use case that will make sure it becomes more clear to you why exactly it has been used as -1. Let's suppose this time we are calling on the example of, let's say, this is the array example, ARR equals to this 7216853. Okay, number of elements we have over here is 7. All right. So basically our low becomes 0, high becomes 6. Make sense? Low is 0 and high is 6. Okay, 1, 2, 3, 4, 5, 6. So last index will be 6. Okay. Now the first thing that we will be calling will with the exact same parameters of partition, array, and low and high. Okay. So over here as well, same parameters we will receive, which is array, low, high, and 6. Okay. Now let's see what is going to be our pivot. So pivot is going to be array of I. So pivot is going to be 3. And for the people, let's just make sure everybody is paying attention, because this is going to be a tough time to repeat, right? And I over here is going to be -1. Let's assume over here that y is or just assume I is equals to 0 over here. Okay, we will see the use case. What is the problem we are facing in this? Let's suppose we have initiated I as 0. That's the better way to do it. Okay. Now what will happen? J will run from 0 to 5. Make sense? J will run from 0 to 5, right? From 7 to all the way to 5. It will run from that, and it will keep checking for all the numbers. Okay. Now, once it comes over here, where it has to check the number, once first, if it checks array of J is less than or equal to pivot, which is not true, right? So it will just skip this. It will go to second element, which is 2. Okay. And it will check if array of J, second element, is less than or equal to pivot, which is in the second case, it is true. Right? So rest of the steps will follow. And what will it follow? First, will be doing I equals to I plus 1, which is not required right now because we have also initiated I equals to 0. So let's comment this out as well. What we will do, we'll swap ith and the jth element. What was the ith element? Ith element is I of 0, right? This was I of 0. I of 0 is 7. Make sense? And the jth element, A of J, right now is what? Okay, what is the value of I and J over here, guys? J is running from 0 to 5. J became 1. So definitely J is 1 right now over here, right? But what about I? What is the value of I over here? I is 0. So we are going to swap I and J over here. Okay, 7 and 2. So the new, just let me mention that the value of array was previously this. Value of I is 0. And J is equal to low to high. So J, second iteration, it will be 1. Okay. Now we swapped I and J. So swapping of I and J basically means you replace the values which are present in ith element and the jth element. So this swap will happen in a way where 2 will come over here and 7 will come over here. Okay. Pivot being at the same place. All right. Next time, what will happen? Next time, let me remove all these. I plus 1 next time. Okay. Next time, what will happen? The call will come to this element 1. Okay. It will come to 1. Now what will happen? The value of J now is going to be J in the third iteration. It's going to be J equals to 2. Right? Because in the previous iteration, J was 1. Okay. This time it will be 2. And hence 1 is going to be ARRJ, and it will be compared to pivot. And this statement will be true because 1 is actually lesser than the pivot. Okay. Now what will happen? Look at this. Swapping will happen between I and J, but I is still 0, but we don't want to swap 2 with 1, right? We want the I to get incremented, right? We want the I to get incremented. Hence, we will have to first increment the I, then make the change. We need to increment the I because I have commented this line for now. Because if we are not starting from -1, there was no point of putting it from I plus 1. Basically, you need to increment the I first to make the change. Okay, right? And hence we need to do the I increment. Since we want to do the I increment every time we swap, because we want to move the pointer ahead, that's the reason we start from one lesser number. Knowingly, we start from one lesser number to make sure if anything, just so that this -1 takes care for the first iteration. For the first time, it starts from 0. That's why we start from -1, because every time we have to increment it. So that the rest of the steps gets easily executed, we need to do -1 start and then use I plus 1 to make sure do it. Yeah. Sorting algorithms, I know it takes a bit of a pain to understand the digits and all that. Then next line of calling quicksort. This line of calling quicksort. Okay, this is fairly simple. So what we are doing over here is, remember the whiteboard. What we did, we selected a number pivot. That's what we did over here in the first line. First line, pivot index partition. So you can assume these two operations was done by the first line of partition. This line, pivot index equals to partition. This partition function is taking care of the first two lines, selecting a pivot and then partitioning the number. 4 will come in a place where one half is the lower and the second half is the higher. But the next two lines is actually taking care of these two. What to move ahead with? The other two arrays. Applying same thing on the other two arrays is being taken care by quicksort being called again on array with index of low and pivot index -1 and the array of pivot index +1 to high.
Just a quick info guys, Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.
So let's start with arrays. And our question is, given an integer array nums, move all the zeros to the end of it while maintaining the relative order of non-zero elements. So guys, this is a very interesting question. So let us see how to solve this question. So suppose we have an input array called nums and we have this number something as 0, 1, 0, 3 and 12 are the elements. So how the output we are expecting is something like this. So 1, 3 and 12 are coming at the front and all the zeros are shifted at the right end. So let us consider an array such as, suppose we have an array, say array name is nums, okay, and we have this much number of elements 0, 1, 3, 0, 12. Okay, so what kind of output we are expecting here is that all the zeros like this one and this one should be shifted at the right end. So our answer will become something like this. So this is our required output. One other case you can think of something like this. If nums is this kind of an array, so we have elements all over here, such as you can say all the zeros are at the left end only, and we have the elements such as 1, 2 and 3. So our output would become something like this: 1, 2 and 3, 0 and 0. So guys, you would have got a clarity that what is expected in this question. So you have to move the zeros at the end of it while maintaining the relative order of the elements. Okay, you can pause the video right now and think of an approach that how you are going to approach this problem and solve the existing problem. Okay, so this can be your first approach. You can think something like this. So suppose we have this array nums and I put the elements such as 0, 1, 3, 0, and 12. Okay. So what can we do all over here? That we can create a vector. Okay, guys. So we can create a vector, okay, name as duplicate. And what we're gonna do it that we're gonna insert the elements 1, 3, and 12 by iterating, over it, over the entire array, and leaving the zeros behind. What you can do, we can create a vector and put all the elements in this vector called duplicate, which are non-zero elements. Okay, so this is the first approach. So here the number of elements is n. Okay, and suppose in our duplicate we get m elements. Okay, so what we will do, so suppose in our vector duplicate we got this element as 1, 3, and 12. Okay, so if we find out the relative difference between these two, so if we go for finding relative difference between the vector duplicate and this array called nums, so we are going to get what are the difference of elements is missed by duplicate, and we can insert all those elements. So suppose if I say 1, 3, and 12, so suppose we have nums has number of elements nums has is around 1, 2, 3, 4, 5. Okay, and our vector duplicate has around 3 elements. Okay, so what is the difference here? So nums minus duplicate equals to 5 minus 3 equals to 2. So means we are missed by 2 zeros. So we can insert, 2 zeros in this duplicate vector. So this becomes our answer. So guys, I hope so you could have found out this approach. It's a pretty simpler one, but the problem is in the question asked, the question stated that you have to move the elements at the end of it. Okay, so we are performing our operations using some other array or a vector, which is kind of not required. It is actually not expected. The interviewer could say you, please try a different approach. I don't want you to take any duplicate array. I want you, all the operations or your approach should just involve using one array. So how we can solve this problem by just using one array? You can pause the video, guys, and then think of a very good approach or any approach which solves the problem. I'm going to take certain approaches and tell you that how we are approaching. The only thing to be understood right now here is, guys, how we are trying to solve this problem. What is our approach? We will see at the end of it, when we have found out a solution, that how is the right way to approach a given problem. So there is a note for you guys. In the above approach, why I am discarding that, So actually what we did was we took an extra space actually, which was like order of n. So which is kind of not an optimized approach. So whenever you are sitting up for an interview, when your interviewer is going to ask you certain questions, so when he says that this approach is not optimized, so you have to find out a solution how you can optimize your algorithm or the way of your approach to solve the problem. So that was that in the above scenario, our approach or our was not optimized. So let me give you another approach in which we will be trying to solve the problem. So guys, what our approach can be something like this. Consider this as our first, the red marker which is all over here is a first 0th element, and this orange one is our first non-zero element. Okay, just remember these markers. So what I'm going to do something like this. I'm going to construct our array and I'm going to swap these first 0 and first non-zero elements. Okay, so our array would become something like this. This is after first operation 0, 0, 3, 12. Now we are going to place our pointers. So our first 0 right now comes here and our first non-zero element is around here. Okay, so after swapping, because remember we have to swap first non-zero. Remember we have to swap first 0th and second non-zeroth element. Pretty much fine. Okay, so after this operation our array would become something like this. Okay, 1, 3, 0, So we have to find out our first zeroth element. The first zeroth element is all over here. Okay. And there is one more zero, which I missed it out. Okay. I'm going to add it up. Okay. So our first zero element is all over here. And after first non-zero element is all around here. So what we're going to do, we're going to swap them. Okay. So our array would become something like this. 1, 3, 12, 0, 0. We have found a solution, but in this we are taking 2 pointers. And guys, I would say this is pretty complex approach. You would be also feeling how we are going to create 2 pointers and this swapping operation. The approach is correct. There is no doubt about it. You could go with this approach and code it up if you are able to. But I would suggest that the coding can be a little bit, complex for beginners. So this approach could be avoided. But if you want to go with this approach, this is also pretty much fine. Okay. So I would suggest that, let's try to find out some other easier way to solve this problem. You can pause a video and you could think about some other approach. So guys, I hope so. You would have thought about something. So here's another approach which is pretty efficient and pretty interesting. Okay, it's a very amazing approach which I would always recommend to use it in these types of questions. So suppose we have an array and I would say I'm saying iterating from I equals to 0 to I equals to n. Okay. So here we have an array called nums and I am putting 2 counters, that is I and j. Okay. I would say that I is somewhere around the first non-zeroth element. Okay. This is I and j I would initialize as the first element. Okay. So we are traveling from I equals to 1 to n basically. Okay. So here is our array called nums and this is the element 0, 1, 0, 3, 12. Okay. We are initializing all over here. I equals to 1. Okay. And j equals to 0. Okay. The first non-zeroth element basically where it is present. Okay. Now what we are going to try to do all over here is that whenever, okay. So whenever we are finding the first non-zeroth element, so we are going to replace the value of the ith index to the jth index and we are going to increment the j. Something like this, guys. So at the first step would be something like this. So here is our first non-zeroth element and here is our, the counter of j. Okay. So we found our first non-zeroth element. So I'm going to replace it by 1. 1, 0, 3, 12. Okay. This was our step number 2. Then again, we increment the counter. So our counter I becomes here and j becomes here. Okay. Since it's encountered a 0th element, so we are going to do nothing and we are going to just increment the I at this stage. Okay. Increment the I. So at the second step, our array would be still the same. 1, 0, 3, 12. Okay. Our ij is still at this position, but our I will be at this position. Okay. Now, since we have encountered a non-zeroth element, so we're going to replace it all over here. 1, 3, 0, 3, 12. And our j position would be shifted to all over here. And I would be at the end of the array. Okay. So basically I has traveled from at this distance to the end of the array. Okay. So what we are going to do is still we are finding the non-zeroth element. So I'm going to replace this with this element. Okay. And increment the j. So our array would become something like this. 1, 3, 12, 3, 12. Since I has completed its iteration, okay, I will be here and j would be incremented. Okay. So we can find out right now that, we have almost traversed or we have moved the elements all around from 1, 3, 12 and j is at this position. Okay. So when we have traveled, when I has traversed the entire array, so what's the value of j's are left means j at index, what the index of j is left. Okay. So here it is like 1, 2, 0, 1, 2, 3, 4. Okay. So j equals to 3 all over here to j equals to 4. We're going to fill these elements a of j and a of j plus 1, okay, with zeros. Basically, since there are 2 elements only left, so I'm just giving you an example that a of j plus 1 or the leftover elements like this and this, since we have to, traverse till here. So we're going to fill these elements with 0. So our array would become something like this, So our answer would go something like this. At our final stage, it will be 1, 3, 12, and 0, 0. This is a pretty optimized approach, and I hope so, like some of you would have thought about it, okay? If you have prior solved this question, it's very good. It's kind of revision for you. But this is actually one of our approach which actually I wanted to discuss. So we went on to 3 approaches, okay? See, we are not arriving at our solution. So whenever we are facing any new question, we are not expected to instantly, write the most optimized code. Your approach should involve hit and trial method, okay? This is the one thing which you have to learn it. So basically you learn by hit and trial, okay? So first you're going to do wrong, or you approach some easier way, then you will think, okay, how to optimize this, or how to add the element, then how to add some flavor to your approaches. And then at the end of the day, after too much of trials, you get to solve the question. So now it's time for us to write the code and see how we are writing the code for the same. So guys, here is a code, and you could try to hit on your systems. So it will be something like this. So we have found our code, and we are going to try to write the code in a language you could choose like C++, Java, but I'm choosing actually C++. So it is my personal recommendation that for solving data structures, you could go for Java or C++. So this code is written in C++. Okay, so what the first thing we have to do? So we have to move the zeros at the end of it. So let's just create a function, okay? So our function is void move zeros. And in this, I'm going to pass 2 parameters, okay? The first one is a vector and second one is the array. Okay. So I'll say vector int and nums. So I'm going to basically initialize the size of the array. Okay, so how we can do it? So there's a very good way. You could just declare a variable and put it nums.size. Okay, so that's a one good approach. So there's int n equals to nums.size. Then I initialize j. Okay, so int j equals to 0. Now let's traverse the array. Okay, so I'll start with the for loop. For int I equals to 0, int I less than n, and I'm incrementing it with I++. Okay, so if nums of I is not equals to 0, so I'm telling it a condition that here, that if the element we have encountered like in the earlier is not equal to 0, it's a non-zeroth element basically. So what I'm going to do right now, I am going to replace it with the element at the index j position. So nums of j equals to nums of I. Basically, I'm assigning the position. So, and then later on, I'm incrementing the, you can say the position of jth, okay, or incrementing the jth. That would be right to say. Then I'm closing the loops, okay. Next thing, what we are doing all over here is, then what we are saying that when for till then, suppose j has reached till, say there was 3 and 12 left in the element, and 1, 3, there was also 12. So j was at here. So we're going to start from the jth position where jth has entered till then. So for here again for loop, because I want to change the values, to zeros. So for j, so just this you could do, and j less than n, okay, and I would say j plus plus, and I'm going to say all the position which are left out after I has traversed entire array. So I'm going to put it to 0. The nums of j equals to 0. Hence it solves our problem. Okay, and this is the complete optimized code. Okay, so let's look at the code once again. So for our better understanding, so let us find out the first thing what we did all over here is that first we tried approach. Okay, we got an approach in our mind, and we also figured it out. It is a kind of an optimized approach. Okay, so what we did was that first, in order to solve that approach, we are going to first create our function, which is gonna solve our problem. So here, what I say is our function is the first thing we created, okay? Coding is nothing, guys. The language is just a kind of a language to interpret about your thoughts, what you want to do, okay? We created an array, we pass out the parameters, okay? It's very important for you to pass an array, okay? And this is the size of the array. Here we are calculating. And I've initialized already that here j will be here, here I will be here. So I've initialized j equals to 0 because j should be starting at the first index, which is at the 0th position. Then I am traversing entire array, okay? So for traversing, what we are doing here, guys, we are applying the for loop. Now here is a conditionals, okay? Because we had a condition in our approach that if we come across the non-zeroth element, basically, which is written all over here, what we're gonna do, we're gonna assign the value of the jth index, nums of j, equals to nums of I, okay? And we are incrementing it with j plus plus, okay? Got it? And then what we are doing is basically the leftover j's, just put all these values to 0. Pretty simple code, guys. It is not a complex code, but that approach earlier, which I told you about putting 2 pointers and going again and again, so that could have been a little bit complex, but see, this approach is pretty much consistent. So guys, I would have thought like this is a pretty easy approach, and you would have understood how we approached a problem. So we are not learning here how to solve arrays question. So that should not be our agenda. Our agenda for today's session should be like how we are approaching a problem to solve it. Because believe me, when you're going to sit for the FANG companies or any good MNC, they're going to ask you questions and which will be pretty new to you. So, and you cannot learn all those questions, you cannot solve a lot of questions, and it just does not works out. You cannot learn a code. So my only advice to you should be, guys, that first start with pen and paper, try to solve it, and come out up with some approach. Try to find out what flaws it has. Is it taking extra space, or its time complexity has increased? So with that thing in mind, always write an optimized code. So guys, I hope so you would have understood how to move the zeros at the end of it. Now let's move to the next question. So our next question is of sorting. Okay, this is also a pretty interesting question, and we are definitely gonna learn something interesting and something new. So if I read the question, it says, given an infinite stream of integers, find the kth largest element at any point of time. We have a note here that we have a stream instead of a whole array, and we are only allowed to store only kth element. Suppose if someone asks you find the kth largest element, okay, so you would have some output and some input. So let me just explain to you what kind of input will be there and what kind of output we are expecting. Okay, so k is any parameter, you can consider it, k equals to 2, k equals to 3, and at the kth position, okay, for that problem, the k is not going to change, and if someone inputs the value of k, so your output for that stream of integers, the kth largest element should always be, coming out, you should always produce those output. As for something, I would like to tell you that this is not an array. This is infinite stream of integers. So how you can expect this as a problem? Suppose there is a data stream which is coming to you. Okay, consider a number of data. So each time a data gets added up in your array. So that is kind of an infinite stream of integer. Let us solve the problem and let's see what kind of approach do we have. Okay, so guys, like in this whole problem, what it is trying to say is, suppose these are the operations. Okay, so for every kth largest, when we are asking, there is an add operation going on. So this is our initial array, okay, and we are adding these elements. Okay, so basically what we are doing is, let me show you. Okay, so suppose this is our array, okay, and I'm saying that suppose in the input section I'm putting k equals to 3, and we have all our array as 4, 5, 8, and 2. Okay, so I'm asking which is the kth largest, which is the third largest element. Okay, so the third largest in this, as you can see, the highest one is 8, next one is 5, and the third one is the 4th. So we have to return 4. Okay, similarly, if we had added one element called 3, okay, so 4, 5, 8, 2, 3. So which is the third largest again. For every kth largest operation, we are adding one element. Okay, so here one element is added, like suppose here 3 is added. Now we are asking which is the third largest again. So the first largest is 8, second one is 5, and still our third largest comes out to be 4. So I'll be just, putting something like this. So the answer, what we are returning. So it's step 2, we return something like this. In the third step, one element again gets added, okay? Let's say it's 5, and our size of the array has increased, okay? Now, if I'm asking which is the third largest, okay? So it's 5, then 8, then 4. Okay, so third largest most precisely in this, if we are not considering the duplicate elements, okay, if we are even counting the duplicate elements, so there is no uniqueness, so our third largest would come out to be a 5. It could be either one of them. Okay, so that's one thing. Okay, so in this way we are expecting to solve the problem. Okay, so let me just give you an pictorial view. Okay, I hope so you would have got a brief idea about this problem. So let me show you one approach how you can solve this problem. That one is called min heap approach. Okay, let us create a minimum heap and store these elements, and we could pop out the element maintaining the relative order of the heap. So how you're going to maintain the heap? The size of the heap, okay, should always be equals to k. Okay, this one is pretty interesting question, so guys, please be with me. Okay, so now let's come up here and add the first element. Here is 4. Okay, since we are not satisfying the size of k, so we are going to add one more element, that is 5. Okay, 5 gets added here. Then we are adding the third element like 4, 5 and 8. Okay, now at this position we are satisfying our, you can say, somewhat the kth largest scene. Okay, we can find out, since our k is 3 here, so we can say we can find out the third largest because we have the 3 elements all over here. Okay, so what is our third largest element? It's 4. Okay, let's see this. Now let's go on to the next stage. Okay, for every kth largest, okay, we say we add one element. So here one element is added, that's called 2. So let's add it up, okay, since we are just ending our array. So you can see all over here that the size of the heap is not maintained. Size is not equals to the value of k. Okay, this is a scene here. So what we're gonna do, we are gonna pop the topmost element, okay, in order to maintain the relative size. So here we get 4, 5, 8. Okay, so our element returned as a kth largest is 4th. Okay, now let's add another element called 3. Okay, so here 3 is added, so our heap size is increased. It is not stable, so we're gonna pop the topmost element. So here this element, we're gonna pop it up. Okay, so after popping it up, our size of the heap becomes consistent. Okay, so we can say the kth largest element here, in this case return here is 4th. We are returning the topmost element, and at the same time we are popping up the topmost element in order to maintain the relative size of the heap. Okay, then we add up one more element called 5, 4, 5, 8, 5. Okay, so in this case what we are going to do, we are going to pop the topmost element in order to maintain the relative size. Okay, so now this gets popped up. Okay, so we can see here in this case, now the value of the kth largest element is changed, and our, in this case, the kth largest element is 5. So we are adding the element and our kth largest element is changing. So the value of k is consistent throughout the problem. So here our heap is 5, 5, 8. We add one more element, that's 10. Here 10 gets added up. Okay, okay, we have added 10. Now the size of the heap is changed and we have popped out the topmost element. Okay, here's a pop operation. So after popping up, our heap becomes 5, 8, 10. Okay, so what we are going to do, we are going to return the topmost element. So now again at this position we are adding one more element, okay, that is called 9. Okay, so I'll perform an operation, add 9. Okay, so our size of the heap is not consistent here, so we are going to pop up the topmost element. So our heap becomes 8, 9, 10. Now it says we have to add 4. Okay, so suppose we are adding one more element 4 here, but you should skip this because the answer would be same. Okay, 8, 9, 10, because if I create another picture, say here 8, 9, and here is 10, and here you say one more element comes up 4. So but ultimately, in order to maintain the relative size, we will pop up this, so which is pretty much not expected. Okay, so you can skip this up. So this was all the problem, and this was one of the approach how you can solve the problem for infinite stream of integers. Okay, suppose a data stream is coming up consistently. Okay, that's a hit populating your array. Okay, but every time you are asking the question, to your function that please return me the kth largest, and kth value is not changing throughout. You can fix k equals to 5, k equals to 4, k equals to 3, but once you have fixed it up, your value of k is not changing for that input. Okay. So let us delve into the code and let's see how we can solve this problem. Okay guys, so this is the code. Okay, so let us inspect this code and let's see how well it fits in our approach. Okay, as said, we are going to create a priority queue named PQ, and there are certain number of parameters I have taken like int, vector int, and gint. Okay, let's see the entire logic inside this function, what basically I'm doing. So I've set a variable, this is a global variable, so I've set it equals to k. Okay, so basically k is equals to the kth largest element. Okay, and I'm trying to traverse inside this array called nums. Okay, filling this element if pq dot size is less than k. Okay, so there is a one condition which I'm putting up. This is a very important condition. Okay, so suppose if the size of our heap, okay, say it was 4 and 5 and our k equals to 3. So if pq, if the priority key or the size of this heap is less than this, then only we have to push an element called x here. Okay, this code says something like this. Else if there's second condition which says if pq dot size equals to k, okay, and also x is greater than pq dot top. Okay, this is second condition, which means that, so in the last scenario what we found out that we had this 8, 9 and 10. Okay, this code demonstrates that scenario. It says that the size is equals to 3. Okay, our heap is maintained, but x should be greater than the topmost element, otherwise it's no point of pushing that element. Okay, we will be wasting the time performing the same add operation, because if we add 4 here, so what's the point on returning the kth largest? Our kth largest is not changing. So when our kth largest is not changing, we have to also give a condition here that if the element added should be greater than the top element, then only I'm going to push. There are true conditions. The first one was this, that the size should be less than, okay, and the second one was that the topmost element should be greater than the element added should be greater than the topmost element. Okay, now let's see the another operation which says that if pq dot size is greater than k. Now suppose we are in this scenario. Okay, suppose it was 4, it was 5, it was 10, it was 8. So this is a pop operation basically. Okay, so pop operation what's saying that if the size is greater than k, we are not maintaining the heap, so we are gonna pop the topmost element. Now I'm gonna say that add function is all over here. Okay, so in the add function what I'm passing a value parameter. Okay, so in this value parameter what I'm saying that I have to add the element. Okay, now I'm adding, suppose say our size is maintained all over here, and I have to add an element called 9. Okay, void add 9. So in order to add 9, I am passing this parameter called val. Okay, and I'm saying that if pq dot size is less than global was equals to k. Now I wanted that variable to pass on to this function also, so I just made it as equal to k, and I'm telling that if the size is less than the global is less than, then I'm pushing the value. Okay, basically, and if pq dot size is greater than global, then I'm performing the pop operation. So basically this was the same code which we have copied and pasted from here, but with different global variables. So same parameter of adding. It is pretty much easier this time to comprehend like how this addition operation is happening, because if you would go once again to that diagram, okay, let me just show you that in this scenario what's add operation, suppose 10 has happened. Okay, so in this we are saying that the size is greater than k. Okay, so we are popping it up. Okay, so two operations are happening at the same time. First kth largest is being called, and second one you have to add it. So adding a value or an element and popping up at the same time. Okay, so we are adding 10, 10 goes down. Now we are calling which is the greatest largest. Now here is a one condition that the size of this is greater than so pop operation is happening, which is written in the last code. And in this case, in order to add an element, so what we have written all over here in this code is this, that pq.size should be less than global. So push the value. If the size is less, okay, suppose in the add operation initially, so the size, basically the size of the priority queue, if the heap is also less, then you should add the value or push the value. Pretty much simple, guys. This was a pretty much easier approach and a good problem to understand. So what at the end of the day, what I would suggest you, that sit up with pen and paper, okay, try to solve at least 5 problems in a day. And when you are trying to find an approach or trying to go for a hit and trial approach, it's pretty easy, it's pretty good. I would say it's very good to make mistakes, but it's not good that if you are not trying. So just seeing the solution won't solve your problem or won't give you a way of analytical thinking to solve a problem. Solve as much problem as you can, but try to solve by yourself. Then you will figure it out what is the optimized way to solve the problem. So these were few of the interview questions, some of the mid-level interview questions, which was asked in the interview. I hope so you would have got a fair idea how to solve a data structure interview questions, which was kind of a hands-on one. Okay, so these were the code.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.